Hey everybody, this is Salar and you guys are welcome to Smart Code and this brand new exciting course on C Sharp. This is the first video of the course and in this video I will give you course introduction and you will get to know some very important features of this course. So don't miss this video and watch this to the end. Now, the first feature of this course is beginner friendly. You don't need to have any prior knowledge of programming before taking this course. So this course is totally for beginners. The next important feature of this course is lectures. This course is entirely divided into several lectures and each and every lecture of this course is important. You are not allowed to miss any lecture. All the lectures are numbered and you are advised to watch them in the same order you have them on the YouTube. Another interesting feature of this course is problem solving and exercises. Throughout this course, we will be learning different C# tools and at the same time, we will try to apply different tools to solve problems. I think this is the most important feature of this course. You will not only learn different tools or the syntax of the tools, you will also learn to code them and apply them. You need to remember one thing, programming is a practical subject and to learn a practical subject, you must do practicals. You must experiment with the subject. Without doing, we can't learn practical subjects. So in our course, we will be doing practicals. We will experiment with the code we learn and you are advised to do the same. Write the code, create some variations so that you get better understanding. Now, the last thing is do not forget to like, comment, and subscribe. I am your teacher in this course, and my name is Salar Askazala. To create such courses requires time and effort. And if you want to show me your appreciations, you can simply like, comment, and subscribe my channel. Now I will see you in the first lecture of this course, and I hope you will learn a lot about programming and your journey would be wonderful. Thanks for watching. I will see you in the next lecture. This is our very first lecture. And in this lecture, you are going to learn some important facts about the C#. I think it's important to get to know some facts about the language before you start learning it. So let's just handshake with the C#. You are here to learn C#. So the first question that you must know and must have the answer is, what is C#? C# is a modern programming language. The language is object-oriented by nature and developed by Microsoft. You might be thinking now, what is object-oriented programming language? This is the first programming term you are going to learn. Object-oriented is a language feature, and by using it, you can present real objects, real world objects to the computer. For example, a person object, car object, employee object, etc. Right? So object-oriented programming feature is simply a technique to present real-world objects to the computer using the language. The second question we need to answer here is, why C#? When there are so many languages to learn, why would you learn C#? The answer here is, C# is almost everything. It's one language with many possibilities. Using C#, you can program any type of application, desktop application, web, mobile, games, cloud applications, and even electronic devices, Internet of Things devices. C# is a one language that can be used in different domains. However, this shouldn't be the only reason to learn C#. The language C# is also beginner friendly. That simply means the syntax of the C# is very clean, the code is more readable and structured. Another reason to learn C# is the language is highly demanded in the job market. C# and .NET developers are always in demand worldwide, especially in enterprise companies like banks, tech firms, and game industry. Right? So there are so many reasons to learn C#. Another interesting question we need to answer here is, why was C# created? So we need to know some historical perspective. The main reason behind the creation of the C# was to simplify low-level complexity and provide the developers a powerful application to develop softwares. Low-level complexity has always been a problem. Things like control over memory, processor, hardwares, creating multiple threads wasn't so easy before the C#. So C Sharp is actually designed so that you don't have to deal with low-level complexity like memory allocation, pointers, CPU register, creating manual threads, etc. So that was the main reason behind the creation of the C Sharp. You don't need to deal with the low-level complexity. You might have heard about the languages Java and C++. Java language introduced the simplicity in its syntax, whereas C++ has very strong features to code low-level applications. C Sharp actually combines the features of Java and C++. Simplicity is just like Java, and the powerful low-level features are like C++. However, the low-level features on the C++ are now more safe in C Sharp. Because in C++, you have to deal manually with the low-level complexity, whereas in C Sharp, everything is taken care by the language itself. And now the final question is what you will learn in this course. In this course, you will learn C Sharp step by step, all the basics. We will start with the installation of IDE. IDE stands for Integrated Development Environment. It's a program where we code. We will not only install the IDE, we will learn its feature and also learn how to use it properly. And right after that, we will learn to create cancel application, write a simple program, and run the application to check the output. We will then talk about the programming errors and how to get help. After that, we will learn how to output result and input data in the program. We will then talk about variables and data types. They are actually the building blocks of a program. After that, we will learn operators in programming, conditions, random object, date and time object, loops, collections, and methods. My roughly estimation is we need more than 60 lectures to cover these points, because these points or the concepts are further divided. For example, in operators, we have mathematical operators, logical operators, and relational operators. When we talk about the conditions, we have if statement and switch statement. And when it's time for the loops, then we have 4 different loops in programming. We have for loop, while loop, do while, and for each loop. So for every concept, we will have a dedicated lecture. So there are gonna be more than 60 lectures in this course. However, the programming doesn't stop here. After the basics, the next step is object-oriented programming. You know the term now, object-oriented programming. We discussed it in our very first slide. Object-oriented programming is also a programming paradigm. A paradigm means a way of coding. It needs different tools and approach. So a course on object-oriented programming with C Sharp will definitely be released after this course. So don't forget to take this course. Object-oriented programming is a realistic programming and it will take your programming skills to the next level. So my dear listeners, it is now time to wind up this lecture. We now know some facts about the C Sharp and are in a good position to start coding. In our next lecture, we will install the IDE, create a cancel application, and write our first program. I will see you there. Thanks for watching. In our last lecture, we learned some facts about the C Sharp, and it's now time to install and study the development environment. Integrated Development Environment, or simply in short IDE, is a program that facilitates the coding. IDE is an important programming term, so don't forget it. Write it down somewhere. IDE simply means an application that helps you to create other applications. An IDE is a complex program and it helps us in several different ways. The most important features of an IDE are we can create projects using the IDE, we can compile and debug our application or the code, and the IDE provides a way to organize our program files. These are the main features of an IDE which we use quite often while coding. Now the next thing is which IDE we can use to develop C# applications. C# is a Microsoft product and Microsoft has developed a dedicated IDE for C# development and .NET development. The name of that IDE is Visual Studio. Visual Studio can only be installed on Windows and Linux system. So if you are on Mac system, you can't install Visual Studio. There is another option, another IDE, and that IDE is JetBrains Rider. JetBrains Rider can be installed on both Windows and Mac, and you can simply develop C Sharp and .NET applications by using it. Mac system and Microsoft, they are not friends. Microsoft has simply banned the use of Visual Studio on Mac systems. Throughout this course, I will be using Visual Studio Community, but if you are on a Mac system, you will simply code in JetBrains Rider. I have already recorded a lecture on JetBrains Rider and C Sharp development. So if you are a Mac user, I would suggest you stop watching this lecture right here and take this lecture, download and install JetBrains Rider. Everything which I'm going to cover in this lecture using Visual Studio, you will find it here in this lecture. Coming back to the Visual Studio. Visual Studio is the name of the IDE and Community is a version which is free for learners and students. Let's start with the installation of the IDE. In a browser window or a tab, you will simply search for Visual Studio Community Download. Press enter. This is the first official link, Visual Studio Community. The latest version of Visual Studio Community is 2026 and here is the download link. Just download the file and start the setup. As you run the setup, you see the installation wizard where you can select, add or remove installation packages. As you can see, there are several packages to select, but to code with C Sharp, you only need one package, which is called .NET Desktop Development. You can also see the short description here. Using this package, you can build VPF, Windows Form, and console applications using C Sharp. Even you can use this package to code with Visual Basic, F Sharp, and other .NET related programs. So all you need to do is just select this package and click the install button. I have already installed this package. That's why you don't see the installation or the install option here. But on your computers, when you have fresh installation, you will see an install button here. Click on the install button and let the program install. Once the installation is completed, you are required to log in into the IDE. You can use any Microsoft account or the GitHub account to log in the program. The program will also suggest Copilot login, and I must say, don't log in Copilot. Copilot is a built-in suggesting AI. As a beginner, when you are learning the basic concepts of the C Sharp, you do not need Copilot. Copilot won't let you learn the basics. It will simply suggest you the solution and you won't be able to train your own mind, memorizing syntax and developing the logical thinking. So don't log in Copilot as long as you are a student and trying to learn the concepts. Now I suppose that you have successfully installed Visual Studio Community and here are the points we are going to cover. Create a console application, study the console application, write and run a hello world program. The windows you need to have open all the time while working with the C Sharp. We will also study the project files on the computer and finally you will learn to create multiple projects in a single solution. Let's cover all these points one by one. The first thing we do here is we will create a folder for our project file. You can choose any location on your system. I am going to choose desktop. On the desktop, I will simply make a right click and choose new. I have Swedish as a system language, so you don't need to be confused here. What I'm doing here, I am trying to create a new folder. This is a folder and I'm going to name this folder C Sharp codes files. That's it. So this is our code folder and we will create all the projects inside this folder. Now we will open Visual Studio, which is, I suppose, you have already installed. So click on the start and search for the Visual Studio. Here it's the Visual Studio. Don't run the installer program. It will start the installation wizard again. This is the program Visual Studio. Click on it. When you start Visual Studio, so this is the first window we usually see where we have four different options: create a project, open a folder, and clone repository. We will need to choose the first option, create a project. Whenever you code a program, you need to create a new project. This is how it works. So click on create new project. You will be diverted to the project templates window. From this templates window, you will select cancel application, but you have to be careful when you are selecting the application because cancel applications we have in different flavors. Here is the search bar. For example, we can filter out and search only for the cancel applications. So here you see there are different flavors of cancel application. What we are going to select is the first one, which is an application for the C Sharp. As you can see, the C Sharp logo here, and this is an application for the Visual Basic. Down there, we also have a cancel application for C Sharp, but this is for only Windows. The first cancel application where you see Linux, Mac, Windows, and console is a .NET Core application. Program written in this application can easily be run on different platforms like Linux, Mac, and Windows. So select this application and click on the next button. Now here we are going to name our project. Here we have three different options. The first option is the project name. Let's say we are going to put a name, hello world, like this, no space between the characters, just have a single text. And now here is our save location. You remember we created a folder on the desktop, so we are going to save all our projects in this folder. Here you see the browse button. Click on the browse button and navigate to the desktop. On the desktop you will find a folder. Here we have a folder, course files. Select this folder and click on the select folder, and here is the solution name. Solution is actually folder of the project. Visual Studio will automatically create an outer folder and put all the files, project files, inside this folder. Most of the time we create a single project in a single solution, so we don't need to change the name of the solution. But sometimes we need to create multiple projects in a single solution. So in that case, we can name our solution differently. Now, for example, we are working with the variables and data types, and we have different types of data types. For example, integer, string, and we want to create different projects for the variables. So we can, for example, name our solution variables. Now, inside this folder, we will create multiple projects. Every project will also have its own folder, and this will also become a folder, the outer folder. We will also look the project files on our computer. So this is how we name our project. This is our project name. This is the save location, and this is the solution name, which is the outermost folder. Now we're going to click the next option. It will take us to another window where we can select the .NET version. .NET 10 is the latest version, and you will always try to use the latest .NET version. .NET, as you can see, is actually a framework, and C# works inside this .NET framework. Down there, we have two checkboxes. We do not need to check them. We will work with the top level statements. We will discuss about the top level and without top level templates later on in our course. So that was the final window, and it's now time to create. Click on the create button and you will see a brand new cancel application project within a second. So my friends, I must say congratulations, we have created a brand new cancel application project. What we see here is a program.cs file, which is a code file. We write our code inside that file. This is a comment. We will discuss more about the comment later on. And here is a command that print the text in the cancel. The comment we can remove simply. We don't need to have comment. And this command will simply print the hello world text in the cancel. We have a separate lecture on WriteLine method, which belongs to the cancel class, so you don't need to worry about it. The first thing here we are going to learn is run the application. But before that, let me just put another console .WriteLine here and put some text here. You can put whatever you want. I am writing here, we are learning C sharp. And now, in order to run the application, you see this green play button, and here you can also see the name of the project. So to run the project, you only need to click on this button. It will take some time because it is the first run, and you will see the output in a console window, the black window. And here you see the output of your program in the console. As you can see, the text hello world and another text, we are learning C sharp. The program is running at the moment. To close the program, we only need to close the console window. So click the close, and now the program is exited. Let's move on. Now we will talk about small windows we need to keep open all the time. As you can see, there are some windows. Here we have an error window. Here we have a solution explore window. And here comes even a toolbox window, which is actually used with Windows Form and WPF applications. So we don't need this window. I am going to close all these small windows. We will learn to open them one by one. Here is the Solution Explorer. There is a cross button. Let's close it. This is a Git window. Close it. We don't need it. Toolbar. Toolbox. And here is the error window. Right? Now we have closed all the windows. To reopen the windows, we will go inside the View menu. And here you have all the windows you need. The first window and the most important window you need to keep open all the time is the Solution Explorer window. This window just tells you about your project and the project files. Now here you can see our solution name is variables, and inside that solution we have a single project, and the name of the project is hello world, and this project contains a program.cs file. When we click on the project, the program will automatically open the project configuration file. You don't need to change anything here. Just close the configuration file. Now, the program.cs file is a file where we write code, and here you see program.cs file. CS simply means C sharp. So, Solution Explorer is a window that you need all the time. Now, another window, very important window, is the error window that shows the error in our code. And to open that window, we will go back again inside the View menu, and here we have an error list window. Just click on it, and now you can see the window is to the bottom of the page or the program. Now, for example, let's just create an error in the program. I'm going to remove this semicolon, and now you will see an error in the error window, and it says semicolon affected. This window is advanced, and when we double click on the error, we usually divert it to the line where the error is. Now, for example, let's say I am here right now, and now I double click on the error, and you can see I am diverted to the line where the semicolon is missing. Now I can put back semicolon, and the error is gone. So whenever you have error in your program, I would suggest you must consult with this error window. All the windows have pinned and unpinned feature. As you can see, auto hide. You can just turn the auto hide option, and your error list window is now down there. When you click on it, it will come forward, and when you click outside of the window, it will hide itself. So if you need, for example, more space here when you write your code, so you can hide this window. The same is here. Here is the Solution Explorer. You can hide it just by turning the pin to the other side. Let's do that. Now you can see your Solution Explorer is here. It's hidden. Just click on it. It will come forward. And when you click outside of the window, it will hide itself. Right? So these are the two windows you need to keep open all the time while working here with the code. Let's now move on, and now we will investigate the project files on our hard drive. So on the desktop, as you know, we have a folder, C# course files. Just go inside the folder, and you will simply find a variables folder. You remember what I told you? When we created this project, I said solution would become the outermost folder. So you can see the name of the solution is variable, and this is the outermost folder. And inside the solution folder, we will have our hello world project folder. So let's go inside the solution folder. So here you can see your hello world project folder. This is the solution file. If you want to start your project from the hard disk, you can simply double click on this solution file. Now go inside the project folder. You will see all your project files. Here you have your binaries, your object file. This is your project file, and this is a program.cs file that you see here. This is where you write your code. So that was your project structure on your hard drive. So let's close this folder. Coming back to the Visual Studio community. The last point on our list is how to add multiple projects on a single solution. So here we have a single solution named variables, and it has only one project. To add another project, you will simply right click on the solution name, right? You won't right click on the project. You will right click on the solution name. Then you will select add option and then new project. It will simply start the new project wizard from the beginning. So click on the new project. Now you can see you have the opportunity to select the cancel applications. Let's select the cancel application, click next. And now you're going to name your project. For example, in the variables, we are learning integer. The location will be automatically in the variables folder because we are adding a new project to an existing folder. So we don't need to change anything here, and our project will automatically be added to the solution variables. Just click on the next and then create. Now you can see we have two different projects, hello world and integer, and both are inside the variable solution folder. Once we have multiple projects in a single solution folder, we need to make one project a startup project because we can only run one project at a time. As you can see, the project hello world, the text is bold. That simply means hello world project is a startup project. To make another project a startup project, you will simply right click here, and here you will search the option down there, set as a startup project. Now you can see the second project, the text integer has become bold. That means this project is a startup project. At the same time, you can also make the project a startup from this small pull down menu. As we add multiple projects in a single solution, this small pull down menu appears automatically, and here we can choose which project to run. When you run the program, you will simply see this output in the console. We now have two program files, one program file for each project. As you can see here, this is our first project and this is our second project. So my friends, that was a detailed lecture on IDE, Integrated Development Environment, how to create console application projects, how to run the project, and how to add multiple projects in a single solution. Now we are in a good position to start to learn coding. We won't stop now. We will learn, and learn. In the next lecture, we will learn to use this WriteLine method. I will see you there, and thanks for watching this lecture. In the previous lecture, we installed the IDE, Visual Studio. We learned to create cancel application. We learned to run the application, and we talked about some important features of the program. Let's move on. It's now time to learn to code the WriteLine method. WriteLine is a standard output method, and when we write console application, we use this method almost all the time. Let's first learn the syntax of the method and then we will talk more about it. In order to call the method, we start with the console, and right after that, we call the WriteLine method, and after the WriteLine method, we put two small parentheses, and then we terminate the statement using the semicolon. In C#, a single line statement is always terminated with the semicolon. If you miss the semicolon, the program will simply show a compiling error. As you can see here, semicolon is expected. Now to the method, inside these two small parentheses, we can pass the arguments. For example, I am passing a hello world. This argument, which is actually a text, will be printed in the console window as we run this program. So let's run the program and check the output. And so you see the output in the console, right? Hello world. Now we will do a simple dissection of this line of code. We are going to use it a lot in our coming lectures. So you need to understand what we are actually doing here. So WriteLine is a method. It's a predefined method. We have this method in the .NET. How do we know when something is method or not? Answer is very simple. Methods in programming. I'm not only talking about the C# here. I mean methods in programming. In all the programming languages almost have the same syntax. And what is that syntax? The syntax is a method must has a name, for example, WriteLine, and right after the name, method should have or must have two small parentheses. As you can see here, WriteLine with two small parentheses. Inside the parentheses, there can be an argument or the parameter or not. It depends on the definition of method. Some methods receive argument and some do not. So WriteLine is a method, and now we know how to recognize a method in programming. A method has a name, and right after the name, you will see two small parentheses. Now the next thing here is the console, and in between console and WriteLine, we have this small period or the dot. This dot is not a full stop. It is actually an operator in programming, which is called dot operator. And this operator is actually used to call something with reference. What we are actually doing here, we are calling this WriteLine method with the console reference. Now, what does reference mean? It simply means this method actually belongs to this console object or the class, and it cannot be called without the reference. This method is totally dependent of this console class. At this point, when we are at very initial stage of programming, it would be very difficult for us to understand the concept of the class. Classes are used in object-oriented programming. But I can simplify this concept for you until you start learning the object-oriented programming after this course. As you see the diagram on the screen, a class is just like a box that provides services. Class contains methods and properties and other things. So in the diagram, you see a console class box where you have some methods, for example, WriteLine, write, ReadLine, etc. These methods are confined inside the console box. And that's why in order to call them or in order to use them, we need console reference. This is what we are actually doing here. We are actually taking out the WriteLine method from the console box. That's it. I hope now you have better understanding of this line of code. Console is a class and WriteLine is a method which is inside the class. Let's move on. WriteLine method has an important characteristic. It actually puts a new line in the console. And what does it mean? Let me show you with the help of an example. We are going to have another console WriteLine like this. And here I'm going to write a text. Today is Saturday. And another console WriteLine. I have a party like this. As we run the program, you will see the output is distributed over 3 lines. So let's run the program and study the output. And so you see the output, right? The output is actually distributed over 3 lines. And that is what I tried to say. WriteLine enforces a new line in the output. The first WriteLine will simply print the output, hello world, and then send the cursor to the new line. And the second WriteLine will simply start printing the output from the second line and then send the cursor to the next line, and the third WriteLine will do the same, print the output and send the cursor to the next line. And that's why you see an empty line here. That was an important characteristic of WriteLine. It actually enforces a new line in the console. And here we can have another example. We can also call empty WriteLine method like this without passing any argument. Now you can see the WriteLine method can take argument. Here is a text argument, and here we are calling the method without argument. So this line of code will not print anything. There is no argument inside the parentheses, but this line of code will simply enforce or put a new line in between these two write lines. So let's run the program and see the output. Now you will see an empty line in between. And so you see the output, right? You see the empty line between these two write lines. That is the empty line. It was an important characteristic of the WriteLine method. Instead of WriteLine, we also have a method which is only write. And now you can guess what this method do. It prints the output in the console without inserting a new line. Let's check it out. 1, 2. As we run this program, you will see the output 1 and 2 on the same line, on the same row. So let's run the program and check the output. And so you see the output in the console, right? 1 and 2. There is no new line in the output. So my friends, that was the WriteLine method we studied in this lecture. WriteLine is a standard output method in console applications. It's now time to wind up this lecture. In the next lecture, we will learn the use of the escape sequences. I will see you there, and thanks for watching this lecture. In our previous lecture, we talked about the WriteLine method. And like I told you at the end, we would cover escape sequences in this lecture. Let's move on and learn the use of the escape sequences in C#. Now, the first thing first, how do we define escape sequence or sequences? Using escape sequences, we can insert visible and non-visible characters in our output or in our text, which we cannot insert directly because of the syntax or the other restrictions. So that is the definition of escape sequences. And to apply our escape sequence, we use backward slash. You will see several examples in this lecture and get more understanding of it. Now, there are 4 escape sequences that you need to know, and those sequences are double quotes, tab, new line, and slash, backward slash itself. Let's jump into the code and learn to code and use the escape sequences. Here we have a code from the previous lecture. Let's remove the code. And our topic here is escape sequences. So I can simply put a comment, escape sequences, and the sequence character is backslash. Escape sequences are applied using the backslash. Now the first escape sequence we are going to learn here is double quotes. As you know, double quotes are already reserved in C#. For example, we simply write a text in the console. We are learning C#. As you can see now, the double quotes are actually the part of the syntax. We cannot print this text without the double quotes. If I remove the double quote, as you can see here, our program simply complains double quotes are expected. So let's put them back. Like this. You have also noticed one thing, these double quotes are not shown in the output. So what if you want double quotes in the output? You cannot simply put the double quotes inside the string. Now let's say I want to put double quotes around this word learning. So I cannot simply put a double quote like here and like here. Our program is complaining. You know the reason why the program is complaining. Double quote is a reserved character. It is actually used to mark the beginning and the end of a text. So to get our code working, we need to escape these double quotes. And for that, we use escape character, which is a backward slash. So right before the double quotes, we wanna escape. We will put a backslash like this. And here we have another double quote we wanna escape. So we will put a backslash right before the character. Now you can see the error is gone, and we usually say we have escaped a character. As we run the program, you will see the word learning has double quotes around it. So let's run the program and check the output. And so see the output, right? Double quotes around the word learning. So that was the first skip sequence, which is double quote. Let's move on. The second one is tab. Tab sequence is used to insert a tab space in the text. A tab space is usually a combination of 8 spaces. For example, if you want a column like output, then you can use tab sequence. Let's have an example. Let's say we have a column 1, column 2, and column 3. Now we want to put a tab space between the columns. We will start with the escape character, which is backslash, and now we will put the tab character, which is E. And we will do the same backslash T. Let me just copy and paste this line of code like this. Now you will see a beautiful table-like output in the console. So let's run the program and check the output. And so you see the output in the console, right? So here we have a tab space and here we have a tab space. You can also add multiple tab spaces. Now, for example, instead of one tab space, I'm going to insert another tab space, right? Now we have 2 tab spaces in between the columns. Here we have a typo. Let's run the program and check the output. Search the output, right? 2 tab spaces between the column. The third escape sequence is the new line sequence. New line sequence is used quite a lot in programming. We use it to modify the result so that our result become more presentable before we present it to the user. Now, for example, we have a result in our program like this. So this is the result and we wanna present it to the user or publish it somewhere. So we can insert the new line to make it more presentable. So right after the name property, I will once again use the sequence character backslash, and for new line, we use M. And before the profession, I will do the same. Now in the console, you will see the output is simply distributed over 3 rows or 3 lines. After the first property, name Salar, a new line is inserted. After the age, new line is inserted, and then comes profession. So let's run the program and check the output. And so you see the output in the console, right? The result is more presentable. Now, the third and the last one is the backslash. As you know, backslash is already reserved, right? Backslash is used to insert the sequences. So how do we insert a normal backslash in our text? There are so many occasions where we need a normal backslash. What we actually do, we use a backslash to escape another backslash. That's it. Now, for example, I have a path in our program, and from that path, I wanna read a file. So that should be the path. ABC text is a file which I want to read in my program, and here is a path. Then we write the path, we use backslashes like this. So as the backslash character is the reserved character, program thinks we are trying to apply a escape sequence. For example, backslash u, and backslash u is not a valid escape sequence. That's why you see an error here, unrecognized escape sequence. So we need to tell the program we are not applying a escape sequence. We simply want to use a backslash in our code. So we need to escape the backslash like this throughout in our path. That's it. So backslash is now escaped, and you will see a normal backslash in the output. So let's run the program and check it out. And so you see the output in the console, right? So my friends, that was a lecture on escape sequences, and now we know how to code them and use them. These four escape sequences are important one, and we will use them in our coming lectures. It is now time to wind up this lecture, and in the next lecture, you will learn to work with the comments. We will see how do we put comments and what are the role of the comments in a program file. I will see you there. Thanks for watching this lecture. In our previous lecture, we learned the use of escape sequences, and just like I told you, we would cover comments in this lecture. Comments in a program file are absolute necessary. You as a programmer will develop an habit to put comments on your code. Short and descriptive comments help others to understand your code. So let's move on and learn to put comments in C Sharp. We will also discuss the best practice. Later on in this lecture, we will also see comments are amazing tool to debug code and find errors. So in C Sharp, we have three different types of comments. We call them single line comments, multi-line comments, and XML documentation comments. First two types are common, and the last one, XML documentation, is actually for industrial development of softwares. I will show you all the three types one by one. So let's move on. So here is a code from the previous lecture. Let's remove the code and change the topic. Our topic here is comment. Now I will write some code which we did not cover yet. The only purpose here is to show you the proper use of the comments, the best practice. So you do not need to focus on the code. You only focus the use of the comments on the code, right? So here we have initial settings for any applications. For example, let's just suppose in an application, we have some initial settings, login attempt, username and password. And above this line of code, we can put a single line comment that simply tells the purpose and the usage of these variables. A single line comment is put using the double forward slash. You can see an example here, and you've already seen several examples in the previous lectures. So this is a single line comment, and everything we write after these two forward slash should be considered as comment. Compilers does not process the comments. Comments are totally ignored. They are for you, for me, for others. Now here we can write initialize system login variables. So you see a short and descriptive comments for all the variables. You do not need to have a single comment on each line. For example, like this, creating login attempt counter variable, or like here, creating constant username variable, right? So you don't need to put comments like this. It's not a good practice. Try to put a single comment, descriptive comments above the code. So this is how we put single line comment. If you want to put another comment, then you must start with the forward slash once again to put another single line comment. Now I'm going to write another piece of code where I will use multi-line comments. Now, for example, we have a method that calculates the revenue. What you see is a method in programming, and we will cover methods later on in our course. And this method, as you can see, the name of the method, it calculates the revenue and receives a parameter. Now, above this method, we can put multi-line comments to tell more about this method and its functionality. Multi-line comment has different syntax. We open the comment with forward slash and asterisk like this, and then close the comment with asterisk and forward slash. Now, what you see here is a multi-line comment, and it can be stretched over several lines. As you can see, I am pressing enter, and whatever I write in between is actually considered as multi-line comment. For example, row 1, here we have row 2. As you can see, all the rows or all the lines are considered as comments. So multi-line comments are used to provide or to document more information, detailed information about the code. Now, for example, for this method or for this code, we can write this block of code calculates the revenue based on the gross income. Another line This method is for quarter calculations. So this is how we use the multi-line comments. Just remember the syntax. Now the last one is XML documentation comments. And like I told you in the introduction, they are the special one. XML comment uses the XML tags in order to document or describe the different part of the code. The compiler can easily extract the information using the XML tags. You do not need to use XML comments as long as you are learning. But if you are working for some company, you are developing commercial softwares, then there can be a requirement to use XML comments for the documentation purpose. Let's have another piece of code. Let's say we have another method which is called add. This method will also return something, and we'll take two parameters, number one, number two. It will simply add both numbers and return the result. Now I want to document this method using the XML documentation comments. I will come right above the method. Now instead of 2// I will type 3// 1, 2, and 3. And here comes the summary tag. In the summary, we write the summary of the method. For example, this method adds two numbers. And now we are going to close the summary tag like this. We can also document the parameter. There are some predefined tags in the XML like this. Parameter tag, XML tag is for the parameters. For example, the name of the first parameter is number one, and this is the first number. We can duplicate this line of code even for the second parameter, which is number two. And we also have return tag, and here we can put the sum of two numbers. As you can see, this comment looks special, right? So my friend, that was the first part of the lecture, how to put comments and use them wisely. Like I told you in the introduction of this lecture, comments can also be used for debugging and error searching. They are great to use. So what do we usually do? Using the comment, we can switch off a single line of code or a block of code so that we can focus only the problematic area. Now, for example, I just want to focus on this piece of code, and I know that this one is working fine. So I can simply switch off this entire piece like this and switch off this entire piece like this. Now I can only focus on this method. If I run the program, the compiler will totally ignore everything here, right? They are commented out. Compiler will only focus on this piece of code because this is the active one. You might be wondering now, how did I manage to comment out several lines of code at once? I actually used key combination, and I believe every programmer today use key combinations to comment and uncomment the code. Let's have a look. I wanna uncomment the code. I will select the code, use the key combination, and now the code is uncomment. I wanna uncomment my variables. I will use the key combination, and the code is uncomment. So let me teach you the key combination. The first one is for comment out, and the second one is for uncomment. For comment out, we use the key combination Control K plus C, and for uncomment, Control K plus Q. Very simple combination, Control KC and Control KU. Let's do some practice. Now I wanna comment out this first line, this single line of code. I will put my cursor somewhere on the line. For example, at the end of the line, and now I will press and hold the control key. I will keep it pressed all the time. So here I press the control key. Now I will press and release K and press and release C. As you can see, the line is commented. Same I will do with the username line. I will press the control key and I will keep it pressed all the time. Then press and release K and press and release C. The line is commented. To uncomment the line, I can do it one by one, or I can simply select both the lines. Now I will press the control key, keep it pressed all the time, press and release K and press and release U. As you can see, both the lines are now uncommented. So this is how you can use these shortcut keys to comment and uncomment very fast. Now, for example, if I do not use the shortcut keys and I want to comment out this method, one option here is I will put manually single line comments on each line, as you can see here, right? And to uncomment manually, I need to do the same process in reverse order. It's simply a time-consuming method, even though we have 3 lines, but it felt a lot. Another manual option, which is much better than the previous one, is you can use multi-line comments to comment out the entire piece of code. For example, we start the multi-line comment from here, and then we'll go down, and here we will put the closing comment. Now the piece of code is totally commented out. The best way here is to use the key combination. Just select the piece of code like this and press the control K C, comment, and control K U, uncomment. That's it. So my friends, that was a detailed lecture on comments. Now we know how to put comments and how to use them wisely. In the next lecture, we will talk about errors in programming. In programming, errors are categorized in 3 categories and we will look closer to them. I will see you there, and thanks for watching this lecture. In our last lecture, we talked about comments. We learned how to put comments and the role of the comments in a program file. And I told you we would cover programming errors in the next lecture. And this is the next lecture. So let's move on and talk about programming errors. In programming, errors are categorized in 3 types or 3 categories. The first one is compile time error. The second one is runtime error. And the third one is logical error. So these are the 3 types of errors in programming. In order to understand the first 2 types, compile time and runtime, you need some background. You actually need to understand the compile time and the runtime. Together, they define the life cycle of a program. We will start with a very important term, which is called compiler. You remember when we installed the program Visual Studio, we chose a package called .NET Desktop Development. That package actually comes with a very special program which is called compiler. Every programming language has its own compiler or interpreter. They are very special programs. As you can see the definition of a compiler on the screen, a compiler translates the source code into low-level language like binary language or the bytecode so that the computer's hardware can execute the code, right? So compiler is actually a translator. While compiling the source code, compiler does some analysis. We are not diving deep into it because compiler does a lot of different things. But one thing that we need to know is syntax analysis. Every language has its own syntax and it's a compiler's job to find out if the syntax used in a program file is correct or not, right? So syntax analysis is the compiler's job. As we know some facts about the compiler, we can discuss the life cycle of a program. A computer program goes under 2 different phases: compile time phase and runtime phase. Whenever we run a program, it starts from the compile time and then enters into the runtime. In the compile time, compiler involves itself, translates the source code, and checks the syntax. After the successful compilation, machine code is handed over to the computer's CPU for the execution. And so you see the output of your program. That simply means your program is running, and this period of time duration is called runtime. Runtime simply means your program is running, and after runtime, you can terminate your program. So a program's life cycle is from compile time to runtime and then termination. Now we know the difference between the compile time and runtime. Let's go back to our first slide. we have compile time errors and then runtime errors. Compile time errors are shown or displayed under the compile time, and runtime errors are thrown under the runtime or execution time. When your program is running, you will get the live demo of compile time, runtime, and logical errors. Let's jump into the code. Here is our code file. You see the code from the previous lecture. Let's remove the code and change the topic. Errors in programming. The first error we are going to discuss here is compile time error. And I need to activate my error list. We are talking about errors. We need to consult with this error window. So compile time errors. Compiler shows such errors in the compile time. That means before the program is executed. If you have compile time errors, you cannot run the program. Your compilation won't be successful. Most of the time, compile time errors based on wrong or incorrect syntax. Let's have a couple of examples on it. We are using a simple WriteLine method with an argument, text argument hello. This line of code is perfectly fine. There is no error in it. Now I remove semicolon, which is a part of the syntax, and here you see the error semicolon is expected. The same way I can remove this double quote. You will see the error, double quote is expected, or something is wrong with the code. Programming is case sensitive. That means we do not change the case of the letters. For example, this C is capital or in the uppercase, we cannot write in the lowercase. Now you can see the console does not exist, right? So we need to be very careful and respect the language syntax. Now, like I said, compile time errors are detected under the compile time. Now, for example, I once again remove the semicolon and you immediately see the error in the error window. We have an advanced IDE and it actively checks the syntax in the code file. But if you try to put our program in the compile time phase, it won't compile because of this error. So let's try to run the program, and this is the compile time phase. And here comes error notification. There is some error in our code and we don't wanna compile our program. So let's put the semicolon back. Let's have another example. I create a number variable and assign it a value n. And somewhere in the code file, I once again create the same value and assign it another number like this. Now, this is also a syntax error in the programming. We cannot create a same variable twice in a code file. And here you see the error in the error window. A local variable named num is already defined in this code file. Our code won't be compiled if I try to do so. So let's run the code and you will see the error notification, right? That was the compile time error. The second type is runtime error. Runtime error, as we know, are thrown when the program is running. Something happens that program cannot tackle or handle. Let me show you a couple of examples of runtime error. I will write some code and you won't consider code so much. Our focus here should be on having good understanding of errors in programming. Let's say I want to read a number in a program when the program is running. I will write a line of code like this. We will cover all these things in our coming lecture, but I can shortly describe what is happening here. Using the read line, we can read data from the console. Console is a black window and we see that window when the program is running. So we are reading data from the console. We are converting the data into the integer numbers, and then we are assigning that data to this variable. If I run the program now and try to give this readLine method something else other than the number, our program will simply crash. So let's run the program. This is a compile time phase. And now you see the runtime, right? So we are now in the runtime phase. You see this black window, console window. And now I will assign something which is not a number. Let's say ABC. Now press enter. and you see an exception error is thrown by the program, and that simply says the string ABC cannot be assigned or converted to this integer format. This error is unhandled and our program is now totally halted. Please, we cannot do anything. We must terminate the program. So that was an example of runtime error. Let me show you another example. For example, we have an array of numbers that contains several numbers like 1, 2, 3, 4, 5. We will cover array and its different types later on in our course. You don't need to worry. So numbers is an array which have 5 components, and every component has an index value. Using that index value, we can access the component. Index values start always from 0. So 1 is at index 0, 2 is at index 1. This is how it works. We will discuss more about it later on. Now I want to let the user choose a number to print, and user will simply insert a index value. The valid index values are from 0 to 4. So let's create a variable like this, and once again we will read a value from the console like this, and we'll insert the value inside the number array. Now what will happen as we run the program and provide a value which is invalid, index value which is invalid, our program will simply crash and we will have a runtime error. Before we run the program, so let me just deactivate this read line. Now run the program. We know the valid index values, and I am going to provide here, let's say 10. This value is invalid. Our program is running. As you can see, this black window. Let's press enter, and you can see once again an unhandled exception. And it says index was outside the bounds of the array. That simply means index is invalid and it does not exist in this array. So we must terminate the program. So that was the runtime error in programming. And the last one here is logical error. You can guess what that can be, right? Logical error is actually an error in your logic. These kind of errors are very typical and difficult to remove and fix because you don't see any error. What you see is wrong calculation or wrong answer. Let's have a very basic example of a logical error, and we write an expression like this: 10 plus 40 minus 34 multiplied by 5 plus 9 divided by 3. Right now, our program will solve this calculation as we do in mathematics. We also have same priority rules in programming. Our program will calculate this one first. Right after that, our program will calculate this one because multiplication and division have higher priority than addition and subtraction. After multiplication and division, our program will perform addition and subtraction. But if I enclose some of them in the parentheses like this, the result must be different. Now our program will produce the different result. It will solve the parenthesis first, then multiplication, then division, and in the last it will do addition. So logical errors are actually errors in your program logic. They are hard to find and fix, but there is a technique which is called debugging. Using the debugging technique, we can walk through our code step by step. We can read what is happening, what is changing and updating in our code. We will cover debugging technique later on in our course. It really helps to find and fix the logical errors. So my friends, that was a lecture on errors in programming, and now we know in programming there are 3 types of error: compile time error, runtime error, and logical error. We also learned some important terms in this lecture like compiler, the role of the compiler, compile time, runtime, and the life cycle of a program. It's now time to wind up this lecture, and in the next lecture, I will give you some important tips to code and use this program file. The program file has some important features, and by using them, you can program more effectively and enhance your productivity. I will see you in the next lecture of this course. Thanks for watching this one. So the previous lecture was all about errors in programming. We learned important terms like compiler, compile time, runtime, compile time errors, runtime errors, and logical errors. In this lecture, like I told you before, we will be learning some important features of this program file. So here is a code from the previous lecture. Let's remove this code, and our topic here is productivity scripts. That simply means to use some features of this background file to enhance your productivity. All the tips which I will give you in this lecture, we programmers use them all the time. They are very useful and you will love using them. The first step here is console write line. As you can see, there is some effort when we write console dot write line, but you do not need to write it manually. There is a shortcut, and the shortcut is CW. As you write CW, you see this suggestion window, and CW is actually represents console dot write line. You do not need to use your mouse pointer. You can simply write CW and then press enter, and you have console write line on your screen or in your code file. So that was the first thing. It's quite easy and useful shortcut. CW, console write line. Now the second tips which I want to give you is tab completion. You may have noticed when we write code, our program engages suggestion. For example, when I write console and I just write WR, so here comes the suggestion. As you can see here, it's gray text. Now I can complete this. I want this. I can complete this if I press my tab key twice. Let's do that. Here you see I press the tab key twice and now the suggestion is completed. So tab completion is also an important feature. Just press the tab twice if you wanna accept the suggestion. That's it. Another very useful feature of this program is the light bulb. We don't see any light bulb here, but when we start coding and have some more advanced language features, you will see several light bulbs in your code file. Light bulbs are actually for more advanced suggestions. So let me just put a comment here. Light bulb. Now I will simply write a method without any definition. The method name is addition and it takes two numbers. Let's provide numbers. And as the name suggests, this method will simply add both the numbers. So I am calling a method without defining it. Now here you see the light bulb, right? And we also have the error. It says the name addition does not exist. We know that the method is not defined, but we can use this light bulb to see the suggestion. Now, when I click on the light bulb, here comes only one suggestion. Do you want to create the method addition? If I accept it, so here you see method definition, or you can see the method skeleton is actually created. And now we can, for example, further adjust the method and publish the addition result like this. Lightbulb is actually for more advanced suggestions and it actually appears whenever it is required, right? The program will automatically put the light bulb on different places. Another feature which I want to show you is go to definition, and that feature is very important, especially when you are working on big projects. So the name of the feature is go to definition. Right now we have a very simple program file. We have a method and here is the definition. The definition of the method is right under the calling. So if I right click on the method, here I will find option go to definition and it will divert me to the definition or the exact location of the method. So let's press this button and here you see I am diverted here. This feature go to definition might seem useless in this program file. Let me show you another program. Here we have another program and here you see it's a project with several different files. Here we have our main program.cs file and this is how the code looks in a project, right? And we have class libraries here and here we also have a class library. In the logic library, we have several classes. As you can see here, we have a car class, we have a config class. If you go inside the config class, so this is how the code looks inside the class. Here we have a property which is called number of places. The program is written in the Swedish language, but I can translate it for you. This simply means number of places. Now we see the number of places in the program file. Somewhere we will see the use of the places. Here we are calling the property number of places, and this property is actually inside this config.cs file. Now I want to see the definition of this property and where it is coming from. I will simply right click and then select go to definition, and our program will simply take me to the exact location where this property is defined. Now you see the usefulness of this feature, especially when you are working with large projects. This feature gonna save your time and energy. We can stay here in this program file because the next feature I am going to show you is also related to the go to definition feature. We can also open a peek window here in the program.cs file that shows the definition of this property. All we need to do, just place your cursor on the property or on the method or any other object, and then press the Alt key and F12 at the same time, and you will see a peek window. You can see this property is coming from config.cs file, and this is the actual definition of this property. Alt key, press the Alt key and the F12 key on the keyboard, and you will see the peek window. After go to definition, we learn the peek window, which can be opened using the Alt plus F12 key. Now, number 6, we have indentation. Indentation means the placement of your statements and the use of the white spaces. For example, the parentheses are automatically generated and placed like this, and our program generated an space. If I continue to enter after this, you see our program will keep the space. And here I can write another right line. But let's say I mess with the indentation like this, which is important to have in the code file to have good structure. Good indentation increases the code readability. And I put some space here like this and like this. So I can get it back and I can fix the indentation using the key Control plus K plus D. So let's hold the control key, CTRL. Just hold the control key and press it down, press and release the K and press and release the D, and I can see the indentation is back. So that is a key combination you can use to have good indentation in your code file. And now the last one and the important one is get help. If you want to get help and read something about the predefined methods, properties, classes, etc., you can open the official documentation of C# exactly for the method you want to study. Now, for example, I want to study the WriteLine methods. I will put my cursor here and then I will press F1. As I press F1, our program will automatically open the browser and I will be diverted to the documentation of the WriteLine. And here you see the documentation in the browser. This is a official documentation from Microsoft, and it talks about the WriteLine methods. Now you can read more about this method. So to get help, all you need to do, just put your cursor what you wanna search for and then press F1 key. This program will automatically open a web browser and you will be diverted to the official documentation. So my friends, that was a lecture on productivity tips. All the tips I gave you are very useful. I use them quite a lot and other programmers use them also. It's now time to wind up this lecture, and in the next lecture we will study the building blocks of a program, which are variables and data types. I will see you there. Thanks for watching this one. Previous lecture was all about writing code effectively and enhance productivity. Now we are going to learn something amazing. We will learn variables and data types. This is fundamental concept in programming. Let's now move on and talk about variables and data types. We will try to define both the terms, and after that we will start doing experiments. We will create variables of different types. And one last thing I forgot to say before we move on, don't miss any part of this lecture. This lecture is very important, right? Okay, so
We usually say variables are building blocks of a program. And you better know what building blocks are. Building blocks are something very essential on which something is built up. For example, if you want to build a house, then bricks can be the building blocks because you can't build a house without the bricks. Same way, variables are building blocks of a program. But why is that? Why variables are so important? They are so important because they hold data or they save data in a program. And every computer program has one main goal: to process the data and produce results. So in a nutshell, we can say a computer program needs data to work with, and variables are data provider. And a computer program does not process the data. Data is actually processed by the computer itself. So a computer program collects the data from the variables and sends it to the computer memory. And data is processed in the memory by the computer. So that was about variables. And you need to remember only one point. Variables save data, which is then sent to the computer for processing. That's it. Let's now talk about data types. Variable and data types go hand in hand. They are not different or separate things. Data type simply means different types of data. And in programming, we use data types to specify a type of data that a variable can hold. Now here you see, variables hold data, and the type of that data is specified by data types. Here might come a question that why do we need to specify the type of data in programming? A very simple answer to that question is data is sent to the memory for processing, and memory works different for different types of data. And programming is a way of communicating with computers. When we program, we send instructions to the computer, and computers do exactly what they are told to do. So the computer cannot categorize automatically the type of data we are sending them for processing. And that's why, as a programmer, we have to write instructions in advance where we specify the type of data we are sending to the computer for processing. I hope you get the point and become familiar with the term variable and data type. Let's now combine both the terms and learn to create variables of different types. In C#, data type includes whole number type, floating point type, character type, boolean type, and string type. So these are 5 primitive data types in C#. Sometimes we work with whole numbers, sometimes we need floating point numbers, and sometimes we work with string. But most of the time, in an average program, we have all the types together. So let's start with these data types. We are going to create variables and assign values to them. The first data type is called integer. Integer are whole numbers, numbers without decimal. So if you want to work with integers or the whole numbers, you will create an integer type variable. And to create an integer type variable, C# provides us several different keywords. But the most commonly used keyword that we use is called int. Int means integer. So when we start creating a variable, we first need to specify its type by using provided keyword. So int means integer, and right after the keyword, we need to choose a name of the variable. Now let's say in a program, I want to save age of the user. So I will name my variable age, and right after that, I will put a semicolon and terminate the instruction. Okay, so what did I do? I created a variable named age, and the type of that variable is integer. That means it can save only integer numbers. This statement in programming is called declaration. Declaration means you declare a variable. You create a variable without placing any value into it. In the next stage, when the variable is already been declared, we assign value to it. To assign a value, we use assignment operator. The equal sign is assignment operator in programming. Don't confuse it with mathematics. In mathematics, equals means comparison. But in programming, equals means assignment. So the statement where we assign a value to a variable is actually called assignment operation. So in the first step, we declared a variable, and in the second step, we assign a value to it. Now, what will happen if I run this program? When the program runs, the value 10 is sent to the computer, and the computer knows the type of this value is integer. So the computer going to reserve a memory of 4 bytes because integer demands 4 bytes. And in that 4 bytes reserved memory, number 10 is placed comfortably. So this is how things work in the background. Our variable name is just a reference name, and it's pointing towards the value in the memory. So whenever we try to read our variable like age, the number 10 is returned to us. We will see a couple of examples on that in just a second. So here you see we have successfully created an integer type variable. But in reality, we don't write two different statements, declaration and assignment. The more practical approach is called initialization. When we initialize a variable, we actually combine declaration in the assignment in a single statement. So how do we do that? Let me create another variable. This is called initialization. In initialization, we create a variable and assign a value to it at the same time. So this is more practical way to create variables. So my dear listeners, now you know how to create variables of type integer. Let's now see some variations in it. Most of the time, we do calculations and solve equations and then save the result in a variable. So in a program, we can write a statement like result 10 plus 90 minus 20 plus 23. So a compiler going to figure out the final result of this calculation and then assign the result to our result variable. And here I want to leave a very important comment. Remember one thing, your variable should always be to the left side of the assignment operator. And the value or the equation or the calculation should always be to the right side of the assignment operator. They cannot swap places with each other. So don't forget that point. Let us see another variation. In this program, we are doing calculation using the constant numbers, right? 10, 90, 20, and 23, they are constant integers. But instead of constant numbers, we can involve other variables in our calculation. So let's create two more variables to use them in a calculation. I call them number 1 and number 2. And our calculation result gonna be saved in a variable named calc result. So this calculation is exactly the same to the previous one. The only difference is here we are using only constant values, and here we have two variables involved. Remember what I said earlier, a variable points to its value, and when we try to read a variable, the value is written. And here we are trying to read our variables. we are trying to use our variables. So at the time when our program does the calculation, number 1 is replaced by value 10 and number 2 is replaced by its value 90. So listeners, this is how we work with integer type data in programming. The next data type is floating point type. Floating points are basically decimal numbers. And to create a variable of floating point type, C# provides a keyword double. So we use double for creating floating point variables. And as usual, we first specify the type, and right after the type, we choose a name of the variable and then assign a value to it, like this. So we have created a variable named discount, and the type of this variable is floating point. It can hold or it can save decimal numbers. Floating point variables can be used the same way as we used integers because they are numbers. Let's say if I want to calculate the area of a triangle, so I can write a program using floating point variables. Let's have a look. Right, so triangle base and height is recorded in two different variables, and here we are calculating the area. So whatever the area is, its value is saved in this variable t area. And if you're wondering why I'm not printing these variables in the console, then I would say have patience. We will certainly learn to output variables in the next episode, in the next lecture. In this lecture, we are trying to learn variables and creating variables of different types, right? Okay, so this is how we work with numbers, integers, and the floating points. Now, our third data type is character type. A character type variable is used to save only one character, and it is created using the keyword char. And after the keyword, we give our variable a name. Let's say the variable name is sign, and then assign a single character to it. Now here we see the value is different. It's not the same as number, and it's assigned using single quotes. This is actually syntax. A character variable's value must always be inside the single quotes. Another thing that you need to memorize is that a character variable can hold only a single character. That means you can't assign two characters at a time to the variable. Let's say if I put another character, I will get the error. And the error says too many characters in character literal, right? So you're not allowed to put more than one character. And one last thing is that character variable takes up 2 bytes of memory, and every character or symbol that is the part of the Unicode table can be used here as value. For example, a question mark is a character, addition sign is a character, @ sign is also a character, and even a space is also a character, right? So that was character type variable. And our fourth variable is very interesting. It's called Boolean type. Boolean means true, false. Boolean is a special variable, and it can only has two values, either true or false. And to create a Boolean variable, we use the reserved word bool. Then the name of the variable. So we have created a Boolean type variable. The name of the variable is right answer, and the value is true. So the Boolean variable, like I said, is the special one, and it needs to be programmed, needs to be further investigated, because the value true and the false can be the result of any other activity. And in that case, is right answer variable can also have the value false. So how do we get to know if the answer is right or not? So in most of the cases, we further investigate Boolean variable to get the right result. So when you will start learning if statements and the loop statements, then you will see this Boolean variable in action. And finally, the last data type is the one that gets used a lot. And the name of the data type is string. You can also call it text. String is very commonly used type. It's very important and it's used to create text. And a text is a combination of one or more characters. To create a string variable, we use the keyword string and then the name of the variable and then assignment. I want you to pay attention on the assignment. A string creates text, and a text is a combination of one and more characters. And these characters should always be or must always be surrounded by the double quotes. That means you will first code the double quotes like this, and inside the double quotes, you will write the text, such as I am learning C sharp. So I am learning C sharp is a text, is a string value, is a string literal. And how do we know that? We know that because of the double quotes. So remember this thing, the string literal of the text must always be inside the double quotes. In other words, everything which is surrounded by the double quotes is string in C sharp. It can be numbers, special characters, alphabets, etc. If there are double quotes, the value is a string. That's it. A single character can also be considered a text. The only condition is the character should be inside the double quotes. As you can see, I, which is now single, but it's inside the double quotes. That's why it's a text, it's a string. In the same way, if you have numbers inside the double quotes, so they are not real numbers like integers or floating point numbers. So this value is not the real number. This value is string representation of a number. Or you can also say this is string equivalent of a number. Equivalent of any number, however, can be converted to its real form in real number. And we will learn to do this conversion together with ReadLine input method. So, my dear listeners, we have covered data types in C Sharp. I am aware of the fact that this lecture was lengthy, and I would say sorry if you feel yourself overwhelmed. Now, I want you to do some practice. If you want to learn programming, you have to do some practice so that you can memorize the syntax. And using the timeline of this video, you can simply back and forth to different topics. And in the next lecture, you will learn to output the variables in different ways. I will see you there. Thanks for watching. In the previous lecture, you learned to create variables of different types. And in this lecture, you will learn to output variables or to see the result of your calculations. If you didn't watch the previous lecture or have no idea about creating variables, I would recommend pause this video, stop here, go back, watch the previous lecture, and learn the process of variables creation. In this lecture, we won't be learning creating variables. We are one step ahead now. So coming back to the topic, to output variables in C Sharp, we use WriteLine method. Into the method, we pass the name of the variable. So in a program, as you can see, I have 5 variables and they have different types of data: integer, floating point, boolean, character, and string. So to output these variables, we will use WriteLine method. Let's see how we do that. I'm going to print out all the variables. That's it. Very simple. So we are passing our variables as argument to the WriteLine method. And as we have discussed earlier, this method is responsible for writing results of text in the console. If I run this program, you will see the values in the console because we are trying to read our variables. And when we try to read variables, they are actually replaced by their values. And these are the values, right? So let's check it out. And here we see the output. You see all the values. But don't you think this output is very boring and it doesn't say much about these values? Am I right? Isn't it? You can't predict anything just by saying 1.5. What is it? Does it tell you something? And the false? What is false? Is this a air or just a number? I don't know. So our output is very boring. It doesn't say so much about these values. So I think it would be better if we bind some text together to add extra information, such as the current year is 2023, today's discount is 1.5, the answer is false, addition sign is plus, and how is weather today? Weather is sunny and warm. So an output of this kind would be better and user-friendly. So let's make this output user-friendly by adding some text to the variables. So in the WriteLine method, before the variable, I want to put text like the current year is. So text is a string, and we know that. And we also know the string is surrounded by the double quotes. So I will open double quote here and will write the text. Right? So we have a string or a text and we have a variable, and we want to bind them together. And to accomplish this task, we put a plus sign in between. That's it. Now the output of our first WriteLine should be the current year is 2023. So the result is desirable. But hold on a second. What I just did, it seems like I'm trying to add two different data types. The one is a string and the other one is integer. So how is it possible? Only numbers can be added, and we know that. The thing is that in the world of computers, things are different and sometimes surprising. That plus sign isn't performing normal addition. It's actually joining the arguments, putting together the arguments. And this joining process is actually called string concatenation. So string concatenation is actually to join two or more strings, and we use plus sign to do so. Plus sign has two different functions. When it's applied to numbers, a normal addition is performed. When it's applied to strings, concatenation is performed. Let's develop this concept a bit further because concatenation is important. It helps you to present the results in readable form. I want to add another sentence to our weather forecast. So I can extend my string like this. That's simple. I extended my string and put another sentence. But instead of extending, I can even join the other string using concatenation. How would I do that? With the help of plus operator. Let me show you. So I will get the same result like before. But here, I'm making use of concatenation. And you can concatenate several strings together. There is no limitation. So concatenation means to join two or more strings. It works only on strings. And when it works only on strings, then why we aren't getting any error here? Because our here variable is not a string. It's an integer. So is there something wrong with the code, or is there something that we don't know yet? So let me tell you, there is nothing wrong with the code. Concatenation is performed here. But before the concatenation, C# mechanism does secretly something in the background. And that something is called type conversion. Our compiler converts the value 2023 to its string equivalent. String equivalent simply means put double quotes around the value. So this is the background thing where compiler converts the type. And to convert any type to a string, compiler calls a built-in method named toString. So by the time of concatenation, integer value had already been converted to a string. So our compiler had no issue doing the concatenation. One thing is for sure, Concatenation applies only on a string. If the value is not a string, then it will be converted to a string. When compiler, I want you to listen very carefully because I'm going to give you two very important terms that you need to know as programmer. When compiler does type conversion without letting you know, like in this case, it's called implicit type conversion. And when you as a programmer convert a type to another, it's called explicit conversion. I can write it down here so that you can memorize them. Right? Implicit and explicit. Compiler will only do the conversion when there is no risk of data loss. Like in this case, the data is intact, the value is intact, only the type is changed. If you want, so you can stop the compiler to call the toString method for you. You can call it by yourself. For example, to the year variable, I can call the toString method by myself. Now I am doing the type conversion, not the compiler. This is explicit type conversion. But this call to toString method here is unnecessary. We let the compiler do that. I just want to show you an example of explicit type conversion. I think you learned so many things in this lecture. Let's prepare the final output. Now our output is good and providing useful information about the data. Let's run the program. Here you see, right? It's much better than the previous one. So using concatenation, you can put information to your output. Let me give you one more example with some variations before we end this lecture. So here's CM variation. When you run this program, the output would be the sum of 10 and 20 is 30. Here you see multiple joinings in a single statement. You can also put white space between variables. And the output may be like 10 space 20. It's now time to end this lecture. And before we end this lecture, I want to give you a food for thought. I want you to investigate this assignment. Try to figure out the value which is assigned to the do not know variable. Would it be 1010 or 20? I'm not going to tell you the answer. Thanks for watching. I will see you in the next lecture. In our previous lecture, we learned to output variables and string concatenation. And I said string concatenation is a beautiful technique to format output string. Having said that, in C#, there is another way to output variables with formatted string. And that technique is called string interpolation. Using interpolation, you get the same result as concatenation. However, the interpolation is more convenient than the concatenation. In addition, if you use string interpolation, your code will become more readable. So let's see how do we create interpolated formatted strings. These were the statements we wrote in our previous lecture. They're still there so that we can have a comparison between interpolation and concatenation. So to create an interpolated formatted string in a console.WriteLine, we put something like So this line of code where the string literal starts with a dollar sign is actually a string interpolation. And the output of this write line and the first one is exactly the same. The syntax of interpolation is very simple. So a string interpolation begins with a dollar sign. And right after the dollar sign, you code your text as usual inside the double quotes. While creating interpolated string, you need to be careful about one thing. No white space between the dollar sign and the opening quotation. If you put a white space, the compiler will complain. To read variables or any other type that returns a value, we use curly braces. These curly braces are called interpolation expression. So we can simply put our variable inside the curly braces and it will be replaced by its value at the time of execution. Let me first run this application and I want you to read the output of the first and the last statement. And here you can see the first statement and the last statement, output is exactly the same. Now you can compare both the statements. You will see string interpolation is more readable and convenient to code than the string concatenation. Let me give you another example to compare between interpolation and concatenation. Now you can see which one is better and more convenient to write. In concatenation, we are forced to put a space between the arguments, even here, here, and a space here, and a white space here. But in this case, you don't need to think about the white spaces. White spaces you put in the string become the part of the output. When we run this application, you will see the output will be same. Check the last two lines, and you can see the same output. One uses concatenation, and the other uses interpolation. In an interpolated string, you can also use escape sequences. Let me put a new line sequence here and one here. Now the output is distributed over 3 lines, line 1, line 2, and line 3. Let's take it out. And here you see the output over 3 lines. So escape sequences work as usual. You have 2 different ways to format your output string, concatenation and interpolation. Which one to use? It's up to you. There is no significant performance issue either with the concatenation or the interpolation. However, interpolation is more readable than the concatenation. So that was all about string interpolation. I will see you in the next lecture. Thanks for watching. So now we are done with the variables. We know how to create, use, and print the variables in the console. It's now time to move ahead. In this lecture, we are going to learn constant fields. Sometimes in a program, we need constant data, a data that cannot be changed or updated after the program is executed. Variables are not constant. Data in the variables can be changed and modified anytime, and that's why they are called variables. But constant fields are always constant. Data cannot be changed. Some values, as you know, are universal constant around us. For example, the value of the pi, which is equals 3.14. But there are some occasions where you define your own constant values. You want them consistent or unchanged all the time. So in C#, to create a constant field, we have a special keyword called const. So to make a variable constant, we put the const keyword before the data type. Now let's say I want to define the pi constant. So after the const keyword, I put the data type and the name of the field and then the value. The value which is assigned to this pi field now can't be changed in the program. If I try to change or overwrite the value, I will get the error. As you see, our program complains. So we can't change or modify a constant after the creation, as we can't change or override a constant. That's why they aren't called variables. They are called fields. A variable can be overridden, and a value in the variable varies. That's why it's called variable. So pi is already a constant in its nature, but you can also make your own constant fields using the keyword const. Let's say in a program, you offer your customers a day discount of 0.5%. So this value is for a whole day. It's important as well as sensitive. If this value somehow gets overwritten by another statement in the program or become more or less, then there will be a serious problem. Your customers either become very delighted by your generosity or become disappointed for not getting the right discount. So to save yourself from the trouble, you can make this variable a constant field. Now you're safe. And one last thing before we end this lecture. A constant field can't be declared. It must be initialized. That means when you create a constant, you must give it a value. You can't just simply declare a constant like this. So you're not allowed to only declare a constant. You must assign it a value immediately. I hope you understood the concept of using constant fields. I will see you in the next lecture. Thanks for watching.
In the last lecture, we talked about constant fields, like how to create constant data in a program. Now we will start learning the operators in programming. Using the operators, we apply operations on our data and we change, modify, and manipulate our data. Let's move on.
In a language like C#, there are a bunch of different operators divided into different categories, such as arithmetic operators, assignment operators, increment and decrement operators, relational operators, logical operators, etc. So these are different categories, and we learn all of them to write a logical program or program that does calculation. But we don't learn all the categories at the same time. Some of them are associated with other things. For example, relational and logical operators are associated with if statements. So we'll learn all the categories when the time is right. We'll learn relational and logical operators when we'll be discussing if statements. Today's lecture is about arithmetic operators. In this category, we have common operators, and you know most of them from mathematics, like addition, subtraction, multiplication, and division. You know all this. Except these common operators, we have another operator which is called modulus. Modulus can be something new to you if you didn't program previously. But don't worry, we will discuss this operator and learn to code it. The sign of the addition is normal, the plus sign. The sign of the subtraction is minus sign. Multiplication sign is asterisk, and division sign is forward slash. Now have a look at the example. I have two numbers, and here we have addition, subtraction, multiplication, and division. Simple. So these operators are very simple, and we use them as we do in mathematics. Only for division, there is something special that you need to know and remember. It's called integer division. Integer division results in integer. So whenever you divide two integer numbers, that means you are performing integer division. And integer division, like I said earlier, returns the integer part of the decision. So the output of this statement would be 3, not 3.33. So in reality, that would be the actual result, 3.33. As we are doing the integer division, as you can see, both the values are integers, whole numbers. That's why we get the integer part of the result. Let me show you the result in the console. Now you see the output, only the integer part is written, right? So you can have integer division if you only need a whole number result, only the integer part of the result. If you, however, want to get a complete decimal result from the integer division, then you need to at least convert one value to floating point. And you can do that in several different ways. For example, instead of integer 3, I can put a decimal dot 0, decimal 0. Now, the result of this statement would be 3.33. And that's why we need to change our data type to double. Let me show you the output. And now you see a complete result, right? 3.33. And if you don't want to put the decimal 0.0, you can perform a typecasting to double. And to do that, before the value you want to typecast, you will write the type in the parentheses. And you only need to typecast only one value. The program will work. Let's run the application and see the output. Right? Here you see the same result. So that was integer division. So don't forget it, right? It's an important thing. And it helps you to comprehend modulus. So let's talk about it. Modulus is a very useful and wonderful operator. You can do amazing things with it. The sign of modulus is percent sign, but it has nothing to do with the percent. So what does it do? Modulus gives the remainder of integer division. Listen once again and pay attention. Modulus gives the remainder of integer division. That means modulus does division, integer division, and it returns the remainder. Let me make it further simple with the help of this image. So what do we have here? We have division. What type of division? Integer division. So when we have integer division, there will always be two things we get in the result. Number one is quotient, because 7 goes 3 times of 2. But the 7 is not completely divisible by 2, so we get a remainder. So that remainder value is returned by the modulus operator. Now let's suppose if I had number 8, so in that case, 8 is completely divisible by 2. So the quotient would have been 4 and remainder 0. So when we use modulus, it does integer division and returns remainder. So let's write some code. I show you several useful examples. In the first example, I'm solving this one. So we get the quotient using integer division, and here we get the result 3, quotient 3. But here I am using modulus. There will also be integer division, but the result won't be quotient. The result is remainder. So let's print both the variables in the console to see if you're getting the right result. Now here's the output. Quotient is 3 and remainder is 1. I hope you understood modulus. Let me show you some more examples. Let's say you are given a time in minutes, 150 minutes. And you are told to convert this time in minutes into hours and minutes. So how would you do that? You will use integer division and modulus. Have a look. So here we get the hours. In 150 minutes, we have 2 complete hours. And 60 minutes equals 1 hour. So 150 divided by 60. Integer division, we get the result 2. After 2 whole hours, we have some remaining minutes. So how do we get the minutes? With the help of modulus. Integer division, but this time the result is remainder, 30. So 150 minutes equals 2 hours and 30 minutes. So let's print it out in the console. Run the application. And here we have our output. 150 minutes equals 2 hours and 30 minutes. Let's have another example. The same way you are giving number of months, right? Like 28 months. And you want to find out the years and the months. So you get the years using simple integer division. So 28 months equals 2 years and 4 months. Let me print it. And here say 28 months equals 2 years and 4 months. You see, modulus is very interesting, and there's so many places where we use this operator. Now, what will happen if I say total number of months is 12? 12 is completely divisible by 12. Here we'll get the answer 1. And 12 is divisible by 12. So there is no remainder, 0. Now see, 12 months equals 1 year and 0 months. Let me show you. You see, 12 months equals 1 year and 0 months. And what if you have only 6 months? Integer division, 0, because 12 is greater than the 6. In this case, the answer would be 6, because 6 is smaller than 12. There wouldn't be any integer division, and number 6 is returned as remainder. Let me show you the output. You see, 6 months equals 0 year and 6 months, right? One last example. In number systems, we have even and odd numbers. So how do you write a program that tells you the number is even or odd? An even number is completely divisible by 2. Completely divisible means the remainder must be 0. So after division, we need to check the remainder to find out if the number is even or not. So in a program, you can write, let's say the number is 12 modulus 2. So if you get 0, that means the number is even, and you will get it here, because 12 is completely divisible by 2. And if I change 12 to 15, the remainder would be 1. So if I check this variable, I can easily find out a number is even or odd. So listeners, in this chapter, we learn to use arithmetic operators. And we learn more operators in our coming lectures. Stay tuned and thanks for watching. In our previous lecture, we worked with arithmetic operators, which are used in calculations or equations. So in connection with arithmetic operators, we are going to explore C# math class. So we are going to do some more mathematics. C# has a well-maintained math class which contains predefined mathematics functions. Predefined functions means they are already coded. You don't need to code them. All you need to do is just call them or use them in right manner. So I will show you how to use some of the functions which are very common, and we'll also see how to read the signature of those predefined functions. Let's say you want to calculate the square root of any number, number 49. So you can do that by calling a predefined function named sqrt. So sqrt is a predefined function for calculating the root. To the function, we pass the value, and function returns a result. And the function is called with its class reference. So math is a class or a library containing sqrt function. And we use dot operator to call a function from a class. So this call of a function is actually exactly the same with console.WriteLine. So WriteLine is a function or a method just like sqrt,
It belongs to the cancel class, so we need its reference. So in this way, you can call predefined functions of math library. So math class contains a lot of functions, and you can find them in the C# documentation, right? So you can see there are so many functions, and they are predefined. You don't need to code them. There is a function named round, which can round a value. There is a property named pi. It gives a value of pi constant. So let me show you a couple of examples. So if I want to round a number, so I can call round function. Let's say I have a number 10.89 and I want to round it to the nearest integer. So I will call the round function and pass the values. So the round function is going to round a value to its nearest integer, and in our case it would be 11. You can also call the value of pi using the property pi. So math.pi will return you the value of pi constant. Let me run the program and show you the result. Here you see the rounded value 11 and the value of pi. And here we forgot to print the root variable. We are printing the number variable, right? So that's why you see the value 49. Otherwise, the result would be 7, right? There is another very useful function called power. Power function calculates x raised to the power of something. And in the documentation, the function is listed here, right? So let's use this function and find x raised to the power of any number. So we have a value x, let's say 5, and we want to calculate x raised to the power 2. So I'm going to call the power function. The first argument is x, and the second argument is power. And the result would be 25, right? 5 raised to the power 2 is 25. We can also check it out in the console. This is how you can use and have advantage of all the predefined functions we have in the math library. Let's now talk about the signature, function signature. Every function has its own specific signature, and that signature is defined by the total number of arguments a function can take and the data type of the arguments, and it also includes the data type of the returned value. This power method has a specific signature. It takes the argument of double type, and return values type is also double. And I know that signature, that's why I choose to work with the double type, as it is a predefined function, so we can't change the signature. Now let's say if I change the data type of the value returned by the power method to int, our program complains, because this method returns a double type value, and we usually can't save a double type value in a integer type variable. So whenever you use any predefined function, you need to be careful about its signature. And you can find function signature in the C# documentation. So here is the power function. Let's click on it. Now here you can see the function signature. The name of the function is power. It can take only 2 arguments of type double, and the return value is also double, right? So x should be double, y should be double, and the returns value should also be double. So this is actually called function signature. And when you use a predefined function, you need to follow the signature. You can find the link of the math class in the description of this video. Just go to the link and try some predefined functions. Read the signatures and try to code them. It's now time to wind up this lecture, and in the next lecture we will study and learn the use of the standard ReadLine method. As you know, WriteLine method is a standard output method. It outputs data in the console. On the other hand, readLine is an input method. It takes the input or the data from the console to the program. Things are going to be interesting as we are moving on and learning new concepts. I will see you in the next lecture. Thanks for watching this one. Like I said in the last lecture, we would study the standard read line method in this lecture. So let's move on.
ReadLine is a standard input method which is used to read text in the program. So using this method, you can create more advanced applications by engaging users. So we are going to learn and explore this method. At the same time, we will see type conversions because readline and type conversion are interrelated. So we are going to first talk about the readline method and then we'll move on to type conversions. So let's start with the readline method. I'm going to write a very simple program where you will see readline method in action and then we will talk more about it. Program will ask user a name and after reading the name, it will print a welcome message, such as if user provides Peter, our program will print welcome Peter. So let's write the code. A very simple program. Here I'm using the WriteLine method and you know it very well. Write method is another output method. WriteLine prints the text and sends the cursor to the new line. Whereas write method prints only the text. It doesn't put a new line. So after this message in the console, there will be a cursor. Now what will happen if I run this application? When we run this application, you will see this text in the console. Enter your name and right after that, you will see a blinking cursor. You won't be able to see the output of this statement because in between we have a readline statement. Readline, like I said earlier, is an input method. When it executes, program stuck. So the execution of the program is interrupted by this method. So what does this method want? This method wants a user input. So in front of the blinking cursor, you will provide input text. And once you are done, you will hit the enter key. Enter key is a termination key and readline stops listening. And when it stops listening, collects the provided text and returns that text to the program. That's why when we code readline method, we code it with an assignment. So the text provided by this method is going to save in this variable. And after the assignment, our program will execute the last statement. So let's execute the program and check it out. Now you see the message, enter your name, and this is the first statement. We don't see the last WriteLine statement, right? And the cursor is blinking. Our program is waiting for the input. And this is the readline method. So we provide a name, let's say Peter. So Peter is the input I gave to the program. And now I will hit enter. And then you will see the last WriteLine statement. Welcome Peter. Here you see, right? So this is how we code and deal with readline methods. And in a single program, you can have several read lines. It depends on the amount of input you are planning to work with. For example, here I'm only reading the name, but I can also read email, telephone, etc. So in this example, I'm using several read line. I'm reading name, email, and telephone. And how does it work? Let's check it out. So enter your name. This is the first read line. Let's provide a name. Enter your email. Enter your telephone. And now you will see the result. That was simple, right? And as we know, read line stops the execution of the program. And this feature can be used to hold an output until the user hit the enter key. For example, after reading these fields, I want my program to stay here so that I clear the console before I show the result. So I will write a message to the user. And to hold the program to go further, I will write console.readLine. I'm not reading anything here. There is no assignment. The only purpose of this read line is to stop the execution of the program. And then I will call console.clear. So when the console is cleared, we are going to print the output. Now the program is going to stop 4 times. Here, 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 and here. So let's check it out. So here we go. Provide a name, an email, telephone, hit enter, and now you see the message. This is the last read line which is holding our program. And when I press enter, this read line gonna release the execution, console is cleared, and the output is shown. So let's hit the enter. And here you see, only the output, everything else is cleared. So this is a very common use of read line. You can use it just to hold the execution of the program. Let's now move on. Read line seems to be a very good method, but it has a couple of issues, and we need to address these issues. Number one, if you hit enter without writing any text to the readline method, it returns a null value. Null is a special data type in programming. It's also a reserved word, and it means nothing. If a variable has null value, that means it has nothing. Variable has no reference to the memory. So null is a reserved word. If I write null here, we say it gets blue color, right? So be careful about the null value. Null value cannot be processed. So to this write line, if I hit enter without providing it any text, a null value is written. So our variable name is going to get a null value instead of a valid name. In C#, there are several methods and functions which we can use to control the input and validate input. And we'll learn those methods in our coming lectures. So a null value is returned when nothing is provided to the readline method. That was the issue number one. Issue number two has something to do with the type conversion. So what's the issue? Readline returns string type data, or in other words, it returns text. So if you only need to work with the text in your program, then it's fine, no problem. But if you need numbers in your program, like floating point and integers, then you can't simply do that. We have to perform type conversions because readline will return the string representation of a number. Let's say if I provide number 10 to the readline method in the cancel window, so it will be converted to its string equivalent like this. So you provide a real number in the cancel, but in the program, you get its string equivalent. And you can't simply use this format in equations. Now let's say I want to read a number. So it can't be done. Our program is complaining there is a type conflict. It says we are trying to convert a string to integer, right? This is what we are doing here. So readline will not return a string. Even if we provide 10 in the console, this form is returned by this method, which cannot be assigned to this integer variable. So somehow we need to convert the string equivalent of a number back to the real number, right? So we need to remove the double quotes. This is basically called type conversion, converting one data type to another. So to convert a string equivalent of an integer to real integer, we use parse method with keyword integer. And to convert the string equivalent of a floating point number to the real floating point number, we use again the parse method together with the keyword double. So what we can do, we can simply let the string equivalent of number in the program. Now it's fine. We will get this one in this variable. We can change the name of this variable like number in string form, right? So when we have the number in string form in this variable, so we can change it back to its real form using the parse method. So I will write int number real, for example. Int, I will call the parse method. Into the parse method, I will send the number in a string form. So this parse method is going to convert the string equivalent of a number, which is this one, to its real form. Now in this variable, I have real number. I can perform operations on it. Let's perform an operation and multiply the number by itself. Run the program. So here we have enter a number, and if I provide 5, so 5 multiplied by 5, I will see 25 in the result, right? So we are able to read numbers with the help of type conversion. So this is how we perform the type conversion and read numbers. These two lines of code can be combined in one, which is a more practical way to read numbers in the program. So how do we combine these two lines in one? Let me show you. ReadLine gonna return the string equivalent of a number. So instead of saving that number in a variable, we can pass that number directly to the parse method like this. And so now we don't need this extra string variable. Let's remove it from here. So this is a more practical way. A string equivalent, which is returned by the ReadLine, is passed directly to the parse method. Number is then converted into real integer, which is then assigned to the variable. The same way, if you want to read floating point numbers, like numbers with decimals, then you're gonna parse it as double, right? So you need a double type variable. Now you can read floating point numbers. The ReadLine method gonna give you the string equivalent, for example 10.89, and the parse method gonna convert this equivalent to real floating point number like 10.98, right? So that was the issue number 2, type conversion, and now we know how to deal with that. Let's now move on to the issue number 3. Issue number 3 is the last issue, and you need to be very careful about this one. Issue number 3 is about error. What error? Runtime error. They are also called exceptions. The parse method can cause your program to crash, totally crash. You won't be able to do anything. So when does it happen? It happens when the parse method fails in doing conversion. And according to the parse method's documentation, there are 2 different cases where this method fails. So let's look at the documentation of the parse method. It can throw 3 different exceptions. These are the errors, runtime errors. Argument null exception, when the value provided to it is null, then you will get argument null exception. Second one is a format exception. So if you provide any string equivalent which is not a number, then you will get this type of exception. And the last one is overflow exception. It happens when you try to convert a very large number that can't be stored in 4 bytes if you are using integer and 8 bytes if you're using double. So these are the 3 exceptions, and first 2 exceptions are very common. So let me give you a demonstration of argument null exception and format exception. Argument null exception, when you try to convert a null value to the number, right? Now let's say in a program you have a null value in a variable like this, and you try to convert this null value to a number, and you will get argument null exception, right? Let's now run the program. Here's the exception. Our program crashes and it says value cannot be null, right? So the null value cannot be converted, and it makes sense. Null means nothing, right? The second exception is format exception, and that means when you provide something which can't be converted to numbers. For example, 10.98 can be converted to numbers because it's a string representation of a number. But instead of 10.98, if I provide something like ABC, so ABC isn't a string representation of number, parse will fail and you will get the error. Or if I provide just a space, I will get the same error. Or if I provide a text containing a string, a mixed string with numbers and characters like 10 and 10, then I will also get the same error, the same exception. So let's run the program and provide something that can't be converted to the numbers. So I provide something like ABC. So ABC can't be converted. I mean, know that. hit the enter and face the exception. Now you see here, right? We are getting format exception. And what does it say? Input string wasn't in a correct format, right? So these were the two exceptions you can face while you code in C#. Exceptions can be handled, and we'll hopefully learn to do that later on. And we'll also learn another conversion method which is safer than the parse method. Now I want you to do some drill, write programs, use the ReadLine methods, read text and numbers, do type conversions, etc. Now we can read data in our program using the ReadLine method and print output using the WriteLine method. So we know how to write a program where the input and output both are functional. From the next lecture, we will start learning more operators. What we have learned so far are only the arithmetic operators. But like I told you, we have bunch of different operators divided in different categories. We need to learn all of them in order to code logic. In the next lecture, we will learn arithmetic assignment operator. I will see you there. Thanks for watching this one. It's now time to learn more operators. In a previous lecture, we have already learned arithmetic operators: addition, subtraction, multiplication, division, and modulus. These 5 operators can also be transformed into assignment, and though they are called arithmetic assignment operators. So in this lecture, we'll be talking about arithmetic assignment operators. You learn to code them, and I'll tell you when to use them, like in what situation. So let's start with the addition assignment. If you get this one, you get all of them. So in an arithmetic assignment operator, a same variable is involved to the both sides of the assignment.
It will make more sense when I give you an example scenario.
So let's have one. Let's suppose I'm programming a game and need a score variable. And at the time, when I start the game, the score is 0. Then I do some progress in the game and want to update my score variable with a value of 10. So one simple way to do that is just assign the value 10 to the variable. This value 10 is points in the game. So let's just suppose after the stage 1 in the game, I got 10 points. But I'm still playing, I'm still in the game, and I cleared the stage number 2. So I need to update my score again with 10 points. So how do I do that? Here we have the stage 1 in the game. Now I am on stage number 2. I can't simply assign another 0.10 value to the score variable just by using the assignment, because it will override the previous value, and we don't want it. What we want is to add the new point value to the previous one so that we get the right and updated score after every stage. So this can't be the solution. I mean, this simple assignment, it isn't going to solve our problem. The problem can be solved using the arithmetic addition assignment. And like I said in the beginning, the same variable is involved to the both sides of the assignment. Now you will see the addition assignment. So the score variable is on the both sides. To the right side, it is involved in calculation, and the new calculation value is assigned back to the same variable. Now, if I compile this code manually, so the value of the score is 0 from the beginning, and after the stage 1, a new value is calculated, 0 plus 10 points. So the value is 10, which is assigned back to the score variable. And in stage 2, once again, a new value is calculated. But now a score has value 10 from stage 1. So 10 plus 10 becomes 20. So after stage number 2, value 20 is assigned to the score variable. This is actually called arithmetic addition assignment. And now you know where you need to use them. You will use them in situations where you need to update a value in relation to the previous value. Like here from 0 to 10, 10 to 20, and it will continue to increase its value by 10 if I write it many times. If I print this variable at this stage, I'll get value 50, right? Now, these assignment operators can be written in a short form. They have their own signs. Like for addition assignment, we use plus, equals. For subtraction assignment, we use minus, equals. And for multiplication assignment, we use multiplication, equals, and so on. And when we use the short form, we code it like this. So what you see here is short form of this one. These two statements are exactly the same. So you can either use this normal form or this short form. The subtraction assignment does exactly the same. Only the operation performed will be subtraction. So in the game, if I made a terrible mistake, I will lose my points by 10. Right? And this can also be written in the short form like this. If I print the score at this stage, I will get 40 points, right? That would be the value in the score variable. So my dear listeners, these remaining operators do exactly the same. Write a program and check them out by yourself. And I hope it won't be any problem for you to code and understand these remaining operators. So that was all about arithmetic assignment operators. I will see you in the next lecture where we will study another set of operators. See you there. Thanks for watching.
We are learning operators in programming. In the last lecture, we talked about arithmetic assignment operators. Let's move on. In this lecture, we will learn another set of operator which
is called increment or decrement by 1. Increment or decrement by 1 actually counters, increment counter or decrement counter. They are used to increase or decrease the value in a variable by 1, exactly by 1. So let's now see how do we code them, how do they work, and what are the different ways to deal with them. Both the operators have their own sign. For increment, we use 2 consecutive plus sign, and for decrement, we use 2 consecutive minus signs. So these were the signs for increment or decrement. Now let's say I have a variable named counter with value 10, and I want to increase the value 10 in the variable exactly by 1, so I can apply increment operator to it like this. So the value in the counter is now increased by 1. If I print this variable out in the console, you will see alignment in the output. Let us see 11, right? The value is changed, value is increased. If I want to increase again by 1, so I will repeat the statement like this, from 11 to 12, 13, and 14, right? So after increasing the value 4 times by 1, I will get 14 in the output. And so you see the 14, right? The decrement works exactly the same, except it decreases the value by 1. So to the same variable counter, we can now apply decrement. And once again, counter had the value 14, and now after the decrement, it will become 13, and now 12. So the final value in the counter is now 12. Let's check it out. And now you can see the value 12, right? So these are increment and decrement operators. And you'll see them controlling the loops, especially the for loop, later on in our coming lectures. Now, if you remember our previous lecture, in the previous lecture, we learned arithmetic assignment operators. Don't you see this increment or decrement is actually the short form of arithmetic assignment. For example, this decrement can also be written like, and this increment can also be written like. So these two statements with assignment and with operator are exactly the same, and these two are exactly the same. But in this case, we have the opportunity to change the incremented value. So you can have a different value to update your variable using arithmetic assignment. But in this case, when you use increment or decrement operator, the value is increased or decreased only by 1. Otherwise, both the operators do the same thing. They update a value in a variable and then reassign the updated value to the same variable. Let's now move on to the problematic use of increment and decrement. This one is important to understand. When you apply increment or decrement to a variable which is involved in assignment or in any calculation, then you need to be careful about two aspects. Number one is postfix and number two is prefix. So what are these two aspects? Increment and decrement can be applied before and after. For example, at the start, I applied increment after. This is called postfix. I can also apply it before, and this is called prefix use of increment operator. So this post and prefix use of increment and decrement needs to be understood, because you won't always get the same or the right result if the variable is involved in the assignment or in the calculation. So let's check out a couple of scenarios. In a program, I have a variable named attempts with value 3 and another variable named user attempt, which is 0 from the beginning. And now I will assign total number of attempts to the user like this, and I will print a message to the user. So we have 3 number of attempts, and in the beginning, user have all the attempts, right? Let me show you the output. Now you can see you have 3 attempts left. Now let's say in the program, user has made an attempt, so I want to decrease this attempt variable by 1, right? So I'm going to copy piece of code and will apply minus to it, right? I want to decrease the value by 1. Simple as that, right? Now, what do you think? What will be the output of this statement? 2 or 3? Let's check it out. Something is weird. As you can see here, users still have 3 attempts left. Despite that, we are applying decrement here, and we're still not getting the right result. This is because of 2 reasons. The reason number 1 is this variable is involved in assignment. The value of this variable is going to assign to this one. And the reason number 2 is we are using postfix decrement. Now what will happen? Our compiler is going to translate this line of code from left to right. And at this stage, our compiler will say, this is an assignment. And then it will investigate further to the right. Is there something that can be assigned? Yes, there is a variable with a value that can be assigned. So our compiler immediately assigned the value before executing the decrement on the value. So the value is assigned first and the decrement is applied after. So the decrement is actually performed to our attempt variable after the assignment. We can investigate the attempt variable in the console and you will see the value 2. You can see the value in the attempt variable. It is decreased by 1, right? So to fix this issue, you can use prefix instead of postfix, like this. Now our compiler will see the assignment, and right after the assignment, it will find decrement. So it will apply decrement to the value, and then the value is assigned. Now you will see the right result here. Let me show you in the output. Now you can see the user had 3 attempts, and now he has 2 attempts, right? And the same will happen if you apply increment or decrement on a variable which is used in an equation or calculation. So let me give you one large example. Let's say we have 3 variables. Here we have 3 variables with values 10 each. And here we have an equation, right? So I'm adding these variables. So what do you think? What would be the sum? Can you guess? Would it be 30 or 33? The output would be 30, not 33. And now you know the reason. How can we make it to 33? I'll leave it on you, right? So that was all about increment, decrement operators. And don't forget the postfix and prefix use of increment and decrement. I will see you in the next lecture. Thanks for watching.
In the last couple of lectures, we have been talking about operators, arithmetic assignment operators, and increment decrement operators. Let's move on. This is our lecture number 17, and I must say, wow, we have done so many lectures, and there are many lectures to come. You remember in the introduction of this course, I showed you all the topics we would cover, and then I gave you an estimation. I said we need at least 60 lectures to cover all those topics. So there are many lectures to come after this lecture. Okay, now from this lecture, things gonna be very interesting because we are going to learn something which is mandatory to write logical and real applications. We are going to learn relational or comparison operators, and this is the beginning of writing logical applications. Relational operators together with logical operators and if statements let a program make decisions. And when a program starts making decisions, that simply means there is some logic in the background. In this lecture, we will try to understand the relational operators. In the next lecture, we will discuss logical operators. And in the lecture after that, we will learn to code if statements. These three lectures, this one, which is lecture number 17, and the coming two lectures, lecture number 18 and 19, are most important lectures of this course. These three lectures are related to each other, so don't miss them. Now, coming back to the topic, relational operators. What do they do?
Relational operators are used to relate two values, like numbers or to string values. And after relating the values, they return a result which is then used in decision making. And that's why they're called relational operators, because they relate values. They're also called comparison operators because they compare two values. In C# or any other language, we have 6 different types of relational operators. We see all of them on the screen. We have equal to, we have not equal to, we have less than, we have greater than, we have less than or equal to, and we have greater than or equal to. They have their own signs. Equal to has 2 equal signs, not equal to has exclamation and equal sign, less than, greater than has their own signs, less than or equal to, greater than or equal to has their own signs, right? So these are 6 relational operators, and when we code them, we use their signs. Now, all the relational operators have 2 things in common. Number 1, they take 2 operands. Number 2, they return Boolean result. And you know what Boolean is, right? We have already talked about Boolean data type in the beginning of this course, right? So the return value is a Boolean value, true or false. So all of them take 2 operands, compare them, and return a result in Boolean, true or false. That's it. Now we are going to investigate these operators one by one. In the program, we need 2 variables so that we can have comparison. So we have 2 variables, number 1 and number 2, and they are assigned same value. So let's start with the equal to. Equal to operator checks if both the operands are equal, exactly the same. So if I want to check number 1 and number 2 are equals or not, so I will write. So here I'm applying equal to operator on number 1 and number 2. Number 1 and number 2 are 2 operands, right? So equal to, going to perform a comparison. We check if both the operands are equal or not. If they are equal, the operator going to return true, otherwise false. Now we know the number 1 and the number 2 are equal, so the result should be true. So true, right? As expected. And if the operands are not equal, you will get false. Let's say the value in number 2 is 20. Now the result should be false. Here you see the false in the output, right? So you can easily compare numbers to check if they are equals or not. But besides numbers, you can also compare string values. Let's say I have a string variable with some text, and I can write something like, so here I'm investigating if the text in this variable is exactly the same to that one. And we know the text is same, so the result would be true. And so you see in the output, right? And if the values are not same, you will get false. For example, our text is in lowercase, and if I change only the one letter to uppercase, so now the output would be false because the lower and the uppercase letters are not same to the computer. They have different codes. And so you say the output is false. So using this string comparison, you can write so many programs, like if a name exists in a list, or if a user has provided the right username and the password. We are going to write such programs later on. Okay, so that was equal to relational operator. Let's now move on to the not equal to. Not equal to, we're going to check if the operands are not equals, right? So in this case, the result would be true because number 1 is not equal to number 2. Number 1 is 10 and number 2 is 20. They are not equal. So the result would be true. And on the other hand, if numbers are equal, the result would be false. So 10 is not equal to 10. It falls logically. That was simple, right? And if I change the operand to string like this, hello is not equal to hello. It's not true, right? So we will get the false result. And when I write hello in uppercase, like this, the result would be true. Once again, uppercase and lowercase letters are not same. So this is not equal to operator. Let's now move on. The next operator is less than. Less than operator is going to investigate if its left hand operand is less than its right hand operand. And it returns true if the left hand operand is lesser. So if I code like number 1 is less than number 2, the output would be false because the left side value is not less than the value on the right side. We have 10 on both the sides, and 10 is not less than 10. That's why the result is 4. If I change the number 1's value to 7, now the result would be true because 7 is less than 10. And if I make number 2 less than number 1, the result will again be false, right? You can also compare floating point numbers, like if 6.1 is lesser than 7.9, for example. And the string values are not usually compared this way. We normally use equal to and not equal to on string values. So that was less than operator. The next one is greater than. Greater than is simply opposite to the less than, and it returns true if the left operand is greater than its right operand. So in our program, let me first apply greater than like this. Now the 6.1 is in greater than to 7.9. And if I change the value to 8.1, which is greater than to 7.1, the output would be true. And you can also compare variables. So number 1 is 7 and number 2 is 5. And 7 is greater than 5, so the output would be true. So that was greater than. Let's now move on to the next one. The next operator is less than or equal to. Did you notice I emphasized on or, less than or equal to? So here we have two different conditions. If anyone is true, the answer is true. So let me first apply this operator to the numbers. The compiler is going to first investigate the less than. So is number 1 less than number 2? It isn't. Number 1 is 7 and number 2 is 5. And 7 is not less than 5. So the first check is false. Now a compiler will check for equal to. So is number 1 equal to number 2? This one is also false. So both the conditions are false, and that's why the final result is also false. Now if I modify number 1 and give it a value which is less than number 2, for example 4, now the result of this expression will be true. The number 1 is 4 and 4 is less than 5. So the first condition is true, and our compiler won't check the second one. And what will happen if both the variables have the same value? Let's say both have 5. The answer will be true because 5 is not less than 5. However, 5 is equal to 5. So the second condition becomes true, so we get the true in the result. So that was less than or equal to, and opposite to this one is the last one, greater than or equal to. So let me modify the sign like this. So now we are investigating for greater than or equal to. And if we process this equation, the output would be true because 5 is not greater than 5, but 5 is equal to 5. And if I change number 2, give it a value like 10, now the output, the result, would be false because 5 isn't greater than 10 and 5 is not equal to 10, right? Both the condition are false, and so the final result is also false. So, my dear listeners, these were the 6 relational operators. Each of them take 2 operands, and the result is always a Boolean value. So, relational operators is a first step towards writing logical and real applications. In the next lecture, you'll learn logical operators. Logical operators go together with relational operators, and together we can create more advanced conditions and logic. So I will see you in the next lecture. Thanks for watching. In the previous lecture, you learned relational operators, and that was the first step towards writing advanced and logical programs. The second step, or the tool that you need to code logical programs, is logical operators. So today's lecture is all about logical operators and logic. Logical operators work with relational operators. So make sure you have watched the previous lecture. Right, now coming back to the topic, logical operators. We have 3 main logical operators in programming, and they are called logical AND, logical OR, and logical NOT. And they have their own signs. We code logical AND using 2 ampersand, logical OR using 2 consecutive pipes, and logical NOT using exclamation mark, right? So these are the signs. Logical operators have a couple of things in common. Number 1, they takes 2 operands of type Boolean, except logical NOT. That means logical AND or OR takes 2 operands, left operand and right operand. But operands must be of type Boolean, true or false. However, logical NOT takes only 1 operand of Boolean type, just like increment or decrement operator. So the first thing which is common here is that the operands type must be Boolean. And the second common thing is they return Boolean result. So in short, we can say logical operators work on Boolean and return Boolean. So that was the introduction of logical operators. Let's now move on and learn them one by one. The first operator is logical AND. Logical AND returns true only if both its operands are true. Otherwise, it returns false. So let me code an example to make it clear. So here we're applying logical AND to the operands. We have 2 operands and both the operands are true. This is the only condition where logical AND returns true. Let me show you in the console. And so you see the true in the output, right? So if both the operands are true, you get true. Otherwise, you get false. And there can only be 4 different cases. The case number 1 is that you see both the operands are true. In case number 2, the left operand can be false, so the result will be false. In case number 3, the right operand is false, the result will also be false. And in the 4th case, we can have false on both the sides, and the result will also be false, right? So logical AND returns true in only one case, when both of its operands are true. This is the only case where you get a true result. So this is how logical AND works. Let's now move on. The Boolean values that you see here, I coded them to demonstrate or explain the operator. But in reality, these Boolean values are the results of the relational expressions. And this is where things become interesting and logical. So let's now see the true and the practical use of logical AND operator. I will show you several examples. Let's say in a program, you want to allow numbers in a specific range. For example, numbers from 1 to 10. So 1 to 10 is the range of the numbers. So how would you do that? You can only do that by combining relational and logical operators. There is no other way. So we are reading a number in the program. So after reading the number, I need to find out if the number is in the range or not. So we write here you see a complete example. Now you see relational operators together with the logical AND. So if the provided number is in the range, you will get true. Otherwise, the result will be false. So what's going to happen here? These relational operators returns true or false. So they are going to investigate the condition to the left or to the right and return a Boolean result. And that result is then processed by the logical AND. Now let's say, just suppose if the user enters number 5. So in the first step, our compiler gonna process the relational expressions. So what will happen in the first step? So the 5 is greater than 1. Here we'll get true, and the 5 is less than 10. So here we also get true. So the Boolean value is coming from relational operators. And after that, our compiler gonna apply logical AND to the Boolean values. And we know logical AND returns only true if both its operands are true. So in this case, both the operands are true. So the final result would also be true. Now let's say if the user enters number 15. So what will happen? 15 is greater than 1, true, but 15 is not less than 10. So here we are going to get false. And now the second step, our compiler will apply logical AND to these two values, and the result will be false. So the final result is false because we have one false operand here, right? So we have successfully limited the user input. Our program is not gonna allow anything else or any number outside of the range. Let's run the application. Now, if I provide number 8, for example, and you see in range true, close the application and run it again. Now I provide something out of the range, let's say number 12, and you see in range false, right? Let's have another example. Suppose you are going to program a login application, and in the system you have a user. So we have a user in the system named Peter, password ABC123, and you write some message to the user. And then you read the username and the password. Right, so you already have a user in the system, and here you are reading username and the password, and the user must provide the same username and the password that we have in the system in order to get in. So how we are going to find out the provided username and the password is exactly the same that we have in our system? That can easily be done using relational and logical operators. So if user equals username provided, and if password equals password provided. So if the provided username is also Peter, we are gonna get a true here. And if the provided password is also ABC123, so we are gonna get the true here. And then we will apply logical AND to both the true values, and the final result will also be true. So if you want both the conditions need to be true, you will always choose logical AND. Let me show you the result. Let's run the program. So if I provide name Peter and password is ABC123, so you see user login is true. Let's close it and run it again. And now I provide wrong username. Let's say Julia with the same password, right password ABC123, user login false, right? Now, let me give you one last example, a complex one, before we move on to the next operator. Let's say in a program, we want to perform addition or subtraction on positive numbers. So here we have two conditions. Number should be positive, and the operation can either be addition or subtraction. In addition, the program needs user approval to do addition or subtraction. But this is another condition, right? So we have three different conditions: positive numbers, addition or subtraction, and user approval. So first we are going to gather all the information, all the data from the user. Right, say we have gathered all the information, number one, number two, operation, and the approval. Now I will code the logic for addition. So that should be the logic for addition. Number one and number two should be greater than 0. Sign should be plus and approval should be yes. So if you provide everything according to the logic, you will get true here, true here, true, and true here. And then the logical AND gonna process the true values like this. Our compiler is gonna process these two first, this one and this one, and both the operands are true, so the output of this one will be true and this one will also be true. And now we have the last AND operator. It also has true both the sides, so the final result will also be true. And for the subtraction, we just need to change the sign from plus to minus, right? Let's now run the program. So provide numbers 12, 12, do addition, plus approval, yes. And now you can see do addition true, while the do subtraction is false. Let's close it and run it again. Now I would say 12, 12, subtraction, I would say no. So here you see both the operations are false. Do addition false, do subtraction false, right? So you can run it several times and check different options. So here you see a complex example of logical AND, and you can even break this condition down into several lines. For example, I can break it down into two different lines. First, I'm going to check the numbers and receive a result in a different variable. So here you see the breakdown. The result would be the same. If both the number are positive, we will get true here. And if the sign is plus and the approval is yes, we will also get the true here. And then we will say if numbers are fine and sign and approval are also fine, like true and both the sides, then do the addition, right? So that was the logical AND operator. You will use it when you want all your conditions to be true. Now, next we have logical OR. Logical OR means this one or the other one. Like you're fine if only the one condition is true. So not the all, only one condition to be true. So let's have some examples. I'm going to remove everything I have. With logical OR, you get true if one of its operand is true. You will only get false when both of its operands are false. So there can also be 4 different cases. So let me show you. So this is the case number 1. When both the operands are true, you will get true. But you will also get true if the left operand is false. And you will also get true if the right operand is false. So there are 3 situations where you get true. You get false only when both the operands are false, right? So this is the only condition where you get a false result. So with logical AND, all the conditions should be true to get a true. But here, if only the one condition is true, you will get the true. And the only condition where you don't get true is false on both the sides. So using logical OR in a program, you can do like do this one or this one, approve this one or this one, calculate this one or this one. For example, in a program, you can say if a customer buy 5 packets of milk or cookies, so she will get a discount of 5%. So here we have OR, either more than 5 packets of milk or cookies. So we have a customer who buy milk, 6 packets, and cookie, only 2 packets. With a customer, we get a discount because she buys 6 packets of milk. So we can code it like so. In the first condition, we are going to get true. And here, we get false. And the final result will be true, right? So logical AND gonna return true if one of its operand is true. So the final result is true. And that means the customer will get a discount. Get discount is true now. So that was logical OR. Or you use it when you are just fine with one true condition. To the same program, we can also say the customer gets discount if she has loyalty card. Now we can extend our logic. Right, so the customer will get a discount even if she only has the card. She doesn't need to buy anything more than 5. So we have true here, this one is false, and this one will also be false. But the final result will be true, just because of this one, right? So now you know logical AND and OR and how do they work. And there are some situations, logical situations, where you need to combine logical AND and logical OR. For example, you want 2 conditions to be true all the time, you'll need logical AND. But any one of both the conditions might have OR options, and thus you will use logical OR. Let me give you an example so that you get it well. Let's suppose you're coding a game, and to start a new round, you give user 2 options. User can either press enter or click on the continue button on the screen. So here we have either OR. That means you will choose logical OR. But to start a new round, there is another condition. And that condition is the number of game lives must be 0. Must be 0. Another condition. And that need to be true in order to start a new round. So here we need to use logical AND. So the program will look like so you see both the operators in action in the same logic. Let's say user press enter. So press enter is true. And the user has choose to press enter. That's why press key is true. And press button is false. At the same time, number of lives is 0. So the press key is true and press button is false. So we are gonna get true here finally, because we are using logical OR. And this last condition will also give a true. So it would be something like this. So true from here and true from here, and then true, logical, and true. So the final result is true. Now let's say if the user doesn't press the enter key and selects the continue button, the result will be the same. You will get true, right? So that was logical OR. Let's now move on to the last one, logical NOT. Logical NOT is like a switch, on and off switch. And it's also unary. That means it takes only one operand. So if the operand is true, it becomes false. And if it is false, it becomes true. So it's like a switch, on, off, true, false. For example, here I apply logical NOT on true. So this true is changed into false. You will get false here, not true, right? So not true simply means false. And instead of true, if we have false, the result would be true. So there are only two conditions, true or false. Not false means true, or not true means false. So it's a special one, and we'll use it in our programs later on. Let's say if you want to implement a toggle logic, let's say toggle between dark and light mode, and you can use logical NOT, right? So there are so many places where we need this logical NOT operator. So my friend, that was all about logical operators, and I hope you now have better understanding of them. It was a lengthy lecture, but important one. You can also use the timeline of this video in order to go back and forth. And now we know relational and logical operators. So the next lecture is going to be very interesting, important, as well as lengthy, because we are going to learn if statements, which is the last tool that you need to learn in order to write programs which make decisions. At this moment, we can build logic using relational and logical operators. But to process that logic so that a program makes decision is done using if statements. So in the next lecture, we will be learning and doing amazing things. I will see you there. Thanks for watching.
In the last couple of lectures, we discussed relational and logical operators. And it's now time to put everything together and implement the logic using the if statements. If statements utilize the logic that we create using the relational and logical operators and let the program decide things. Before you start this lecture, just make sure you have taken the last two lectures. Let's move on with one thing in mind. Both the operators, relational and logical operators, they both return a Boolean value that can only be true or false.
The if statement takes that final Boolean value and then let the program decide. This lecture is going to be lengthy because if statements have several different variations and we learn all of them. So you can simply take pause if you feel yourself tired or overwhelmed, and then come back again, continue the lecture where you left off. You can simply use the timeline of this video to remember your progress, right? Let's now move on. The first thing that you need to learn is the structure and the behavior of the if statement. So let me code an if statement and then I'll explain it to you. Here we go. You see a fully functional if statement. The structure of the statement is simple. There are three important things in the structure I want to point out. The first one is the keyword if. If a statement starts with the keyword if. The second important thing is these two small parentheses. So the keyword is always followed by these two parentheses. And the third important thing in the structure is the if block or if body, which is created using curly braces, right? So that is the structure of the statement. Keyword, small parentheses, and block. Let's now talk about the behavior or the functionality. How does it work? Inside the small parentheses, a Boolean value is investigated. If the value is true, the statement gonna let you in. That means you will come inside the block and the statements are executed. So the code that you see here will only be executed if the investigated Boolean value is true. In this case, the value is true. If I run this program, you will see this output. So let me show you. Now here you see the output. I am inside the if block. Let me change the value from true to false. When the value is false, you will never ever come inside the block. Now you won't see anything in the output. Here say nothing, right? So we never come inside the block. So that is the behavior of the if statement. Now the Boolean values to the if statement are actually the result of any logical expression. We do not code true or false directly to the if statement. We actually code an expression that results in Boolean. Now you will see a real example where we investigate an expression. Let's say in a program, you want to calculate number raised to the power 2, but the number should be in a range between 1 to 10. If the number isn't in the range, we won't calculate raised to the power 2. So our program is going to make a decision based on the number provided to it. So we are going to input a number. After the input, we will investigate if the number is in the range or not. So if the number is in the range or in between 1 to 10, this expression will return true. And that Boolean true is processed by the if statement. We can print result in the console. So let's run the program and check it out. And here I provide number 8, which is in the range. Now we see the result, right? 64. Let's run it again. And now I provide number 12, which is outside of the range, and I won't see any result, right? So here you see a practical example. If statement in action, and our program decides what to do. So this is our variation number 1, where we have a single if statement in a program that does something. But sometimes we need to execute other code when the expression's result is false. In that case, we use the else together with if. Else is also a keyword and it connects itself to the if block. So where you close the if block, you code the else statement. Else statement cannot stand alone. They are always connected to the if block. That means if I put something here, for example, a variable in between, our program will complain because this else is now detached. And in the error list, you can see else cannot start a statement, right? So it cannot stand alone. So remember this thing. So when the expression results in false, you will always come here in the else block. And here we can print a message like save the number provided between 1 to 10. You will come here. And when the number is out of range, we will come here. So let's run the program and provide a number which is out of range. Let's provide number 15. Now I see the message from the else block. Number provided is out of range. So that was the second variation, if and else. And here I want to point out one more thing. I have seen several students trying to investigate an expression with else like this. For example, so this is not allowed. You can't investigate expressions in the else section. Let's move on. The third variation. The third variation is interesting. It's about coding nested if statements. When you code, there's so many occasions where you need to evaluate several different expressions. It usually depends on the requirements. We sometimes have a first level check, a second level check, a third level check, and so on. So let me give an example so that you get better understanding. I want to make some changes in the program and we put some more condition. The condition 1 is the older one. We want number between 1 to 10. And in that specified range, we have the even numbers and the odd number. So I want to calculate number raised to the power 2 only to the even numbers and number raised to the power 3 only to the odd numbers. So there are 2 more conditions, level 2 conditions. This one is the level 1 condition and the others are level 2 condition. So we make sure first the number is in the range and then we process further. So our enhanced program is going to look like So here we have a solution. If the number is even, then raised to the power 2, and if the number is not even, then raised to the power 3. The second if statement, it's not necessary, and you might have thought about it. If the number is not even, then it is odd. So we don't need to investigate for the odd numbers. We can even simply code an else block like this. This one is a better solution, but the result in both the cases would be the same. Let me give you another example, but this time we'll code a complex program. We'll code a simple ATM machine where the user needs to log in by providing right PIN code. And after that, there will be 3 options: check balance, cash out, and deposit. And user can choose any one of them. This is gonna be an interesting program with many conditions. So let's code it. So the development up till now is very simple. We have a PIN code in the system. A user needs to provide the same PIN code in order to use the ATM. And this one is the initial balance. Now here we want user to enter the PIN code. So as soon as user enters the PIN code, we are gonna process it. So this is the level 1 check. If the provided PIN code is wrong, user will see this message. Otherwise, we'll come inside the if block. And here we'll program the entire application. In my ATM, we have 3 options: show balance, cash out, and deposit. So let's code the option. Right, so here we have 3 options: balance, cash out, and deposit. You will need to press 1, 2, or 3 respectively. So let's run this program now and check the development. So here we go. Now provide the PIN code 1, 2, 3, and 4. Press enter, and now you see the options. Program is working, looks good in the console. Let's now move on. And now we need to code the options, and it can be one of them. So if the provided option is 1, we are gonna show the balance. And the name of the variable is bank balance. The second option is a cash out. And to make a cash out, user need to tell how much. So we need to read the amount user wanna cash out. Now here comes another condition. This is the level 2 condition. Inside the level 2, we need to code another condition, and that can be the level 3 condition. You can't cash out more than you have, so we need to code another condition. So you can only cash out if the cash out amount is less than or equal to the balance. This is an important condition, and every ATM implements it. And after the cash out, we can print the current balance. But if the user inserts the amount more than she has, then we need to inform her. Now let's see how we are coding and controlling the program flow. Nested conditions. Let's now run the program and check out the developments. So provide a pin code 1, 2, 3, and 4. And here I want to show the balance first. So here you see your account balance is $1,000. So let's run it again and check the cash out option. Now the cash out option, and I need to provide the cash out amount. Let's say $500. And you see the current balance is 500. But why we are getting the insufficient funds message? Something is wrong with the code. We have missed the else statement here, right? That was my mistake. So let's run the program again. So provide the code 1, 2, 3, and 4. Number 2, cash out option. Provide the amount. Let's say $800. And you see the current balance is 200. Let's now run the program again. Log in. And now I want to provide, and now I want to give a big amount, like $1,200. And here you see insufficient funds, right? And the third option is the deposit option. And I leave this option to you. Program this option, give it a try. So that was the variation number 3. It was about coding nested if statements or if else statements, right? Now the last variation. The last variation is another interesting structure. Using the if else, you can choose between 2 choices. But sometimes we need to investigate and choose among several choices, just like in our ATM program. So here we have more than 2 choices, right? We have 3 options, 3 choices. So in that case, when you have more than 2 choices and you need to choose only one, you use if else if structure. So how do we code it? Let me show you. Let's say we have a number 10. Now we say if number is less than 0, so print negative number in the console. Now here's the else if. So if the number greater than 0 and number is less than or equal to 50, then I will print number is between 1 to 50. Then I would say again if number is greater than 50 and number is less than or equals 100, then I will print number is between 51 to 100, and then I will close the entire if else using an else block. So if nothing becomes true inside the else block, and here we say the number is greater than 100. So this is the variation number 4. It's an structure if, else if, else if, else if. And you can close the else if structure by coding the else block in the end. If you don't need it, then don't code it. This structure has an advantage over alone if statements. For example, you can code this program just by using the if statements like this. But the problem here is that our program is going to investigate all the if statements. We get a true value here, but our program will also investigate this one. So this is the disadvantage of coding standalone if statements. If they can be combined, then you will combine them. So in the if else if, when this one becomes true, for example, our compiler won't investigate the others. And if the first one is false and this one become true, our compiler won't investigate this one, right? So you get better performance with this structure. So as we know the structure, and I can see it applies to our ATM program. So we have three options and we need to execute only one option at a time. So we can change our program like this. So you see the practical implementation of if, else, if structure. So my dear listeners, now we are done with the conditionals. Now you can write amazing programs. You can control the flow and you can make decisions. So that was all about the conditionals. Do some practice. I will see you in the next lecture. Thanks for watching. In our last lecture, we talked about if statements. We learned to code them in several different ways, and I must say that was a long and very comprehensive lecture. So if statements are used to perform selections, a program can take different alternatives or do different things. However, in addition to the if statements, there is another tool that can let a program select different options, and that tool is called switch. So we have two different ways to select between different alternatives: if statements and switch statement. Switch can be used instead of the if statements in several different scenarios, but switch is not a replacement to the if statements because they are two different tools and they work on different types. If statements work on Boolean, whereas switch matches patterns. In addition, switch has some limitations. For example, you cannot process object type directly in the switch statement, and you can't even write and evaluate complex logical expressions. However, simple and straightforward logical expressions can be used in the switch using relational and logical pattern matching. So we are going to learn to work with switch case statement, which is a pattern matching tool. It lets you perform selections and you can use three different patterns: constant, relational, and logical. So we are going to learn all of them and write many practical examples. So let's start with the constant pattern matching as well as study the structure of the switch statement. I'll code the statement first and then I'll explain it to you. So here you see the switch statement in the selection mechanism. Let's look at the structure. The structure is pretty simple. We start the statement using the keyword switch followed by two parentheses. Inside the parentheses, we pass an expression or a variable, and the switch has its own block or the body, which is marked using the curly braces. Now, inside the switch body, we code different cases. The value which is passed to the switch statement is compared itself with the cases, and when the match is found, so the statements inside that case are executed. Now you see, to the switch statement, we are sending a variable. We are passing a variable with value 10. So in this case, we'll get a match here. The value 10 matches with the case value 10. And that means the statement only inside the case 10 is now selected by the program. So if I run the program, you will see this output. At the same time, we have to break every case using the break keyword. The break keyword is important. It terminates the execution of the program as soon as the matching is found. For example, in our program, we found a match here. This one is the output. Now, stop the execution of the program. So we don't want our program to go further and investigate all the cases. Break is also the part of the syntax, and that means you can't simply just forget it. If I remove it from here, I will get the error. So we have three cases: case 10, case 20, and case 30. But at the end, we have a default case. The default case is for default. When there is no matching here, then this one is executed. So this is how switch statement gonna work. So let me run the program and you will see number is 10 in the output. And here you see the output from the case 10. If I change the number to, let's say, 30, then we'll get a match here, and that would be the output. And instead of 30, if I pass another number, let's say 50, now there won't be any match, and you will see the default. Let me show you. And here you see the default message. Number is unknown. Let's now move on and learn some practical variation. The matching is called constant pattern matching because each case contains a constant value, and that value must have the same data type which is passed to the switch statement. So I'm passing the integer type, and that's why I'm coding integer values. And you can have values from all the primitive data types like string, character, floating point, etc. In addition, you can also have enum and nullable types. So let's code another example with a different data type. Let's say a program that reads an alphabet and tells if the alphabet is vowel or consonant. So the program is going to look like so here we have the program that tells if the alphabet is vowel or not. And now we are working with the character type and so the values in all the cases. So let's run the program. And if I provide a vowel, I will see the vowel. Let's run it again and provide P, which is not a vowel, and I will see consonants. So the program is working, doing selections, and we are getting the right result. But this code can become better. In switch statement, you can even create grouped cases. That means you can group several cases into one if they all are doing the same thing. For example, these 5 cases, as you can see, execute the same statement. So that means we can group these cases. And how do we do that? Let me show you. So here you see the much better version. All these cases are now grouped into one. If any one of them is matched, you will see the output. So let's run the program and check it out. Provide a vowel, and here you see the output, right? So that was an example on character constant matching. You can also pass a string type if you want. Let's have an example before we go further. So here you see an example on a string pattern match. The day is the string type and the value is Sunday. So we are going to get a match here, and that would be the output. So that was all about the constant pattern matching in the switch statement. Let's now move on to the relational pattern matching. In relational pattern matching, you can use 4 relational operators to compare a result with a constant in the switch statement. And those relational operators are greater than and equal to, less than, and less than and equal to. So these 4 relational operators are allowed to use while creating relational pattern. So let me give you an example so that you get better understanding of it. We have a number, let's say 100, and I pass this number to the switch, And now I will create two different cases. So this is called relational pattern matching. We are trying to compare the case with the constant. You're not allowed to use any variable instead of these constants. So now in our case, the number has a value 100 and the 100 is smaller than 500. So that would be the output. So let me run the program and show you the result. And so you see the number is less than 500. And if I provide something greater than 500, that would be the output. And here we say the number is greater than 500. And if you somehow get something else which is not a number, this one would be the output. So here you see simple relational pattern matching can be performed in the switch statement, but not the complex one that we can do with the if statement. There are limitations. Like I said, you cannot replace this constant value with a variable. And one more thing, the relational and the logical pattern matching was introduced in C# 9. So if you're not using C# version 9 or the earlier version of C#, then you won't be able to perform relational pattern matching, right? Now the last one is the logical pattern matching. And this one is interesting. We can create logical patterns using the keyword and, or, and not. So we have three logical pattern matching operators: logical and, or, and the not. Logical and, or, and not work with Boolean value, whereas these three offer logical pattern matching. They can't replace each other. They are two different things. So let me show you an example before we wind up this lecture. And I am thinking to reuse this piece of code. So the logical AND uses the same logic. Both the operands should be true to get a match. Now let's say in the first case, I want to check if the number is greater than or equal to 1. Like number is between 1 to 100. So I would like so if the number provided is between 1 to 100, where 1 and 100 is also included, we will get this match. And if the number, let's say, is greater than 100 but less than or equal to 200, then we are going to get this match. But at the same time, I say I want this match, right? But also I want to exclude a specific number. So I would write and not 150. So this case is going to match any number from 101 to 200, excluding 150. So the number is 101 to 149 and 151 to 200. So all the numbers in this range gonna get a match here. The last one is the logical OR, and it implements the same OR logic. So I can write a case like to all the numbers greater than 500 or all the numbers less than 0. So the numbers greater than 5 or all the negative numbers gonna get a match here. So it includes number like above 500 and negative. So let's give it a run. The value of the number is 600 and 600 is greater than 500. So we got a match here, and that would be the output. Let me show you. And so you see the match above 500 or negative. Let's change the number to any negative value. Let's say -5. Now once again, we're going to get a match in our third case value. This one is going to be true. And so you see the same result as before. And if I change the value to something between 1 to 100, I'm going to get this match. Let's check it out. Let's say the value is 75. And you see the number is between 1 to 100, right? That was this one. And if the value is from 101 to 200 except 150, we're gonna get this match. Let's say the value is 149, and here's the output, right? That was this one. And the 150 is not gonna get match anywhere, right? So you will see this one in the output. You can change the output like any number. So if we change the value to 150, let's see what's happened. And here's say any number, right? So that was the logical pattern matching. So listeners, in this lecture, we learn switch statement with constant, relational, and logical pattern matching. So do some practice with the switch statement so that you remember its syntax. I'll see you in the next lecture. Thanks for watching. This is our lecture number 20 on C# cancel programming course. We have been discussing conditionals in last couple of lectures, and I hope you now have good understanding of if and switch statements. This lecture is also about making decisions in a program, but not either using the if statements or the switch statements. Now, in addition to the if and the switch statement, we have another operator in C# that can also be used in decision making, and that operator is called ternary operator. Ternary operator is a shorthand version of an if-else. That means an if-else can easily be replaced by the ternary operator. The operator has its own syntax, which you can also see on the scheme. The syntax is divided into three different parts: the condition, true action, and the false action. And there always be an assignment. That means the syntax is gonna return some value. The true action is marked using the cursive character, and the false action is marked using the colon. The operator is gonna evaluate a condition. If the condition is true, then the true action is executed and a result is returned. And in case of false evaluation, false action is executed and a result is returned. So the syntax is very compact, and like I said, it's a shorthand version of an if-else statement. So let me write a program with if-else statement, and then we will modify the same program using ternary operator. So in the program, I have an age variable and a string variable like this. Now, using the age value, I want to know if the person is adult or minor. A very simple program. If a person is 18 or above 18, he or she is adult, otherwise minor. So this version of the if statement can be replaced by the ternary operator. So let me show you how. Let us see a very concise code, one line based condition. So if the condition is true, adult is returned, otherwise minor is returned. And this code is irrelevant now. So let's run the program and check it out. And here you can see the output, adult, right? So that was the ternary operator. It's simple, elegant, and a powerful tool. You can use it in simple condition-based assignment. There should be an assignment. But if you have more complex condition and want to perform multiple actions, then you will go for regular if statements. So that was all about ternary operator. Write some programs, do some drill. I'll see you in the next lecture. Thanks for watching.
In the last couple of lectures, we have been learning selection making using if statements, switch, and ternary operator. Now we know how to write programs which can have different program flows based on the data provided to them. What else we know after the if statements is that how to tackle Boolean value. To tackle a Boolean value or to just investigate a Boolean value, we use if statements. In this lecture, we are going to learn another type conversion method which is called try-parse. Try-parse is safer than the parse method which we have been using throughout this course up till now. You know, when the parse method fails, it throws an exception, and an exception is simply a runtime error. That means our program crashes. On the other hand, try-parse is actually a safety net around your program. When try-parse fails in conversion, it does not throw any exception. The method simply returns a Boolean value, true or false, that represents if the conversion went well or not. We waited for this method to cover just because of the Boolean value. But now we know how to tackle and investigate the Boolean values. We are in a good position to learn and understand the use of the try-parse method. We are going to start this lecture with a problematic scenario. Now let's say in a program, I just want to read integer values, only the integer values. Very simple program. We are reading a number or integer number and printing that number out in the console. That's it. Now the problem here is this parse method. As long as I am providing a data which is integer, our program will work. For example, 1, 2, 3, 4, 5, etc. However, if I happen to provide data which cannot be converted to integer, our program will crash. For example, if I provide ABC, only A, or just an empty string without writing anything in the console, I press enter, so an empty string is written in the program, or maybe a space. In all these cases, this method simply fails and throws exceptions. So let's run the program and check it out first. Here is our application and it's asking for a number. I do not provide any number, only press enter. I hit enter and you'll see our program will simply crash. And so you see a format exception is thrown that says the input string is not in the correct format, right? Let's now run the program once again, and now I will provide floating point number, right? As you see in the background, we are trying to convert the data to integer, but I will provide a floating point number 1.2. For example, now our program will crash again. You can see our program is now crashed. So that simply means if you are working with the parse method, then you must be very careful what you write in the console. If the format is different that cannot be converted to integer using the parse method, the program will automatically crash. Now, in order to avoid this thing and unnecessary exceptions in the program, we have much safer method which is called try-parse. So let's see how try-parse can save us from the troubles. I am going to write the same program, but this time I will use try-parse. And I want you to put focus on the screen and on the code. Enter integer value. And now I will use the try-parse. As you know, try-parse returns a Boolean value. That's why we need to capture or save that value somewhere in a Boolean type variable. And now we will call try-parse using integer. So you see the calling of the try-parse method, and this method actually takes two parameters: input source and output source. Input source in this program at this moment is console.readLine. We are going to read input from the console, then comma. We usually put a comma when there are more than one parameters. The second parameter is the output source, and here we use a reserved word out and now the name of the variable. For example, integer value. That's it. Syntax of the try-parse is not so difficult, right? We need an input source. Input source is actually the data we want to convert, and the output source can be a variable that holds that converted data. Now, if the conversion and the assignment to this variable goes well, this entire line of code will simply return a Boolean true value, and that value we are saving in this Boolean OK variable. On the other hand, if the conversion or the assignment does not go well, this line of code or the method will simply return a Boolean false value. In both the cases, when conversion goes well or not, our program will not crash, and that is the point. Before we run this program, we can simply check the status of our Boolean variable, right? So let's run the program and check the output. But before that, I think I need to disable this line of code. Let's run the program now. Here we go. Now enter a value first that can be converted to integer, for example 12, and you see the Boolean value true. That means everything went well. Now close the program and run it again. Now I will provide a value that cannot be converted. For example, ABC. Let's enter. Now you see the Boolean value is false. That simply means the conversion and the assignment did not go well. The point is here, as you see, our program has no exception. And that is the main reason of using try-parse method, right? So now we know the method returns a Boolean value. That simply means we can use this or investigate this Boolean value before we start using this variable. We can simply, in an if statement, write a program like this. If the value in the variable is true, let's say we are going to calculate the square of the value. Let's multiply the value by itself. And in the else statement, we can print a message to the user like value is invalid. Okay, if the value provided by the user is real integer value, we are going to calculate the square. Otherwise, we will inform the user about the incorrect value. We can also do a variation here. As you know, the return value is Boolean. That simply means we can code this entire line of code directly inside the if statement like this. It's a very common and practical use of try-parse, just coded directly inside the if statement. As we know, the return value is Boolean. Now run the program and check the output before we move on and learn some more variations. So here is a control window. Let's provide a value 100, and here you see the square of the value. Now we will talk about the input source. We are using here ReadLine to read data directly from the console. Instead of the read line, we can also have any constant value. We can have a variable containing a value. For example, I can put constant value here like this, 12. This will work perfectly fine. The value 12 will be converted to integer, and you will see the square of the 12, which is 144, I think. And now the output source. Output source is a variable. We are creating this variable directly inside the try-parse method. We can also create this variable outside. For example, here outside of the method, I am going to create variable integer value like this. And now we can simply use this variable inside the method. Integer. Sorry. This can also be done. The output variable can be created outside of the try-parse method. And lastly, I will show you how to extend this investigation using the logical operator and investigate further this value. For example, in a program, an integer value is required, but there is an interval. The value should be between 1 and 10, where the 1 and the 10 are also included. We can expand our investigation using the logical AND, and now we can further investigate our integer variable. Greater than equals 1 and value should be less than equals 10. So you see, we are doing several things in a single line of code. Let me just change input source back to console read line like this. So we are reading a value, and this part will simply make sure the value is integer, and this part will make sure if the value is in the range or not. Let's now run the program and check the output. Here we go. And first I will provide a valid value. For example, the value is 9, and here you see the square 81. Close the program, run it again. And now I will provide a value which is greater than 10, right? Outside of the interval. For example, 11, and here you see the output. The value is invalid, right? The try-parse method can also be used with the loops. Loops we are going to cover later on in this course. So my listeners, in this lecture, we learn to use try-parse method, which is safer than the parse method. Do some tricks with this method. I will see you in the next lecture, and thanks for watching this one.
In the last couple of lectures, we have been learning logic. We learned how to code if statements, switch statement, and ternary operators. So we have covered all the tools which are required to create logic in a program. And it's now time to go ahead. This is our lecture number 21, and in this lecture, you will learn to create random numbers in C#. Random numbers are required in so many applications, especially in simulation or in game development. For example, in our classic snake game, the food is placed randomly somewhere in the game plane, And that point where the food is placed is actually calculated by random numbers. You can also create so many interesting applications using the random numbers, such as dice simulation. And we will also try to simulate a dice in this lecture. Okay, so random numbers in C# is actually generated by a class which is called random. Every programming language provides a mechanism to generate random numbers. In C#, we have a class called random. Random class is a built-in class in .NET. You don't need to write any code for it. You just need to use it in a right way. So let's consult with the official documentation of the random class. Random class belongs to the system namespace and it is used to generate random numbers. And if we scroll down a bit, here we have examples. In order to use this class, we need to generate a variable of that type, of random type. And once we have random variable ready, we can call the methods to generate random numbers. So let me just scroll down a bit more. So here we have methods to generate random numbers, and there are so many methods offered by the class. I will show you how to call 3 to 4 methods. And once you know how things are working, then you can do some more experiments by your own. The most common method that we use to generate random numbers is next method. And next method comes with different versions. Next with no argument, next with 2 arguments or parameter, and next with 1 argument. And here we have a small description. If I use the next method with 2 parameters, so it will return a random integer that is within the specified range. That means these 2 parameters will specify a minimum and maximum range. And we also have next double, which is used to generate a floating point number which is greater than or equal to 0.0 and less than 1.0. And down there we have a next single, and here we have a random number, a floating point random number, where we will also get the value 0, greater than or equal to 0 but less than 1. And if we use sample method, we will get a random number between 0 and 1, where the 0 and the 1 is also included. Now, like I said earlier, in order to use this method, we will first create a random variable, right? And here is the syntax to create a random variable. So let's go back to the code. We will create a random variable and then call some interesting random methods. So our random variable name is R&D, new, and random. This is how we create a class variable. R&D is a random type variable, and here we are calling the class constructor. When we will learn about the classes, we will discuss more about it. Now, once a variable is ready, using this variable, we can simply call all the methods. We will first write the name of the variable, then point operator, and after that, we will call the method. The first method we will call is next method with 2 arguments. Let's say the first argument or the minimum argument is 1 and comma, the maximum is 10. Now we will simply get a random number range from 1 to 9. The upper bound is excluded. It is not included as per the documentation. So this is the range of our random number. We are actually using this version, next method with 2 arguments. If I click on the link here, and here I can read the minimum value and the maximum value. The minimum value is inclusive, whereas the maximum value is exclusive, right? So let's run the program and see what do we get here. And here we go. The random number we got here is 7. Every time we run the program, we will get a different random number. So let's close the window and run the program again. And now you see the random number is 8. Once again, random number is 5, right? So we are getting different random number in every execution. Let's now call another version of next method, which is with 1 argument. Let's say I just want a random number under 100. So we provide only the 1 argument, and it will give me a random number range from 0 to 99. Once again, the maximum value is excluded. So let's run the program and check the output. You see the random number is 48. Let's run again. 77. Run again. 57, right? So this is how we generate random numbers using the next method. Next method generate integer random numbers. Let's now learn about the floating point random numbers. For floating point random numbers, we have different methods. For example, we have next double like this. It takes no parameter and gives a random number greater than or equal to 0 but less than 1. So you will never get 1 when you call this method. The max value should be something like 0.99999, right? So let's run the program and check the output. Now you see a floating point number 0.4, close the window, run it again. Here comes another 0.43, close the window, run it again, 0.34, right? So it wasn't so difficult to generate random numbers in C#. Later on in our coming lectures, we will use random numbers in different scenarios. And finally, if you want to simulate a single dice, then you will call the next method with 2 parameters. So let me just copy this here and paste this line of code here. And you know the dice has a limit, low limit and higher limit. The low limit is 1 and the higher limit is 6. So now instead of 6, I will put 7 here because we know now the maximum value is not included. So we will get a random digit here from 1 to 6. So let's run the program and see what do we get. So here you see a dice value 4. Let's close it. Dice value is 1. Close it. And here the dice value is 6. That was all about random numbers generation in C#. Visit the documentation and try out some other interesting functions by your own. I will see you in the next lecture. Until then, take care of you. In the last lecture, we learned to work with the random class. We learned to generate random numbers, both integers and floating points. And in this lecture, we're going to learn another interesting and important tool, which is called date time struct. Date time struct is used to work with the date and time in the application. And you know the importance of the date and time. Almost every application or the project implements date and time. For example, if you are creating block application, payment application, or booking application, then you will definitely work with the date and time. There is no way to create a booking system without working with the date and time. So it's an important topic and I want you to not to miss anything in this lecture. Now, while working with the date and time, there are some common use cases we need to know, such as getting the current date and time, formatting dates, extracting different parts like year, month, day, hours, minutes, and seconds, performing date time calculation like subtraction between two dates and two different times, comparing dates, and working with the time zones. So these are the common use cases we need to learn. And in this lecture, we are going to cover all of them one by one. Let's move on and learn this interesting tool. When we consult with the official documentation, it says date time is a struct, it is not a class, and this is also the part of the system namespace. And when we scroll down, there is a lot to work with. Date time has constructor, which is heavily overloaded, as you can see here. Further scroll down, it has some fields, it has properties, and it has methods. And there are a lot of methods to work with. You can see here, the list is very long. So we cannot cover all of them, but we will cover most commonly used properties and methods. And for further reference, you have this documentation. You want to learn something new about it, just come to this documentation and find the topic. So let's go back to the code and learn how do we use date time in different contexts. The first thing we want to learn and experiment with is how to print current date and time. In order to print current date and time, we have a predefined property in the date time struct, which is called now. So let's call this property and get the current date and time. So we are simply calling the property now with the help of date time struct, and here we have period operator. The return value of this statement is a timestamp, and that's why we need an appropriate variable to save the timestamp. So dt is the name of the variable and the type of that variable is date time. Now we can simply print the dt variable to see the output. And so you see the output, right? This is a current date and time in the console. So using the now property, we can simply get the current date and time of our system. So that was the first point on our list, how to get the current date and time. And for that, we can simply use the now property. Now, the second point on our list is how to format a date. And for that, if I scroll down, so we have toString method. We can use toString method to format the date. As you can see, there are several different use of toString method, and it can also be used for formatting. So let's see how do we format the date using the toString method. We are going to write another console WriteLine and our date time object, and to that object we will call toString method. And to the toString method, we are going to pass a format pattern. For example, I want full year, then a dash, then I want month, and then I want day. So to the toString method, I just pass a format string. Now the date should be like this. So let's run the program and see if the format is changed or not. So you see in the output, the format is changed, year, month, and the day. So this is how we can format a date according to our requirement. And there are several different formatting strings we can provide to the toString method. Let me show you some more examples. So here you see two more examples. Here we are going to get a date in this format, month, day, and year. And here comes the time. And in the last one, we are going to get the day name and the month name and the day date. So let's run the application and check the output. Here is the format of our date. This is the time. And today is Wednesday, June 11th. So once again, consult with the official documentation. Here we have the toString method for date formatting. And if I click on the link here, and then it's scrolled down a bit. So here we have a custom format string, different examples, different strings, and here we have the output examples. So you can see we can format a date in several different ways using the toString methods. So check out some more formatting strings. Here we have some examples, right? So that was the second point on our list, format date and time. The third point on our list is extracting different parts like year, month, day, etc. So in order to extract different parts, we have predefined properties. If we look at the documentation again, under the properties table, we will find many properties like day property, hour property, minute, month. Now we use recently, today, and year. So using these properties, we can simply extract a single part from a complete date time object. So let's call some of the properties and see how do they respond. Now, for example, if I just only want to extract the year, so I can write something like this. And now we can publish the year variable in the console. So year property will simply extract the year from the date time object variable and then assign the year value to this year variable. For month, we can simply call month property like this. And for day, so we can simply call the day property. And we can also extract minutes and hours like this. We can even extract seconds, milliseconds, etc. So let's run the program and check the output. And so you see the output in the console: year, month, date, minutes, and hours. So that was the third point on the list, extracting different parts. And now we know how to do that. Our fourth point on the list is performing date time calculation. Date time calculation can easily be performed using the predefined methods, such as we have add days, add months, add years, etc. We can also subtract two different days and times to get the difference. So let's see how do we do some basic date time calculations. I will first create another date time variable. Let's call it today. And here I will assign today property, not the now property. The now property that we used earlier returns both the date and the time. The today property returns only the date, but the time components is also there, which is set to the default. So now we have today's date in today variable. After that, I'm gonna create another variable of date time, and the name of the variable is after 5 days. So what would be the date after 5 days if we start counting from today? To find it, we are gonna simply call the add days method to the today variable. We're gonna increase the date with 5 days. So instead of 1, I'm gonna send the value 5 to the add days method. Now, as we know, today is 11th June, and after 5 days, the date should be 16th June. So let's just print the value of the variable after 5 days and run the program. And here you see the output. The date after 5 days is 16 June, right? So we simply added 5 days to the current date and it worked. We can also calculate the difference between the dates. For example, I want to know the number of days in between. I will simply perform a subtraction like this, and it will get me a result of 5 because there's a 5 days difference between these two dates. So let's run the program and check the output. And so you see the value 5 in the output, right? Now, instead of add days, we can also call add months, add years. So let me show you an example of add months. We will create a new variable. Let's call it after 4 months, like this. And to the current date, we will call add months like this. And if you add 4 months, and now we can calculate the difference between the dates after 4 months minus or subtract today. So let's run the program and check the output. And so you see the output in the console. 122 days. You won't see the number of month here. You will see the number of days in 4 months. And this is because of the months have different length, 28, 30, and 31. So the system cannot convert the number of days into months. If you want a month number here, then you need to write a custom function or a method for it. So that was the add days and add months method. On the documentation, there are more methods to experiment with. Just go there and do some more experiments. Now, before you move on, there is an important thing you need to understand. The difference of date and time has a different nature, and it cannot be assigned to any other variable. For example, let's say here we have a difference, and I want to assign this difference to a integer variable. So I will write something like this. Now our program will complain. This difference is actually a duration. It is not a time stamp. And we cannot even assign this duration to a date time variable like this. So you see our program is still complaining. To save the difference of time and date, we actually use time span variable. Time span is also a struct which is used to hold or save the duration, the difference between two dates or time. For example, if you want to calculate the performance of your code, the execution time of your code, so you can code something like this, a variable to store the start time like this, date, time, sorry, time now, a variable to store the end time, and in between you have your code, bunch of code. So you have your code in between. So we are recording the time before and after, and in between we have our code. Now we can simply calculate the difference within the subtraction, end time minus start time. And to say the difference between the times, we need time span variable because it's a duration. So it will be something like this: time span, performance, end minus start. So that was the time span struct. Just read about it on the internet. It also have some useful properties like total minutes, seconds, milliseconds, etc. So let's now move on. Our next point on our list is date-time comparison, which is also an important concept. In order to compare date and time, we can simply use the relational operators like greater than, less than, and equal to. So let me show you an example of that. We create a new date time variable. Let's call it today date and place today date in the variable like this. Now I will create a future date using the date time constructor. For example, the next year, the year is 2026, the month is same, June, and the date is also same, 11. Now we can compare these 2 days using the relational operators. In if statements, we can write something like this. If the future date is greater than today, for example, console write we are in future, and else if the future date is less than today, then we are in the past, definitely. Otherwise, the dates are the same, and we can write, let's say, same day. So at this moment, we know the future date is set to the next year, 2026. So this if statement gonna become true, and that should be the output in the console. So let's run the program and check the output. And so you see the output in the console, right? Future. And if I change the date to, let's say, 2024 in the past, so this statement will become true, and we will see past in the output. So let's run the program, and so you see past in the output, right? So performing date comparison is quite simple. Now the last point on our list is working with different time zones, and that point is actually your assignment. Look for it on the internet, search the documentation, and see how do we work with local time and a universal time. So that was all about working with date and time in C#. I will see you in the next lecture. Thanks for watching and take care of yourself. In the previous lecture, we covered date time struct. Date time struct is used to work with date and time in applications. We have also covered the tools which are used to create logic in a program, like if statements, switch statements, etc. So now we are in a very good position to learn another essential tool, programming tool, which is called loop. Almost every program does some sort of task repetition, such as processing every item in a list, which is a task repetition, or checking user input until it is valid. It is also a task repetition, or maybe running a game loop over and over again. Right? So the task repetition is a key job that most of the programs do. And that repetition cannot be implemented without loops. So, loops in programming are used to create repetition. They allow us to execute a block of code again and again, multiple times. So, my friends, from this lecture, which is lecture number 23, we start learning the loops in C#. When it comes to the loops in C#, we have 4 basic loops, and they are called while loop, do while loop, for loop, and for each loop. So these are the 4 loops that we have in C#. The first 3 loops in the list, while, do while, and for, are universal loops. That means every programming language has these loops. For each loop is also the part of most of the programming languages, but it is sometimes implemented in different ways. For example, in JavaScript, for each loop works differently. It works together with the function, and we call it for each function loop. Right? So first 3 loops are universal, and you will find them in all the programming languages. So we are going to cover first 3 loops one by one in different lectures. In this lecture, we will learn the use of while loop, how do we code while loop, and the use of the while loop. In the coming lecture, we will learn do while loop, and then we will learn for loop. The last loop, which is for each loop, we will cover later on, because for each loop works together with a collection. We need a collection like an array, a list, a dictionary, etc. So as we learn the collections later on in our course, then we will definitely cover the for each loop, which is an important and very useful loop. So let's move on and see how do we code and work with the while loop. So our topic is loops in programming, and the loop we are going to cover here is while loop. Every loop has its own syntax, and so the while loop. When we code a while loop, we start with the reserved word while, followed by two small parentheses, and these two small parentheses are followed by code block or while body. Inside the small parentheses, we code a condition. And inside the loop block, which is marked with these curly braces, we write the code to repeat. So this is the syntax of the while loop. Now the question is, how does it execute? How does it work? The execution of the loop is quite simple. While loop will continue to repeat its code block as long as the condition here evaluate to true. That means as the condition here evaluates to true, the while loop will repeat the code. And then after the repetition, while loop will again evaluate the condition. If the condition is still true, while loop will repeat the code once again. And then again after the repetition, while loop will evaluate the condition. So it will continue in the same pattern as long as the condition evaluates to true. And once the condition evaluates to false, loop will stop working immediately. So one thing we know for sure now, the while loop just requires a true value in order to create a repetition. So that means if I write the boolean true here, the loop will continue to repeat the task without any interruption. So a while loop with a constant true value is a continuous loop, is an infinite loop. So this while loop will never be stopped because the condition is always true. One should be very careful while working with an infinite loop because the infinite loop can demand a lot of resources from the system. In order to stop an infinite loop, we use break statement. Break statement we are going to cover in coming lectures. So now we have our functional loop. Although the loop is infinite, but it will work. So what do we do? In the loop body, we simply print a string hello and run the application. And so you see the output. The loop is going very fast and repeating its code block. Hello, 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 hello. Let's close this window now. Now we know the syntax and the execution of the while loop. Let's now learn the ideal use of the while loop. Now let's suppose I want to repeat a task 10 times. So I will start with a variable, a loop variable which I will use in the condition to create a condition for the while loop. So I will create a variable. Let's say the name of the variable is count and I will put value 0 in it. And now I will create a condition in the loop, something like this, as long as the count is less than 10. So as long as the value of the count variable is less than 10, this condition will evaluate to true. And true means the loop will repeat its code block. And then inside the loop, somewhere we need to change the value of the count. If we don't do that, the value of the count will remain constant. And if the value remains constant, the loop is infinite loop. So what we're going to do, down there, we are going to increase the value by 1. So this increment by 1, because count is a loop variable, it is involved in this condition. So this increment by 1 is actually our way out. It will help us to stop the loop sometime somewhere. Now we are good. This loop is good, functional, and will generate 10 repetitions. If we compile this code manually, we start with the count value 0. 0 less than 10. Condition evaluates to true, and this string is printed in the cancel. And right after that, we are going to increase the count value, which will become 1. Loop will go to the condition again and try to evaluate the condition. Now the value of the count is 1. 1 less than 10, condition evaluates to true, and we will print the string hello once again. And after that, we are going to increase the count value once again. It will become 2. Evaluation 2 less than 10 is still true, and we will print, the loop will print the string hello in the cancel. The loop will continue the same way from the value 0 to 9. Sorry, 9. But when the value become
10, the loop will stop working because this condition won't evaluate to true. 10 less than 10, it false. So as the false comes here, loop will stop working and our control will go further down there. So let's run the program and see if we get 10 repetitions or not. And so you see 10 repetitions. Hello in the console 10 times. Now the key point to remember here is that whenever you program a while loop, you must figure out a way out, just like we did here. If you don't figure out the way out, your loop will be an infinite loop. Let's move on and have some more experiments with the while loop. We are not done yet. In our first example, we decided the number of repetition, 10 repetition using the count variable, and we coded a suitable condition, and here we are incrementing the variable. So we coded like that. We wanted 10 repetitions. But in most of the conditions where we use while loop, we actually don't know the number of repetitions. For example, a use of the while loop in user input validation. In such case, if the user insert correct data, there will be no repetition. But if the user insert incorrect data, there will be one repetition. And if the user insert incorrect data once again, there will be another repetition. So the user is stuck in the loop until he or she provides correct data. So let's now have a user input validation example with the help of the while loop. Let's say we want to validate the password. So we need a password variable, which is empty. And now we will code a while loop like this. And the condition is important here. In the condition, we would say as long as the password not equals to secret. Secret is actually the password, and as long as the password variable has a value which is not equal to secret, we will be inside the loop. And inside the loop, we will ask the user to provide a password. Provide the password like this, and we'll save the password in the password variable like this. And then outside of the loop, we will print a console write line. We will say password accepted, access granted. Before we run this program, let's try to understand it. It's a very common way to validate user input. What we are doing here, we are actually letting the user come inside the loop and provide password. The password variable is an empty string from the beginning. So empty string is not equal to secret. Secret is our password. So empty string is not equal to secret. The condition evaluates to true. We will come inside the loop and here we will publish a message, provide the password, and the user will provide the password we are going to save in the same variable password. After this cycle or repetition, the loop will go up here and try to evaluate the condition once again. Now let's say user does not provide secret. User write incorrect password like ABC. So the value ABC in the password variable is not equal to secret. The condition evaluates to true once again, and that means we will come inside the loop and there will be another repetition. And in that repetition, user provides the correct password, secret. So the value in the password variable is secret. Secret is not equal to secret. Condition evaluates to false. And that simply means correct password is provided. The value of the evaluation is false, while loop will stop working and we will go down and execute and run others statements. So this is how this piece of code is working. Let's now run this application and check it in the console. So here we go. Program is asking for the password. Let's provide incorrect password, ABC. We will come again inside the loop. Here you see, provide the password. Now I will provide once again a wrong password, XYZ. You see, password is not validated. And now I will provide correct password, secret. And as you can see, password accepted and access granted. So that was a good example, I think, to understand the functionality of the while loop. Let's now have one final example. In that example, we will force the user to enter a number which is in the range of 1 to 10. If the number is out of the range, we will catch the user immediately and won't let the user go until he or she provides the right number, correct number. So let's have a console write line first. Here we will print a message, provide a number 1 to 10 like this. Now in a variable, we are gonna read the number
and at the same time we need to convert it to integer. So as soon as number comes in the program and before using it somewhere, we will validate it. So here we are going to validate the number using the while loop. We're going to code a while statement like this. And the condition is very interesting here. We will say if the number is less than 1 or logical or gonna work here, number is greater than 10. And here we have a typo. It should be while. So if the number provided by the user is less than 10, this condition will become true. Here we have logical or. If one condition become true, the whole is true. And in other case, the number provided by the user is greater than 10, this condition becomes true. The one is true, the whole is true, and we will automatically come inside the while loop. Now we know the user has provided incorrect number. And in that case, we are going to force users to provide input again. And we don't need to create the variable again like this. And once the right number is provided, we can print a message for the user. And we can also print the number here. So when the wrong number is provided, we will automatically come inside the loop. And here we will force the user to provide correct number. Otherwise, there is no way out. So let's run the program and check the output. But before that, I want to just deactivate this piece of code. Now we can run the program. So here we go. We need to provide a number between 1 to 10. Let's say I provide 11. We say I am now inside the loop, provide a number 1 to 10. I provide -1. Let's say once again, I'm stuck in the loop. The user is stuck in the loop. And as we provide the correct number, which is in the range 1 to 10, our number is accepted by the program. Let's say I provide number 9. Let's say you provided the correct number, which is 9. So my friends, that was a while loop we covered in this lecture. And I hope you now must have realized the importance of the loops in programming. In the next lecture, we will cover and learn the do while loop. I will see you there. Take care of you. We talked about loops in programming in our previous lecture. And we said that in programming or in C Sharp, we have 4 basic loops: while loop, do while loop, for loop, and for each loop. And after that, we learned to code the while loop in detail. So from the previous lecture, we know the number of loops in C Sharp and the functionality of the while loop. After the while loop, the next loop on our list is do while loop, which we are going to cover in this lecture. Do while loop is an special loop in programming. It offers at least one repetition irrespective of condition is true or false. So let's learn the syntax of the do while loop as well as its functionality. The do while loop has 2 reserved words, do and the while. In the do block, we write the code to repeat, right? This is the do block, and here we have a code to repeat. And right after where we close the do block with the help of this curly parenthesis, we write the while reserve word. And then we put a semicolon like this. And this is how the do while loop syntax look like. We can simply compare this syntax with the while loop, which we learned in the previous lecture. While loop has very simple syntax like this. And in the while body, we write the code to repeat. And then as usual, in these small parentheses, we code the conditions. So that was all about the syntax of the do while loop. Let's now talk about its functionality. So like I said, do while loop will at least offer you one repetition irrespective of condition is true or false. If we compare the do while loop with the while loop will offer you the repetition only when the condition is true, right? So we can do an experiment in comparison between do while and while loop. So I'm going to create a variable string okay, which is empty at the moment, and then write a condition in the do while loop as long as okay is equals okay, and the same condition in the while loop. And then both the loops have a console, right? And here we can simply print a message. I am inside the do while loop. And here we have a condition, write line, like I am inside the while loop. Now we can analyze our code. You see the condition from the beginning is false. Our OK variable has an empty string. Empty string is not equal to OK, right? The condition is false. We will get a false value here. And the same here, it's the same condition. We will also get the false value here. However, when I run this program, I will say this string in the console once, and this will never be there in the console. And this is because of the difference between the loop. Do while loop will execute its do block first and then check the condition. If the condition is false, then there will be no further repetition. If the condition is true, do while loop going to execute its do block once again. But in this case, while loop will execute its block only when the condition is true. So one repetition with the do while loop is always guaranteed. So let's run the program and check the output. And so you see in the output, I am inside the do while loop. And that simply means we went inside the do block and there was a repetition. So that was the only difference that we have between do while and while loop. Otherwise, both are loops and they're used to generate repetitions. Do while loop is also a good choice to validate user input. Let's say we want to validate user password, a program that we wrote in the previous lecture with the help of the while loop. Now we're going to write the same program using the do while loop. So let's change the name of the variable. Instead of OK, our variable name is password, which is empty in the beginning, and the password is secret, right? So as long as the password is secret, we are good. We are going to accept the input. Sorry, as long as the password is not secret, that should be the condition. Here we have a typo, that should be secret T in the end. And then inside the loop, we are going to publish message. Let's say enter your password like this. And then we are going to read the password in the password variable console readline. Right, so now we know as we run this program, this do block will execute and our program will ask the user to enter the password. And if the user entered the wrong password, let's say user inserts ABC, then the condition will become true because ABC is not equals secret. That means one more repetition and we will ask for the password again. So the user will be stuck in the loop as long as he or she provides the correct password. So let's run the program, check the output, deactivate the while loop code here. We're going to run the program, enter a password, incorrect password, let's say ABC. I will say enter your password again. I provide incorrect password once again, ABC123. You see, our program keeps asking the password. I'm stuck in the loop. Now I will provide the correct password, SECRAT, secret, and now we are good. So my friends, that was the do while loop. It's a simple loop, works the same way as the while loop. It evaluates the condition, and when the condition is true, you get a repetition. But the only difference is this condition is evaluated after one repetition. Do some practice with this loop. I will see you in the next lecture where we will discuss the for loop. Thanks for watching and take care of you. As you know, we have been talking about the loops in C Sharp. In the last lecture, we covered the do while loop, and before that, we learned to code the while loop. And we also know that there are total 4 loops in C Sharp. The first 2 loops, like I said, while and do while, we have already covered, and it's now time for the third loop, which is for loop. The last loop on our list is for each loop, and I have already told you we will cover this loop later on because this loop works together with a collection like array, string, list, etc. So this lecture is all about learning the for loop. For loop is a very interesting and very useful loop in programming. So let's move on, learn the syntax and the execution order of the for loop. The for loop has an interesting syntax as well as it is a managed loop. Why do I call it a managed loop? I called it managed because for loop is controlled by 3 statements which decide the number of repetitions. That simply means when we work with the for loop, we mostly know the number of repetitions because we manage the repetitions using the statements, three statements. So let's start with the syntax of the for loop. Learn the syntax of the for loop as well as some important terms. For loop also has a reserved word for, and right after for, we put two small parentheses like this. And after the parentheses, we put loop body or the loop block using the curly braces. And inside the curly braces, we write the code to repeat. Now, come inside the small curly braces. So, what we know from the last couple of lectures when we learn the while and the do while loop, both the loops have these small parentheses in their syntax where we write a simple condition, right? So, we simply write a condition inside these small parentheses when we work with the while and the do while loop. But the case is different with the for loop. So instead of a single condition, for loop actually requires three statements inside these small parentheses. The first statement is actually called initialization. We know the term initialization. Create a variable and initialize it with a value simply means initialization. The second statement inside the for loops parenthesis is condition, and we know what a condition is. We create a condition using the relational and logical operators. And the last statement, the third statement inside the for loops parenthesis is increment. So this is the pure syntax of the for loop. It starts with the reserved word for. It has its code block or the loop body. And inside the parentheses, we usually write three statements: initialization, condition, and increment. So let's make this loop functional by putting the real statements here. Initialization. Here we create a variable and initialize it with a value. Let's say I create a variable name is j, and I initialize it with the value 0. This variable j here is local variable. It cannot be used outside of this loop. This variable also called loop variable. So j is loop variable as well as local variable. Now I want to create 10 repetitions. I need to write a condition. And the condition should be something like j less than 10. So as long as the value of the j is less than 10, our loop will repeat itself. And after the condition, we have increment. We can also code decrement if we wanna code a loop that goes backward. But at this moment, I am going to code the increment by one using the increment operator. Now we have coded a for loop which is functional and will give us 10 repetitions from the value of j 0 to 9. Inside the loop where we repeat our code, we will simply write a write line with the text hello. Now before we run this application and check the output, we first need to understand the execution order of this loop. So what will happen here, as program control comes here, it finds a loop, a for loop. So as the loop is detected by the control, it will then come inside the small parenthesis where we have these three statements. Now inside the parenthesis, the control will first create a variable j and initialize it with the value 0. And right after that, evaluate the condition. The value of the j is 0 and 0 is less than 10, and the result is true. As the result of the condition becomes true, we will get a repetition. Our control will come down and execute the code that we have in the for code block of for body. So we will simply get first repetition, and then something interesting will happen. Our loop will go upward again. When the loop will go up again, it will totally ignore the initialization part. It will actually make an increment in the j variable. So the value of the j will be increased by 1, and right after that, the condition is evaluated once again. So before the second round, the value of the j should be 1. And 1 is still less than 10. The condition is true. That means we are going to get another repetition. And after the repetition, our loop will go up again and once again increase the value of j. So after the second increment, the value of j will become 2. 2 is still less than 10. This condition will return us a true value, and that means there will be another repetition. So this cycle will continue the same way until the value of the j becomes 10. When the value becomes 10, this condition gonna evaluates to false. That means no more repetition and our control will move further down there. So this loop is very interesting and very well managed by these three statements. The only thing to remember here is that this initialization part is executed only once before the first repetition. After the first repetition, our loop will go in this direction. Increment, condition check, repetition. Increment, condition check, repetition. Now we know the syntax of the for loop plus the execution order of the for loop. Let's run the program and check the output. And so you see the output. The string hello world is printed 10 times in the console. Let's move on and learn more about this loop. Like I said earlier, this loop is very well managed by its statements. And most of the time, we know the number of repetitions, like in our case, right? We coded like that. We knew the number of repetitions should be 10. So we can manage this loop in different ways. Let's say I can start the repetitions from the number 5 instead of 0 and will take it up to the 15. So the value of j will start from 5 and here it will get incremented until it is under 50. So we are going to still get 10 repetitions. Value of j from 5 to 14. We can also change the increment. Instead of increment by 1, we can make it increment by 2 like this. Now the value of the j is increased by 2 after every repetition. And that means we are going to get 5 repetition instead of 10. So let's run the program and check the output. And here you see the output. The hello string is printed 5 times. So we are getting 5 number of repetitions. Right? So for loop is in our control. We decide the number of repetitions and the increment order. Let's now reverse the changes and see how do we utilize the loop variable inside the loop. Like I said, j is a loop variable. You can have any other name here, for example, row or column, right? It's just a name to the variable. So j is a loop variable and j is available inside the loop. So we can simply print the value of the j to see its value. By printing the loop variable in the console, we can study how the value of the j was incremented after every repetition. So let's run the program and you will see the output like 0, 1, 2 up to 9. And here you see the output. The value of the j starts from 0 and the last value is 9. As the value became 10, the loop condition evaluated to false and we left the loop, right? The loop variable value is an important value. When we will learn the collection, then you will see how do we utilize the loop variable to handle the collections. But at this time, we can use this loop variable to print number tables. We can write an interesting program. So let's see how do we utilize the loop variable to print number tables. You will also learn some important variations. So I'm going to create a variable here, an integer variable with the name table. And let's say I want to create a table of 5. And now in the WriteLine, we just need to create a table string. Let's create a table string like this. So as I run the program, you will see the multiplication table of 5 in the console. We can also do a manual compilation. In the first repetition, the table value is constant, which is 5. Here comes a string, multiplication string, and the value of j is 0. So 5 multiplied by 0. We are not doing the multiplication here. This is just a string value. Multiplication is done here. Here comes the result. 5 multiplied by 0 becomes 0. In the second repetition, the table value is constant, which is 5. The value of j is 1. We are not doing any multiplication here. This is just a string. We are doing multiplication here. So 5 multiplied by 1. Here comes the value 5. And it will continue until the value of j becomes 9. But we want the multiplication table up to the value of 10. So I can change the condition here. Instead of less than, I can put less than or equal to 10. Or you can simply increase the value to 11. The both will give the same result, but I think this one is more readable. So now the value of j will increase from 0 to 10. And once it becomes 11, the condition becomes false. So let's run the program and see the multiplication table in the console. And here you see the beautiful multiplication table, and you see the value of j goes from 0 to 10. Now here we can do another variation. We can do another twist. We can also control the table length using a variable. At this time, we are using a constant number 10. We can replace this constant with a variable. Let's say we create another variable which is called table length and put a value 10 to it. And now we can replace the number 10 with the variable table length. If I run the program, we will get the same result. But when I change the value, let's say the table length is 15, we will get a different result. We will get a lengthy table up to the 15th. The multiplication table from 0 to 15. Let's run the program and check the output. And so you see the output. The value of j goes from 0 to 15. And if you want to print another table instead of 5, you just need to change the value here from 5 to 9. Now I will say the multiplication table of 9 in the console. Let's run the program. And so you see the output in the console. Now here we have a multiplication table of 9. You can see 9, 18, 27, 36, 45, right? And what can we do more here? We can also start the table from 1. We know the multiplication with 0 is always 0, so we don't need to start our table with 0. Now the value of the j will start from 1 and go up to this limit, right? Table length. So my friends, that was the for loop we covered in this lecture, and I want you to do some more experiments. Code this loop and try to create some variations. For example, you can create a backward loop. So let me show you how to create a backward loop. We need to reverse everything here. We're going to initialize our variable from 10, and we would say until the value of 10 is greater than or equal to 1. So say I reverse everything, and instead of increment, I will do decrement here. Let's print the value of j in the console like this. So here we have a countdown loop. It will start from 10. You will see 10 first in the console. Then you're going to do a decrement. It will become 9. 9 is greater than or equals 1. Condition is true. You will see 9 in the console, and it will continue that way. So let's run the program and check the output. You will see a countdown from 10 to 1, and you will see the countdown 10, 9, 8, 7, and up to the 1. That was the for loop we covered in this lecture. We will use this loop quite often in our coming lecture, but we are not done with this loop. In the next lecture, we will study the nested for loop. That means a for loop inside another for loop. It is called nested for loops. It's very important to understand the execution of nested for loops in order to solve some problems, like sorting problems where we sort the data, or to read out the multi-dimensional arrays. So we will be discussing nested for loops in our next lecture. I will see you there. Thanks for watching. We have been learning loops in the last couple of lectures. We learned to code the while loop, do while loop, and the for loop. For loop we just covered in the previous lecture. In this lecture, we will try to understand the execution of the nested for loops, just like I told you at the end of the previous lecture. Nested for loops are needed in several different scenarios, such as sorting, finding, searching, and traversing the multi-dimensional arrays and collections. So let's move on and try to understand the execution of the nested for loops. In a program, we are going to create a for loop inside another for loop. Both the loops will go 10 repetitions. So let's create the program. This is our first for loop, and it will go 10 repetitions. The loop variable is I. I will start from 1 to up to the 10, and here I will change the condition less than and equals 10. Now we know this loop simply generate 10 repetitions. We can put a comment here. Let's say outer loop. This one is our outer loop. Now inside the outer loop, we are going to create another for loop like this, and it will also generate 10 repetitions. And then we put our comment here. This is the inner loop. So this kind of code structure where we have a loop inside another loop is actually called nested loops. Now we have nested structure. outer loop and inner loop. The question is, how does this structure work? The answer is interesting, and in order to get the answer, we need to manually compile this code structure step by step. So let's do a manual compilation and learn the execution of this structure. So what is happening here? Our program control will find a for loop here, and right after that, it will come inside the outer for loop and initialize the variable I with 1. And then our program control will evaluate the condition. The value in the I is 1, 1 is less than 10, the condition is true. That means we will come inside the outer loop. So the value of I in the first round is 1, and we are now inside the loop, inside the outer loop. As the control comes inside the outer loop, it finds another for loop. The control will do the same. It will create a variable j, initialize it with the value 1, and right after that, check the condition. 1 is less than 10, condition is true, and now our control will come inside the inner loop. So here is our control. Now, inside the inner loop, we don't have any other loop. That means our control will stay in this loop until the value evaluates to false. And when will this condition evaluates to false? This condition evaluates to false after 10 repetition. So this loop, the inner loop, will simply go 10 repetitions. After the 10 repetitions, when the value of the, say when the value of the j becomes 10, this loop gonna evaluates to false. So as the condition returns the false value, our control will simply leave this inner loop. But what about the outer loop? The outer loop is still true. That means our control will go up here again and increase the value of I with 1. So the value of I will become 2, and the condition is tested again. 2 is less than 10, the condition is true. That means our control will come inside the outer loop once again. And when it comes inside the outer loop, it will find a for loop once again. And as the control finds the for loop once again, it will simply come inside this inner for loop, create this variable, and will check the condition. Condition is true. The value of j is 1. 1 is less than 10. That means there will be a repetition. And once again, our control is stored in the inner for loop until the value of j becomes 10. And that also means another 10 repetitions. After the 10 repetitions, our control will leave the inner for loop and will go up again to the outer loop. The value of I gets incremented once again and will become 3. The program will check the condition. 3 is less than 10. The condition is true. It will come inside the outer loop and then again run this loop up to the 10 repetitions. And this cycle will continue until the outer loop has done with all of its repetition. It's interesting, right? With every repetition of the outer loop, the inner loop will go 10 repetitions. So if I ask a question to you, can you count the total number of repetitions? Can you count it? Just pause the video and try to figure out the total number of repetitions. So what was your answer? Did you figure it out? The total number of repetitions here should be 110. You want to know how? The outer loop creates 10 repetition. And with every repetition of the outer loop, the inner loop creates 10 repetitions. So the 10 repetitions for the outer loop and 10 into 10, 100 repetitions for the inner loop. The total becomes 110. We can also program and code the output of this structure to get the confirmation in the console. So let's code the output of this entire structure. To the outer loop, we will print the value of the I, and I will use console write instead of WriteLine. We'll put the new line in the output later on, and here we put a string. Here we write outer repetition and simply print the variable, loop variable I, and then simply put a space after the I. Now inside the inner loop, we're going to simply print the loop variable j. Like this, might be a space after every j value. And now after the inner loop, we will remain inside the outer loop, and here we will print a new line, right? So once the entire code is executed and before the new repetition of the outer loop, we are going to insert a new line in the output. So let's run the program and check the output of this interesting code. And here you see a very interesting result, right? Outer repetition goes from 1 to 10. You see outer repetition 1, 2, 3 to 10.
And for each repetition of the outer loop, here is the inner loop's repetition from 1 to 10. To the second repetition of the outer loop, the inner loop goes once again 10 repetition from 1 to 10. And the 10th repetition of the outer loop, the inner loop goes once again from 1 to 10, right? So using the cancel and the loop variables, we are now sure about the execution of this interesting nested structure. So my listeners, that was nested loops in programming, and now we know how the execution of the nested loops works. At this point, we have simply covered the first three loops, while, do while, and for. The for each loop we will cover later on, together with the collections. In the next lecture, we will study continue and break statements. Both are designed especially for the loops. So I will see you in the next lecture. Thanks for watching. Take care of you. In the last couple of lectures, we have been talking about loops. We learned to code while, do while, for loop, and learn the structure of the nested loops. So regarding to the loops in C Sharp, our understanding is very good now. The last thing we need to cover related to the loops is two special statements which are called continue and break. Both the statements continue and break are used inside the loop. The common thing between both statements is that they are used with conditions. That means they are used inside the if statement inside the loop. So let's see how do we code and use these two statements and what do they actually do. We can start with the continue. The continuous statement simply skip a repetition when a specific condition is met. So there should be a condition, and when the condition is met, the repetition of the loop is skipped. That means the loop won't go down and continue its repetition. It will go up again. Let's have an example. We code a for loop with 10 repetition, and the value of I goes from 1 to 10. Now we come inside the loop. Inside the loop, I will simply print the value of I like this, repetition, and the value of I. When we run this program, we will simply get an output like repetition 1, repetition 2, repetition 3, up to the repetition 10, right? So let me show you the output of this program first. And so you see the output just as I told you, repetition 1, repetition 2, up to the repetition number 10. Now let's say when the value of the I, which is the loop variable, becomes 5, I want to say the loop to skip its repetition. That simply means do not repeat the code. So I will code a condition using the if statement. Remember what I told you earlier. The thing in common between continue and break is they are used with condition. So I will code a condition here and we'll check if the value of I equals 5. So as the value of I equals 5, I will simply call the continue statement like this. So as soon as loop finds continue statement, it will skip its repetition. That simply means loop won't go down and execute other statements. Right after the execution, the loop will go up again to the increment part. If I run this program now, you will see an output like repetition 1, 2, 3, and 4. You won't see the repetition 5 because repetition 5 is a skip. So after the 4, you will see repetition 6, 7, 8, 9, and 10. So let's run the program and check the output. And so you see in the output, after repetition 4, you see repetition number 6. Repetition number 5 is totally skipped because of the continuing statement. So this is how we use the continue statement. By using it, you can simply skip a specific repetition. And once again, there must be a condition. If I use the continue, for example, without the condition like this, then there would be no repetition. Or there would be repetitions, but our control won't go down and execute the statements after the continue statement, right? So there must be a condition around the continue statement. So that was the continue statement. Let's move on to the next statement, which is break statement. Break statement is used quite often. And what does it actually do? It simply breaks or terminate the loop. And also when a specific
condition is met. So let's code a for loop, or we can simply just copy our previous code here like this. And now instead of continue, I will simply call the break statement like this. Now as the value of the I becomes 5, the loop is break. Simply the loop is terminated and our control will go down here. So the output of this code in the console should be repetition 1, 2, 3, and 4. And once the value of the I becomes 5, the loop is terminated. So let's run the program and check the output. And so you see the output in the console, right? Our loop went only for repetition from 1 to 4. And the loop simply terminated on the 5th repetition. Now, you remember the while loop. When we discussed the while loop, we coded a infinite loop using the true constant like this. This loop is an infinite loop, and what I told you at that point, at that time, I said the infinite loop can only be stopped using the break statement. So now we can apply the break statement to control this infinite while loop. The break statement inside the while infinite loop should be used together with the condition. So let's say I want to generate 10 repetitions using this infinite loop, and after the 10 repetitions, I just want to break the loop. So I will create a variable count, which is 1 like this. And inside the loop, I will simply print the count variable. And right after that, I will increase the value of the count by 1. And here, I will check the condition. So I will code a condition and say, as the value of the count becomes equal to 10 or greater than 10, then execute the break statement. So you see, just by using the break statement, we simply modified an infinite loop to generate 10 repetitions. So let's run the program and check the output. And so you see the result in the console. Our loop is actually generating 9 repetitions. And this is because of as the value is incremented, we check the condition right after that. And to solve that, we can simply move this incrementing part at the end of the loop like this. I think now we will get 10 repetitions. So let's run the program and check the output. And so you see in the output, right? Our loop is actually generating 10 repetitions from 1 to 10. So that was the break statement. And like I said, we use break statement quite often in programming. Let's have another example of the break statement. You remember we validated the user input when we studied the while loop. And for that, we gave a condition to the while loop. But we can also use a while true loop to validate the user input together with the break statement. Let's see how. So we are going to create a variable here, string variable password, which is empty on the beginning. And then we will let the user come inside the loop because the value is true here. And in the right line, we will simply print a message, insert the password like this, sorry, password like this, and then read the value of the password in the password variable. And our password is secret. So if the password value entered by the user is secret, we are gonna simply call the break statement. Just remove this piece of code here. Now, once again, the user is stuck in the infinite loop because the value is true here, and we will continue to ask for the password. And once the password provided by the user equals secret, we will simply come inside this if statement, and here we will execute the break statement. So let's run this program and check the output. And now provide the password. Let's say I provide a wrong password, ABC. You see, insert the password again. I will provide wrong password once again, ABC123. The program will ask to insert the password once again. Now I will provide the right password, which is secret. And now you see the password is accepted and the loop is terminated. We can also implement the number of attempts. It's a very useful function. We already have a count variable. Now let's say the maximum attempts a user can make is 3. So when the password is entered by the user and program checks for the correct password. When the password is not correct, we will come down here and we'll investigate the count variable. If the count variables, the value of the count becomes equals or greater than 3, that means the user have made 3 attempts, and now we are going to simply break the loop. And before that, we can simply print a message to the user like too many attempts, and here can we need to increase the count value by 1. Interesting program, right? Let's run the application and check the output. Here we go. I will provide a wrong password. Let's say ABC. Okay, insert the password again. I will provide the wrong password once again. Insert the password. I will provide the wrong password once again, and I will say too many attempts. The loop is terminated and user is not allowed to make more attempts. Now, one last thing before we wind up this lecture, and I just want you to figure it out by yourself. You remember we discussed the nested loops in our previous lecture. So let's say we have a nested for loops, and both the loops, let's say, generates 10 repetition. I think I need to change the variable j, j, and j. Now the question is, what will happen if I use the break statement inside the loop? It's your job to find out. The break statement gonna terminate the inner loop or both the loops. So find the answer by your own. We are now done with the loops in C Sharp. On the next lecture, we will start learning collections. I will present you the collections that we have in C Sharp, and we will then start learning them one by one. I will see you in the next lecture. Thanks for watching. Take care of you. We have been learning loops in the last couple of lectures, and now we are done with the loops. We know how to code while, do while, and for loop. We also learned the structure of the nested for loop, and in the previous lecture, we discussed the continue and the break statement. So the loop section is totally covered, and it's now time to move ahead. The best thing to learn after the loop are collections. So from this lecture, which is I think lecture number 27 in our course, we will start learning the collections in C Sharp. Collections are very important in programming, and we need to have very good understanding of them in order to write practical programs. In C Sharp, there are many collections. They also have different names as well as they work differently. In this lecture, I will give you an introduction of the collections, and then we will start learning them one by one. So now the first thing we need to understand here is what is a collection and why do we need a collection? Let's get the answer of these two questions first. What is a collection? A collection is simply a data structure that can store multiple values. Very simple and straightforward definition. It is just a data structure which is used to store multiple values. That's it. Data structure is also an important term in programming, and we can also define the term data structure. We can say data structure is simply a way to structure the data. We can structure data in different ways. For example, we can have linear data structure. We can save our data in matrices. We can also have a dictionary-like data structure, and we can also have a tree-like data structure, which we use on the social media. So a data structure is simply a way of structuring data in different ways. All the collections that we have are actually data structures. They give us the opportunity to structure data in different format. You will see that in this lecture and coming lectures. So that was the definition of collections. Now the next question is, why do we need collections? The answer of this question is very straightforward. We cannot work with the variables all the time. A variable is actually designed to store only one value. What if we need to store the name of 100 people? We cannot create 100 variables. So this is totally non-practical to create 100 variables to store the name of 100 people. So let's just suppose we create 100 variables to store the name of 100 people. Then what will happen when the time comes where we want to manipulate the data? For example, we want to update a name, we want to find a name, we want to delete a name. So manipulative operations are nearly impossible to apply if we have names stored in variables. In addition, we're only talking about 100 names. In reality, the list can be longer or bigger, such as hundreds of thousands of names, right? So variables are good, they are building block of a program, but they are not made to store multiple values. For multiple values, we use collections. Now we know the importance of the collection. Whenever we need to work with the multiple values, we will simply select a collection. Let's now move on. When we talk about the collections, there are several different types in C Sharp. The very basic collection in C Sharp is actually called array. An array can be defined in three different ways. We have one dimensional array, which is also called linear array. So the linear array offers linear data structure, just like the names in a list. And then we have two-dimensional array, which is also called matrix, just like the matrix that we have in mathematics, where we work with the rows and columns. Two-dimensional array offers a matrix-like data structure. The last structure in the array category is jagged array. Jagged array is actually an array of multiple linear arrays. That simply means we can combine multiple linear arrays to create a jagged array. So in the array category, we have three different ways to structure our data. One-dimensional array, two-dimensional array, and jagged array. And then we have another collection which is called list. List is generic collection or data structure. We will talk more about it when we learn this collection. And in the last, we have dictionary collection, which is also generic. Using the dictionary, we can store our data in keys and values pairs. So that was an introduction of collections in C Sharp. We talked about what collections are, why do we need them, and different type of collections in C Sharp. Now we will start learning them one by one. We will start with the array. Array is a very basic type of collection. We will learn to work with the one-dimensional, two-dimensional, and checked array. And after that, we will learn to code generic list and dictionary. I will see you in the next lecture where we will learn to code a one-dimensional array. Take care of you and don't forget to take the next lecture. In the last lecture, I gave you an introduction of collections. We defined the important terms like collections, data structure, and discussed the importance of collections in programming. And then we discussed the number of collections in C Sharp. We have array collection, list collection, and dictionary collection. Array is further divided into three types: one-dimensional array, two-dimensional array, and jagged array. And it's now time to learn to code them. In this lecture, we will be covering one-dimensional array. So let's move on and learn to code it. So our topic is collections in C Sharp, and in the array category, we are going to cover one-dimensional arrays. All the collections or the other tools in programming, as you have experienced, have their own syntax. So it's important to remember the syntax of different tools in programming. The one-dimensional array, which is also called a linear array, has its own syntax. So let's start by creating the one-dimensional array. We will learn the syntax and some important terms. Now let's say in a program, I want to store 10 different numbers, 10 integer numbers. So I want to work with multiple values. That means I need an array. So I will create an integer array. So I will start with the integer, and right after the data type, I will use a square bracket, and then I will give a name to my array. Let's say the name of my array is numbers, and then I will put simply a semicolon. So what I have done here, I have actually created a variable of array type. And this is the syntax for creating a one-dimensional array. We simply decide the data type we want to work with. We will work with integer numbers, and right after that, we put square brackets. This line of code where we simply create an array variable is actually called declaration, and we have already discussed this term when we learn to create the variables. So here we have a declaration, right? So once we have declared a variable of array type, we can start initializing it. Initialization simply means reserve spaces in the memory. So on the next line, we will start initialization. So as I want to store 10 numbers, so I will reserve 10 spaces, 10. So here is the syntax for initialization. We are trying to reserve 10 places, and this new keyword will make it possible. It will reserve 10 places, 10 consecutive places in the memory for this array variable. Right? So in the first step, we declare an array variable, and in the second step, we initialize it. This is just like we do with the variables. For example, we can uh, declare a variable like this, and in the next step we can initialize it by assigning a value to it. The same thing we are trying to do here, but the syntax is different. We are working with the array now, not the variable. And we also know the declaration part and the initialization part can be combined together, just like we do with the variable. For example, I can simply create a variable like this. right? So we are creating variable and at the same time we are initializing it with a value. This is the more common way to create a variable. So just like that, we can create and initialize an array on a single line, which is the more common way to do that. So I will take this part of the initialization and will simply put it here. Now we can remove this variable and this comment I will put here. So this is a practical way of creating one-dimensional array in C#. We simply create an array. The name of the array is numbers, and here we are initializing it. This simply means reserve the memory for 10 components. At this point, if I compile the application, so our compiler will simply create an array variable as well as reserve 10 spaces in the memory, and all those spaces will refer to this single variable numbers. The memory picture will exactly look like that you see right now on your computer screen. Our compiler has reserved 10 spaces in the memory, and all the spaces have a single reference variable, which is numbers. At the same time, the compiler will automatically assign a data type default value to each place. The default value of integer type is 0. That's why 0 is assigned to all the places. Another thing I want you to notice here is all the places, memory places, are consecutive. That means they are next to each other. So the compiler takes care of that and reserve the consecutive memory locations. Now we know what happens in the background when we simply create an array and reserve some spaces. It seems interesting, right? We are learning something new in programming. So that was the declaration plus initialization. What we can do more here, which is even more common in programming, is declaration, initialization plus value. So we can assign our own values at the time of declaration and initialization, which is very, very common. So how do we do that? Now here we need to remove the spaces we want to reserve, and instead I will open curly braces right after that, and inside the curly braces I will simply put the values. Let's say I want to work with the 10 different values. So all the values are separated by the commas: 20, 30, 40, 50, 60, 70, 80, 90, and the last one is 100. So this is how we declare, initialize, and assign values at the same time. Now in the memory, the structure looks like as you see in the diagram. Our own values are now placed in the memory. You have also noticed that I removed the array size number from here. So when we initialize our array with the value, we don't need to insert the size number. Our compiler will automatically count the number of values and then assign a size to the array. So now we have a fully function array. The name of the array is numbers and it has 10 different values, which are also called components. This array have 10 components. In C#, there is a shortcut. If you want to create an array and assign it value at the same time, then you can also remove this new part. Now you see the syntax has become very simple. We are creating an array and initializing it with values at the same time. And once again, the size of the array is automatically calculated by the program. Let's move on. Now we will learn the most important feature of collections. Not only the array, all the collections implement the same feature. And that feature is called indexing. Indexing are used, or index numbers are used to access elements, access components. And we can access elements in two ways. We can read components and we can write components, such as we can read out the components, we can printing them out in the console, or we can even write components. Write means change components to some other value. And for that, we need to work with the indexing or index numbers. Now I will show you the memory diagram once again, and you will see the index numbers under the reserved places. These indexes are placed there by C# compiler, and they have one very important property. The index value starts always from 0. So remember this point, all the memory spaces of an array are indexed by the compiler, and the index value starts always from 0. Using the index value, we access the components or the elements. We combine the index value with the array's name. How do we do that? Let's find out. When we work with a single variable, for example, I create a variable here like this. So variable has a single name and a single value. So the value 20 has only the one reference name, which is number. So if I want to print the value out in the console, I will simply write the reference name number. But what would happen in this case? If I, for example, uh, write the name of our array, our compiler will get confused because numbers is an array and it represents 10 different values. So things are different when you work with the array because an array can hold several different values. If I run this program now, you won't see any value in the console. You will rather see its type, which is system integer array. So let's run the program and let me show you the output. And here you see the type of the variable, which is an array of integer type, right? So in order to access the element, we need to combine the name of the array with the index value. Now we know index values always starts from 0. That means the number 10 has an index value 0, number 20 has an index value of 1, and the last number has an index value of 9. So how do we do that? We use brackets, square brackets together with the array name, and inside the bracket we put the index number of the element we want to access. For example, if I put index 0 represents number 10, and now you will see number 10 in the output. So let me just run the program, and so you see number 10 in the output. Now instead of index 0, let's say I put index 9. Index 9 represents the last element. Let's run the program, and you will see 100 in the console. I will see 100 in the console. So in order to read out the values of an array, we use index values. We can also write the values. For example, I want to change the value 100 to 95. So we will simply assign using the assignment operator. We will just point to the location. Location is 9. And now I will assign a different value. Let's say 95. And then we will print the value again. So we are printing the value which is on index 9. And here we are changing the value and then printing it again. So let's run the program. And so you see the value is changed, right? Here comes the output of this first line, WriteLine. Now we are changing the value. We are assigning a different value to the same index, and we are printing out the same index. So here you can see the value is changed. It has become 95. I hope you understood the idea of indexing. It's a very important thing, and all the collections implements the same idea. And the idea is quite logical, right? A single variable representing several values. So we need to work with the indexes in order to reach each and every value. Let's move on. We should be very careful while working with the indexing. A wrong index value results in an exception error, and that means your program will simply crash. The exception which is thrown by the C sharp is called index out of range exception. So whenever you try to access an index that does not exist, you will see this exception. This is an error. So let's do an experiment. I am going to read out index value 10, and we know that the value 10 does not exist. The last element 100 has an index value of 9. Now the program will simply throw index out of range exception as we run the application. So let's run it and see what happens. And so you see the error. The error is exception, which is unhandled, and the name of the exception is index out of range exception. And what does it mean? It means index was outside the bound of the array. So we are using an index which does not exist, which is outside of the bound of the array. So index out of range exception is very common, and whenever you have it, you should know that you are messing with the index values. Later on in this course, we will learn to handle the exceptions. Then we will talk more about it. So let's just deactivate this line of code. Now, the last thing before we wind up this lecture, the length property. The length property is a very useful property. You will use this property quite often while working with the arrays in C#, especially when you will loop through an array. What does this property do? It actually returns the number of components. Just by calling this property on the array, you get the number of components, or in other words, you get the size of the array. So let's call this property on the numbers array like this. And now run the program, you will see 10 in the output because the number of components in the array or the size of the array is 10. So let's run the program, and so you see in the output, right? The number of components or the size of the array is 10. We use the length property when we loop through the array, and we will see how do we do that. Using the length property, we can also access the last element. You want to know how? Let me show you. In a console WriteLine, I will like something like this. So we are doing a calculation. Instead of writing a constant index value, for example, the 100 has an index value of 9. So instead of writing a constant, I am calculating it using the length property. We know that the length property will return the number of components, which is 10. And we also know that the index starts always from 0. So the index of the last element should always be 10 minus 1, which is 9. So using the length property, we can simply calculate the index of the last element, which is 100 or maybe 95. We are changing the value here. So let's run the program and see if we are getting the last element or not. And here you see, right, the last element in the console. So my dear listener, that was one-dimensional array we learned to code, but we are not done with it. We will continue to work with one-dimensional array in our next lecture. In this lecture, we simply learn to create array and some other stuff, the important stuff. In the next lecture, we will learn to loop through one-dimensional array. It simply means apply the loop and automate the process. I will see you in the next lecture. Thanks for watching. As you know, we have started learning collections in C Sharp. In the last lecture, we learned to create one-dimensional array. Here is the code we wrote in the last lecture. We learned to declare and initialize an array with the values. We talked about the memory representation of the array and the indexing concept. Indexing is a core concept, and I told you all the collection implements this concept. Using the index values, we can access elements of an array and can perform read and write operations. And then we talked about the index out of range exception. This exception is a runtime error, and it causes when we try to insert an index value which does not exist. And then we discussed the length property. Length property is a very useful property. Whenever we try to walk through an array with the help of a loop, we use length property. And in this lecture, you will see this length property in action because this lecture is all about looping through one-dimensional array. So that was a quick recap of the previous lecture. Let's now move on. In this lecture, you will learn to apply loop on the array to walk through all the array components one by one. Without applying the loop on the array, it is nearly impossible to perform operations like read, write operations, or manipulative operations. We simply cannot insert the index values manually. The things will become very complicated. For example, if I want to calculate the sum of all the values without using the loop, then I need to code all the indexes manually. And it should something look like, for example, here the index 0 represents the number 10 plus numbers of index 1 plus numbers of index 2. And the same way, I will go up to the index 9, which is the last element in our array. So you see, it is nearly impossible to work with the index values manually. In addition, this is not programming. Programming is all about automation. So using a loop, we can automate our process. We can perform read and write operation as well as others manipulative operations. So let's see how do we loop through one-dimensional array. I'm going to clean up some space here and we keep only the array which has 10 components, right? The length of the array is 10. Now, in order to loop through an array, we always prefer for loop. For loop is a best choice because the for loop already has its own statements. We don't need to create extra variables. So let's create a for loop and read out this number array. One thing we know from the previous lecture, the array has index values. Index values starts always from 0. So this is the index of the first element, and the index of the last element is 9. So we simply need to generate a for loop where the loop variable starts from 0 and goes up to 9. So it's a simple loop and we know how to do that. So we are going to create an index variable, a loop variable, which is j, and our array starts from 0. So we are going to initialize the j with 0, and here we will choose the maximum limit that should be minimum or less than 10. And now we are going to simply increase the value of j. If I simply print the value of j in the console, so you will see an output like 0, 1, 2, 3, 4 up to the 9. And 0 to 9 are actually the index values of our array. So let's run the program and see the output in the console. And so you see the output in the console. We are getting index values. It starts from 0 and the last value is 9. So now instead of inserting index values manually, we can simply make the use of our loop variable. That's it. The read operation on the array is performed. As I run the program, you will see all the values. We can also do manual compilation in order to understand this piece of code. In the first repetition, the value of the j is 0 and numbers of index 0 represents 10, and so the number 10 is printed in the console. In the second repetition, the value of j becomes 1, numbers of 1 represents 20, and so we see 20 in the console. So let's run the program and check the output. And so you see the read operation, right? All the values are printed in the console. So this is how we simply apply the loop on the array and automate our process. But you can see the things have become much simpler and easier. Let's move on. And now we will discuss the use of the length property. This for loop is somehow problematic because of this constant 10. And you might be thinking how? Why this value, a constant 10 value, is problematic. So let me show you why this constant 10 is problematic. Let's suppose this piece of code is a part of any application, and after some time, we are required to reduce or increase the size of our array. For example, the new requirement is only 5 elements, like this. So as we reduce the size of the array, the index values are also reduced. Now the index of the last element or the last component in the array is 4. So after changing the size, we must reconfigure our loop, because this loop will still go from 0 to 9. And when we try to access the index that does not exist, the program will crash and you will see index out of range exception. So I need to change this constant value. Instead of 10, I need to put value 5 here. So you see, I was forced to modify my loop as soon as we changed the size of the array. This modification in the loop can be avoided using the length property. So instead of the constant 5, I can call the 5 using the length property. We know the length property always returns the number of components. The number of components in this array is 5. So here we will get a constant value 5 through the length property. And the value of j will go from 0 to 4. 1 less than the length property. And 1 less than the length property is always the index of the last element. So by using the length property, we don't need to worry about the loop as we reduce or increase the size of our array. As I run the program now, it will work. Now let's say I want to increase the size and will put more values here. Let's say 70, 80. Our program will still work. Now we have 8 components, so the length property will return the value 8, and the last index in the array is 7. Our program will still work without any problem because here we are using the length property, which will automatically return the constant 8, and the loop variable will go from 0 to 7. So that was the proper use of the length property. Let's move on. Now let's say I want to calculate the sum of all the values that we have in our numbers array. This calculation can easily be done using this for loop. Now we don't need to write the manual index like this. Numbers of 0, numbers of 1, and up to the numbers of 7. So we don't need to do manual compilation. We can simply create a variable here uh, the name of the variable is sum. And now inside the loop, we will simply write this statement. And when the loop has gone through all the elements outside of the loop, we can print the sum variable. So we are using arithmetic assignment operator. We have already discussed it in our previous lectures. This is the short form of the operator. We can also write it like this, right? In the first repetition, numbers of 0 represent 10. So 10 plus 0, sum has 0 in the beginning. So 10 is saved in the sum variable. So after the first repetition, the value in the sum variable is 10. Now in the second repetition, the value of j becomes 1 and the numbers of 1 represents 20. 20 plus 10, the sum has now 10 becomes 30. 30 is saved in the sum variable. This cycle simply goes the same way, and when the loop is done with all the indexes, we have sum saved in this variable, sum variable. So let's run the program and check the output. And so you see the sum of all the values, which is 360. So that was a read operation. We can also perform the write operation. Write operation simply means we can change and update the values. So let me just create another loop here, and it also use the length property, numbers of length like this. In this loop, I will simply change or update the values of our numbers array. Let's say I want to multiply each value with 5. So I will simply write a program. Numbers of the variable name is I, and then again numbers of I multiply by 5. So this operation is actually called write operation. In the first repetition of the loop, the value of I is 0, number of I represents 10, 10 multiplied by 5 becomes 50, and then the value 50 is assigned back to the same index, which is 0. That means the value 10 is now replaced with 50. So once this loop has gone all its repetition, our array will be totally changed. And now after performing the write operation, we can create another loop to read out the values. Most students and beginners perform write and read operation at the same time in a single loop, which is a wrong practice. You don't need to do that. You will create a separate loop for write operation and then another loop for read operation. So let's now do the read operation. Simply create a loop, the same loop uh, like this, and now we will simply read out the values. So, so this is how we code. Let's run the program and check the output. And so you see all the values in our array are updated, right? Let's move on. We have been working with an integer array, but we can also create an array of characters, floating point numbers, and strings. For example, in a program, I want to create a name list of 5 persons. So I will create an array like this. Now this time, the data type of my array is a string, and here I can place names. Let's say Peter, Sarah, Johan, Adam, Alex. We can simply run a loop and read out all the names, use the length property, names dot length like this. And now in a WriteLine, we can print out our array using this way. Now run the program and you will see all the names in the console. And so you see all the names in the console. Now let's say I want to find a name. This is my name list, and the list can be longer, right? At this time, we are working only with the 5 names. So I want to find a name in the list. So I will simply create a variable. Let's have a bool variable. The name of the variable is found, which is false from the beginning. And I want to know if the name Sarah is in the list or not, right? So I will simply code an if statement if names of I equals Sarah. If the condition becomes true, So I will change my isFound variable to true. And right after that, we can simply call the break statement. We suppose that this name list is a unique name list. There is no name repetition in the list. So as we found Sarah, we don't need to go further. So we can simply call break. And now, once we come outside of the loop, we can investigate is found variable. If is found is true, that means we have found a name. We can simply print a message, say Sarah is sorry, or we can save the name as well. Create a variable, and the name of the variable is found name, which is empty. And as we found the name, we can save the name in the variable, right? And now we can print a better message. We can say found name is in the list. That's it. As we found the name on the index 1, we are assigning the name to the found name variable. And here we are simply printing the message. I think we are missing a curly braces here. So let's run the program and check the output. And so see the output in the console, Sarah is in the list. Now let's say I want to find a name that is not the part of the list. I will change here and put my name. Right? Salar is not a part of the list, so we don't see any output in the console. So let's run it. And so you see no message in the console. Now, one last thing that I want to show you here is that using the read line to read the values in a program and save those values in an array. So we are going to create an array, and this time we will not initialize it with the values. We will just reserve the spaces, and let's say the name of the array is user values, and we will reserve, let's say, 5 spaces. That's it. And now we will simply call a loop on it, user values length, and here we will assign the values in the array using the read line. We can also print a message before the loop, insert 5 values. And once all the values are inserted, this is the read operation. You remember what I told you earlier, read operation in a separate loop and then write operation in a separate loop. Now we can write another loop, which is perform the write operation, user value of length, and here we will simply print out all the values. User values of I. So we are creating an empty array, no values. We run a loop which goes the index from 0 to 4, and then on every index we are assigning a user value. So let's run the program and see the output. So here we have insert 5 values. So let's insert 5 values. And now you see all the values I just inserted. So, my dear listeners, that was a detailed lecture on applying loops on one-dimensional array, and we discussed several different cases. In the next lecture, we will learn and discuss the for each loop. You remember what did I tell you when we covered the loop? I said the for each loop works together with the collection. Now we can code one-dimensional array, which is a collection. That means we can learn and use for each loop. So in the next lecture, we will discuss and learn for each loop. I will see you there. Thanks for watching. We have started learning collections in C Sharp. In the last couple of lectures, we have been discussing collections. We learned to create and code one-dimensional array, and in the last lecture, we learned to loop through a one-dimensional array. I told you in the last lecture the best loop to apply on one-dimensional or multi-dimensional collection is for loop. And this is because of the for loops control statements. So because of the control statements, we don't need to create an extra variable to go through all the index values. So for loop is always a best choice to loop through an array. But you remember there was another loop on our loop list and we waited for that because the loop works together with the collections like one-dimensional array. And what was the name of the loop? If you remember that, that was for each loop. And I told you we would cover that loop once we start learning the collections. So as now we have starting learning the collections, we know how to create one-dimensional array. So I think this is the best time to cover for each loop. So our topic is still collections in C# and one-dimensional array, but at the same time, we are going to cover for each loop. For each loop works together with the collections, and I have told you several times. But now you will see each and everything in action. We will learn the for each loop in comparison with the for loop. And I think this is the best way to develop a good understanding. So let's learn to code the for each loop on the collections. We have two collections, one dimension array, which we created in our previous lecture. The first array is an integer array and the name of the array is numbers, and the second array is a string array and the name of the array is name. Numbers array has 8 component and name array has 5 components. Now let's say I simply start with a for loop. I create a for loop that goes 10 rounds like this. So this for loop is actually a standalone loop. It can be used together with the collections or separately. This loop will simply go 10 repetitions and we can do whatever we want inside this loop. We don't always need to loop through array using the for loop. It can also have different uses. But for each loop is not standalone. For each loop is always applied on the collections. So let's code a for each loop now and learn the syntax. The syntax of the for each loop is very interesting. I'm going to apply the for each loop on numbers array and we loop through all the components one by one. For each has its own reserved word, which is for each, and right after the reserved word, we open two parentheses, a small parenthesis as usual, and then the loop has its own body. Now, inside the parenthesis, we code a single statement. As I am trying to loop through an integer type array, so I will start by creating a variable. Let's say the name of the variable is value, and then I will put a space and then another reserved word which is in, and after in I will provide the name of the array or the collection I wanna loop through. So this is the syntax of the for each loop, a local variable in and the name of the collection. The best thing with the for each loop is you don't need to specify the number of repetitions or the size of the array. But in case of the for loop, we specify the size of the array. For example, if I want to use or apply this for loop on the numbers array, so I will simply call the length property on it. So in the for loop, we plan everything. We plan the index values, such as here, the index goes from 0 to 7 because the length of the array is 8. However, in for each loop, we don't need to think about the index value. Loop gonna take care of that. Let's move on. Now the question is, how does this for each loop execute? The execution of the for each loop is very simple. At this time, we are trying to loop through an array which has 8 components. That means this loop will automatically generate 8 rounds or repetitions, and it starts the repetition from the first component of the array, which is number 10. So what will happen in the background? In the first repetition, the for each loop took the 10 from the numbers array and assign it to the this local variable. In the second round, for each loop, pick number 20 from the numbers array and then assign it to the local variable value. The loop will continue this way until the last value. That means the value in this local variable is updated in each round. And we can confirm it just by putting this variable in the console. As I run the program, you can guess you will see all these values in the console. Because in the first round, the for each loop will store number 10 in the variable and then repeat its body. In the second round, for each loop will place number 20 in this variable and then repeat its body. So the value in the local variable is updated in each round, and inside the loop, we have access to that variable. So let's run the program and check the output. And so you see the output in the console, we have successfully looped through one-dimensional array with the help of the for each loop. So that was the for each loop, simple and elegant. Now let's say I wanna loop through this string array. So here I wanna put the name of the array, and now the data type of this array is string. So I need to change the data type here from integer to string. We can also change the name of the variable, let's say, and then we can print the variable num in the console. Right? The same thing will happen here, but this time for each loop will go 5 rounds because we have 5 components in the array. And in the first round, the name Peter is assigned to the num variable. And in the second round, the name Sarah is assigned to the num variable, and it will go exactly like this up to the last name. So let's run the program, check the output, and after that, I will tell you when to use and not to use for each loop. And so here you see all the names are printed in the console. Now let's discuss when do we use for each loop. For each loop is only used for the read operations. Read operations simply means when you want to read out or print out the data that you have in your collections. Just like we do here, we are only reading out the names from the name array. We cannot perform write operations using the for each loop because in for each loop, we don't have access to the index values. Index values are used in for loop. So here we can perform write operation as well as read operation. For example, as we coded in the previous lecture, we can manipulate or change these values, such as we can add number 5 to each value and then save the value to the same index. So this operation is actually the write operation because we are changing or updating the values. And this operation becomes possible because we have access to the index values. This same operation can't be performed using the for each loop. So that was the main difference between for and for each loop. For each loop is mainly for reading out the values. So just remember this difference. So my friends, that was all about for each loop. Now we have covered all the loops that we have in C#, while, do, while, for, and for each. At the same time, we are done with the one-dimensional array. In the next lecture, we will learn to code two-dimensional array. I will see you there. Thanks for watching and take care of you. As you know, we have been focusing on collections in C#, and in the last couple of lectures, we thoroughly covered one-dimensional array. Right? So now we are done with the one-dimensional array. We know how to code it and loop through it using the for and the for each loop. So it's now time to learn the second collection in array category, which is called two-dimensional array. Two-dimensional array is also called a matrix, just like a matrix in mathematics. So our topic here is two-dimensional arrays, and they're also called matrices. So let's learn this interesting data structure. Now, as the name suggests, two-dimensional. That simply means it has two dimensions, a row dimension and a column dimension. Just like a matrix in mathematics, where we have rows and columns. In order to understand two-dimensional structure, we will study some images, and they will help you to better understand the concept. Now, on the screen, you see a two-dimensional structure where we have rows and columns. The structure consists of 3 rows and 3 columns. When we create two-dimensional array, we get the structure like this, columns and rows. Now, once the structure is created, our compiler will automatically assign index values to the rows and the columns. So the first column is at index 0, and the first row is also at index 0. The second column is at index 1, and the second row is also at index 1. So the index values are automatically assigned by the compilers, and you know the purpose of the index values. Using the index values, we access the individual components, and you know that. When we learn the one-dimensional array, we use the index values to access the individual components. The same concept is applied here. However, in the one-dimensional array, we had only one dimension. And here we have two different dimensions and two different index values. And that simply means an individual components in two-dimensional array will recognize itself with two values, two index values. For example, the index value of the first component is 0, 0, or simply 0, 0. The first 0 represents the row index and the second 0 represents the column index. So in order to access an individual components, we combine the row and column index values. If you want to access the second component, the index value would be 0, 1 because the component is at row 0, but this time the column is 1. And that's why the index value is 0, 1. So every component has its row index and column index. We combine them both to access the component. Now, for example, the value of the last component is 2, 2, because the row index is 2 and the column index is also 2. The same way, the index value of the middle component is 1, 1. The row is 1 and the column where the component exists is also 1. So my friends, this is how two-dimensional array structure works in programming. Now we know that. It's now time to code it and do some practical experiments. The two-dimensional array has its own syntax. So let's learn the syntax. I'm just going to declare an array. I will reserve the spaces for the rows and the columns. We will start with the data type. Let's say I want to work with the integer values, and right after that, I will put large brackets, and inside the large brackets, we need to put a comma like this. The single comma inside the large braces simply tells the compiler we are going to create a two-dimensional array. And now we are going to choose a name for our array, which is a matrix, assignment, new, int, and here we are going to reserve the rows and the columns. Now let's say I'm going to create a two-dimensional array which has 3 rows and 3 columns. That's it. So we have simply declared a two-dimensional array with the name matrix and reserve the spaces. Our array has 3 rows and 3 columns. So this line of code will create a same structure which I showed you in the images, 3 rows and 3 columns. So that was a declaration without values. We just reserve the spaces. In the second stage, we can assign values by combining the indexes. Now let's say I want to put a value 100 to the first place. Now I know the index value of the first place is 0, 0, and to that place I simply put a value 100. The value 100 is now inserted at 0, 0, the row 0 and the column 0. You can also see the image to the right to get the more understanding. Now, if I want to put something in the middle of the array, so I will use the middle index value, which is 1, 1. Let's say we put here a value of 300. And the last component in our structure has an index of 2, 2. And let's say we put a value 500. So we have filled 3 places in our array using the index values. So declaration is the first step, and after that we can simply assign the values, but we don't do it manually. We usually run a loop to assign the values, which we will discuss later on. Now, in most of the cases, we actually initialize our array with values at the time of its creation. So let's see how do we initialize a two-dimensional array at the time of its creation. We don't need the new part, just remove it. And now we will put the curly braces like this. Make some space. Now inside the first curly braces, we will start creating rows and column. And each row has its own pair of curly braces like this. Now let's put the values. Let's say 100, 101, 102, a comma, enter. Now the second row, and the value is 200, 201, 202, the trailing comma once again, and here comes the third row. The values are 300, 301, and 302. So what we have done here, we have simply initialized a two-dimensional array with values. The array has the same structure, 3 rows and 3 columns. So here we have row 0, row 1, and row number 2, and here we have column 0, column 1, and column 2. Just have a look at the image on the screen. This is how our array looks in the memory. We have values to the right, and all the values have their own index values. If I want to access 100, I'll provide the index 00. If I want to access 202, I will provide the index 12. If I want to access the last value, 302, I will provide the index 22. For example, in the console write line, we can simply write matrix of 0, 0. 0, 0 gonna print out 100 because the index value of 100 is 0, 0, row 0, and column 0. And let's write some more write line matrix of 1, 1. This value has the index 1, 1. You will see in the console 2, 0, 1. And one more console write line, and this time I'm going to print 300. 300 has an index value of 2 and 0, row 2 and column 0. The first value represents the rows and the second value represents the column, and now you will see 300 in the console. So let's run the program and check the output. And so you see the output 100, 200, and 300, right? 100, 200, and 300. So my friends, that was two-dimensional array in C Sharp. Easy to create and easy to read out. But there is one thing, and you need to be very careful about it. There is a requirement with the two-dimensional array. And that requirement is all the rows must have the same column length. For example, we have 3 rows and all the rows have the same length, right? We cannot have different column lengths. For example, in the first row, I try to insert another value 103. Now you see the error in our program. We have simply disturbed the structure. Our first row has 4 columns, whereas the second and the third row have only 3 columns. All the rows must have the same column. The structure should be a rectangular structure. So simply remove the value or make all of them same, like this. So just remember this requirement. A two-dimensional array requires all the rows must have the same columns. If you want your rows to have different columns, then we have another structure which is called checked array. And checked array is next on our list, right? So we will cover it later on. So my friends, that was two-dimensional array, and now we know how to create it, how to initialize it with values, and how to access the components, how to access the values. So do some practice by your own, create some arrays of different data types like string or floating point numbers. I will see you in the next lecture. In the next lecture, we will learn to apply loop onto dimensional array. And this is going to be very interesting. So I will see you there. Thanks for watching. In the last lecture, we learned to code two-dimensional array, and now we know how this structure works and how do we read out the values from the structure. For example, here is a code we wrote in the last lecture. We created a two-dimensional array matrix, and the array has 3 rows and 4 columns. And to access the value, we use the rows and the column index values. For example, 0, 0 represents the first value because it exists on row 0 and column 0. And when we provide index values to the array for reading out or for writing, the first value represents the row and the second value represents the column. So these were the concepts we discussed in the previous lecture. And in this lecture, we are going to loop through this entire structure. And we know that from the previous lectures, arrays can only be handled using the loop. We cannot add, remove, and update the values manually. So let's learn how do we apply loop onto dimensional array and read out all the values. We are going to use the same array that we have in our program. Now, before we apply loop, there are 3 important things we need to understand. The first thing is the length property, right? We know the length property returns the number of components, and number of components are actually the length of the array. And the length property works very well on one dimension array. But in this case, when we have two different dimensions, length property is not very useful. It returns the number of components, but number of components are not enough to loop through this structure. We actually need the number of rows and columns in order to loop through this structure. So let me first show you the output of this length property. So we are going to apply the length property on our array, and the output should be the number of components. Now you can see we have 3 rows and 4 columns. The number of components should be 12. So let's run the program and check the output. And so you see the output in the console. 12 is the answer. So that means we have 12 components in our array. So the length property is not very useful, especially in the case where we wanna loop through this structure. The two-dimensional array, in fact, has its own methods to get the number of rows and columns. And the name of the method is getLength. In a console WriteLine, we will call the getLength method and provide a constant value of 0. And in the second console WriteLine, we will write the same getLength method. And now here we will provide the constant value of 1. The 0 is a constant value, and it returns a number of rows. And 1 is also a constant, which returns the number of columns. So getLength method with the values 0 and 1 is used to retrieve the number of rows and the columns. And 0 and 1 are the constant values. 0 represents the rows and 1 represents the columns. Now you will see the output. The first WriteLine will return 3 because we have 3 rows. And the second WriteLine will return the value of 4 because we have 4 columns. Well, let's run the program and check the output. And so you see the output, right? 3 and 4. So we have 3 rows and 4 columns. So that simply means when we loop through this entire structure where we have 2 dimensions, we do not use length property. We actually use getLength method to get the number of rows and the columns. In order to loop through this structure, we apply for loop, and for loop is the best loop to apply on arrays. We have already seen and discussed that in our previous lectures. So one thing is definite, we will use for loop, but a single for loop is not enough here. We have 2 dimensions. We have rows and columns. So to access both the index values from the rows and the columns, we actually need nested for loops. That simply means this two-dimensional structure cannot be looped through without nested loops. When we create nested loops, we actually have a loop inside another. We have an outer loop and inner loop. The nested for loops and the execution of the structure we have already covered. I did a separate lecture on nested for loops. So if you have missed that lecture, go to the channel, find the lecture and watch it. So nested for loops are required to loop through this structure, and when we create nested for loops, the outer loop gonna loop through the rows and the inner loop will go through all the columns. So let's create nested for loops in order to loop through this two-dimensional array structure. This is our outer loop, and this loop gonna loop through the rows. As you can see, I am using the getLength 0. GetLength 0 simply returns the number of rows, and here I am going to change the name of my variables in order to make the code more understandable. Let's say the name of the variable is row instead of r. And now inside the outer loop, we are going to create another loop. And this time the variable name is column and the getLength value is 1 because we are going to loop to the column in the inner loop. The execution is simple. When the value of row is 0, and this column variable will go from 0 to 3, right? We have 4 columns having index values of 0 to 3. GetLength will return the value 4. So our column variable will go from 0 to 3. When the value of the column value becomes 4, this loop stops its repetition. Now let's say if we compile our code manually, so when the value of the row variable is 0, this column variable will go from 0, 1, 2, 3. Now in the second repetition of the outer loop, the row becomes 1, and once again the column will start its repetition from 0, 0, 1, 2, and 3. And in the third and the last repetition of the outer loop, the value of the row becomes 2. And once again, when we come inside the loop, the inner loop will go again 0, 1, 2, and 3. This is wrong here. 0, 1, 2, and 3. Right, so every repetition of the outer loop, this inner loop will start its repetition from 0, and this is how this nested loop structure works. And that also means in the first repetition, we are pointing to the first row using the outer loop and then going to the right from one column to another column using the inner loop. In the second repetition of the outer loop, we are pointing to the second row and then once again visiting all the columns from left to right using the inner loop. So loop variables here, rows and columns, are actually representing the index values. Now we can provide these index values in console WriteLine to print out all the components. The first value is a row value and the second value is a column value. That's it. Now, before we run this program, we can make our output more interesting. When we leave this inner loop, that simply means we have went through all the columns. So we can simply print a line gap in the console. Now, let's run the program and check the output. And so you see the output in the console. We have successfully loop through all the values one by one, right? Here you see the first column or the first row, here we have the second row, and here we have the third row. We can actually make our output more interesting just by removing the right line or changing the right line with right method. And here we can put a simple space between the components like this. Now you see an output exactly like this. So let's run the program. Check the output once again. And so you see the output, right? Here you see an array and the same output in the console. So my friend, that was all about looping through two-dimensional array. And here you need to remember only two things. The first thing, we do not use length property. We actually use getLength method. GetLength with value 0 returns the number of rows and the value 1 returns the number of columns. And secondly, a single for loop is not enough because we need to access both the rows and the columns, and that's why we apply nested for loops. So my friends, that was all about two-dimensional array, and we have covered this topic thoroughly. Now we know how to create a two-dimensional structure and how to loop through it using the nested for loops. In our next lecture, we are going to cover the checked array. Checked array is the last data structure in the array category. I will see you there. Thanks for watching and take care of you. As you know, we are working with collections in C#. We have already talked about linear array in our previous lecture and two-dimensional array in the last lecture. Now the last collection in the array category is the checked array. So let's move on and learn this interesting data structure of the collection. Checked array is also called array of arrays. That means an array with multiple arrays inside. When we create a checked array, then you will see it's simply a collection of multiple arrays. Checked array also has two dimensions, rows and columns, just like the two-dimensional array we covered in the last lecture. So we have two data structures with rows and columns, two-dimensional array and checked array. Now the question here is, what is the actual difference between the two-dimensional and the checked array? To get the answer of this question, let's study the diagram on the screen. The diagram on the screen tells you the difference, right? It cannot be simplified further. A two-dimensional array is always rectangular. We know that from the previous lecture. All the rows must have the same number of columns. This is a requirement. Whereas in the checked array, rows can have multiple number of columns, as you see in the diagram. That is the main difference between the three-dimensional and the checked array. Another difference lies in predefined construction. Two-dimensional array has its predefined construction syntax, whereas checked array is constructed by combining multiple arrays into one. So these are the two main differences between the two-dimensional array and the checked array. And when we write code, you will get more understanding of it. So let's move on and do some practice. I have saved this code from the previous lecture where we have a two-dimensional array, and the array has 3 rows and each row has 4 columns.
And like I said, two-dimensional array has a requirement. All the rows must have the same number of columns. For example, if I try to insert another column here, 104, and you can see the structure is disturbed. And the error says, I think initializer of length 5 is expected. That means we must increase the length of the column to make all of them 5, right? So this cannot be done in two-dimensional array. But in jagged array, you can have multiple rows containing different number of columns. For example, in a store, you have 3 payment counters. So each row is actually representing a payment counter, and the column values are representing the number of customers coming forward to a payment counter and paying there. In this situation, you cannot always have the same number of customers to each counter. So the number of customers going to the counters can never be the same. We all know that is a common observation. So in this situation, jagged array can be a choice because you are not sure about the length of the columns. I hope you guys got my point. Let's move on and learn to initialize the jagged array. Jagged array has its own syntax and it is simply declared like this. We are going to create an integer array, 2 pairs of large brackets like this. This simply tells the compiler we are going to create a jagged array, and right after that we need to select the name of the array. Let's say the name is jagged array, new, and once again 2 large brackets. And now in the first large brackets we need to decide the number of rows. Only the number of rows you need to decide. The column value is not needed. That is the point, right? The number of columns can be different in each row. Now let's say I want to create a jagged array with 3 rows. I will put 3 in the row section. That's it. Now we have declared a jagged array which has 3 rows. At this point, our array is totally empty. It only has reserved 3 places for the rows. The memory representation of this line of code you see on the screen, 3 reserved places for the rows. That's it. Now in the second step, after the declaration, we are going to assign columns to each row, and each column is actually a linear array, the structure you see here, and that's why jagged also called array of arrays. So we need 3 linear arrays, 1 for each row, and those arrays can have multiple columns. So let's now create 3 linear arrays. For example, the first array is A, which has values 1, 2, 3, 4, 5, 6, 7. Let's copy it. This is, and here we have the third row, and they have multiple values. For example, 8, 9, and here we have only 5 values. Now we are going to assign these linear arrays containing different columns to each row. How do we do that? Jagged array of row 1, we are going to assign the first array like this. Jagged array of row 1, the second array, and jagged array of row 2, the third linear array. It might look confusing, right? We have a jagged array, we have a linear array, and now we are assigning linear arrays to the jagged array. The point here is you understand the term or the construction of the jagged array. Like I said, jagged array is actually an array of arrays, and here you see the practical example. It's an array of multiple arrays. Now the diagram on the screen can further simplify the concept. As you can see in the diagram, each row is actually pointing to a fully constructed array. Row 0 is pointing to A, row 1 is pointing to B, and row 2 is pointing to C. This diagram can be further simplified, and here you see the simplified version. And this is the diagram I want you to memorize. We have 3 rows and each row has multiple columns. That's it. Let's move on. So what did we actually do? We declared a jagged array with 3 row places, and in the second step, we assigned column values to each row. So we created a jagged array in 2 different steps, declaration, and here we have assignment. But just like any other data type, jagged array can also be initialized. So here you see an initialization. At the time of the creation, we are inserting the values. So how do we initialize the jagged array is an important thing to understand. Let's learn the initialization of the jagged array. It's very simple, just like the
a two-dimensional array, we need curly braces like this. And now each row is actually a separate array. So we are going to copy this piece of code here. We will put inside the array and we need to modify it a bit like this. And now remove the semicolon and put the comma. And then put a semicolon to terminate the statement. So this is a more practical way to initialize a jagged array. Things are the same here. Program will create 3 rows and each row has multiple columns. As you can see here, right? The length of the columns are different. Now there is another syntax which can also be used here to further simplify the creation of jagged array. And that syntax is, we do not need a linear array creation syntax like this. And instead of that, we will use the large brackets around our column values like this. This is much better than the previous one. Now it looks much better and resembles quite a lot with the initialization of the two-dimensional array. As you can see here, the resemblance. So that was all about the creation of the jagged array. Now the next step here is the use of the length property. Jagged array, now we know, is an array of arrays. So length property is used here. Let me put a comment, length property. We need to learn the use of the length property to get the number of rows and the number of columns on each row. So to get the number of rows from the jagged array, we apply the length property directly on the array's name, which simply returns the number of rows, and the output here should be 3 because we have 1, 2, 3 rows. Let's run the program and check the output. And so you see the output in the console, right? The number of rows are 3. So apply length property directly on the array to get the number of rows. Now to get the number of columns from each row, we code like this. Jagged array, we need to point to the row, for example, row 0 of length. Now we want to get the length of an array which is assigned to row 0. And this is the array which is assigned to row 0. And here we have a length 7. So let's run the program and check the output. So it says 7 in the output. Number of columns in the first row. Now, another thing that we need to investigate here is how to access individual component. The method is the same. Use the row and column index value. Now, for example, I wanna print the value 8 from the second row. So I will write a statement like jagged array. The row is second and the index value of the second row is 1. And now the index value of this component, we must count the index value 0, 1, 2, 3, 4, 5, 6, 7, right? So the column value is 7 and this will simply return the value 8, the component. Let's run the program and check the output. And so you see the output in the console, right? Component 8 from the second row. So that was the length property and how to reach a single component. Now, the last thing here and the most important thing here is loop through the jagged array. We know from the previous lecture that we need nested for loops in order to loop through array with 2 dimensions. Jagged array has also 2 dimensions, a row and column. That means we need nested for loops. The outer loop will simply point to the row and the inner loop will go each column in the pointed row. This is how we iterate over 2 dimensions structure. So let's have the nested for loop. This is our first for loop and inside that we will have another for loop. The outer for loop gonna select the rows one by one and the inner loop will select and go through the columns of the selected row by the outer loop. So to get the number of rows, we will simply apply
the length property on the array. This will return value 3, number of rows, and the valid rows indexes are 0, 1, 2. So this loop will go through all the rows 0, 1, 2. And to get the column length of each rows, we will code exactly like this, but instead of the constant value, we will use the loop variable. We also need to change the loop variables here. We can make it more simplified if we change the name of our variables like rows and columns like this. To get the length of each column, select array of row dot length. Simple is that when the value of the row is 0, we will get the length of the first array here, which is 7. And in the second round, when the value is increased and become 1, we will get the length of this one. And in the second round, we will get the length of this one. Now we can print out all the values. Object array of row of column and a line break when the entire row is printed. Console WriteLine. We can also put a space between the components. Just put a space here like this. Now run the program and you will see all the values in the console. I think we need to use the write method instead of WriteLine. You see the line break after each component. So instead of WriteLine, we are going to use write method. Now we see a beautiful output. And here we see all the values from all the rows and columns, right? So this is how we loop through a jagged array in C#. So my friends, that was the jagged array we covered in this lecture. Jagged array is just another two-dimensional data structure. Do some practice with this array. We can have, for example, a string array instead of the integer array. Use the indices to print the values manually. Try to use the length property and then try to loop through the entire array. Now we are done with the array collections in C#. We know how to create and use linear array, two-dimensional array, and jagged array. The next collection on the list is the list collection. List is generic and dynamic. We will discuss more about it. It's a very practical and a very useful collection. So we will discuss this collection in the next lecture. I will see you there. Thanks for watching this one.
As you know, we are working on collections in C#. In the last lecture, we covered jagged array, which is the last collection in the array category. So we are not done with the array collections, one-dimensional array, two-dimensional array, and jagged array. So let's now move on and learn another interesting collection, which is called list. List is a practical collection and it is used in real applications. So why do we call a list a practical collection and what are the limitations with the array? We are going to find out in this lecture. So let's jump into the code and get the hand dirty. Our topic is list collection and I will start this lecture by coding a simple program just to show you the limitations with the array. Now let's say we have a string array with the name list and that array can save 3 names. We are going to read the name at the runtime from the user. So let's just print a message, provide some names. And now we will simply loop through the array for the indexes and read the names using the read line. And once the array is filled with the names, it will simply print out all the names using the for each loop. Just print a message above the for each loop as well. You provided following names. So very simple application, right? We have an array with 3 places and here we are reading the name at the runtime. Runtime means execution time. When the program is executed, then we are going to read the names in the program. And once the array is filled with the names, we are going to print out all the names. So let's run the program and check the output. And here we have our program provides the name. Let's say Adam, Sarah, and Peter. And here we have all the names we provided. So our program is working as expected. But the problem here is, the limitation here is the array are always fixed size. And what does it mean? That means now let's say at the runtime, I want to provide more than three names. So let's just say it is a requirement to provide more than three names. Let's say four name, five name, or six name. Or we don't know exactly the number of name or the amount of data. We don't know, right? So in this case, where the amount of data is unknown or the amount of data is dynamic, we cannot use array because array is always fixed length. And because of this limitation, array data structure is unpractical. And we can't use this data structure in real application. In addition, there are also some other limitations with the array. Now, let's say I want to insert a name in the middle, or I want to insert the name at some specific position, or maybe instead of inserting a name, I just want to remove a name. I want to shift a name from one place to another. So these kind of manipulative operations are also not available here. Right, so array has its limitation. Array is always fixed size, and when the amount of data is unknown, we cannot use array in our applications. The question is, what do we use instead of the array? What alternatives do we have? The answer is we have list collection. The list is a dynamic data type. It is free from the size. It expands and shrinks based on the operations. And not only that, in addition, you can insert the item anywhere in the list. Even you can remove the item from anywhere in the list. So all these features makes the list collection a practical collection. And like I said, we use list collection in real applications. So let's see how do we create a list, learn its syntax and the behavior. I'm going to remove this code and now we will create a list for storing the names. And we don't know the number of names. They can be 5, 10, 50, 20, whatever. So when we create a list, we start with the list reserve word followed by two parentheses greater than and less than, and inside these two parentheses we put the data type. So the data type of our list is a string, and now we are going to choose the name. The name of the list is name list, the keyword new, and then once again the list and the data type. So we have simply created a list data structure. The name of the list is name list. And this is the syntax. And you can see we don't need to mention the size just like we did with the arrays. So once the list is created, we can start using it. The list collection has its own methods, and we will learn most use methods in this lecture. The first method is the add method. Add method is used to add elements to the list. Now let's say I wanna add some name to our list. So I will call the add method. It's a predefined method. And here I will, let's say, Peter, the first name, name list dot add. Once again, the second name is Sarah. And let's have another name. And the third name is Adam. So simple as that. Using the add method, we can insert elements to the list, and in the background, the list is saved just like an array. That means the first element is at index 0, second element is at index 1, and the third element is at index number 2. So our list now have three components, Peter, Sarah, and Adams. And in order to read out the components, we have two different options. We can simply use the array notations just like we did with the array, large brackets, and inside the large brackets, we simply provide the index. Let's say the index of the Peter is 0, or we can use the list predefined method, which is called at, element at, sorry. And to the element add method, we simply provide the index. Let's say the index value is 2. So these are the two options to read out the values or the components from the list. So let's now run the program, and in the output, you will see the first write line will print the name Peter, and the second write line will print the name Adam. So let's run this application and check this out. And so you see the output in the console, right? Peter and Adam. So for inserting or writing to the list, we have add method, and for reading out, we can use array notation or the predefined method element add. Now the next thing we need to learn here is the count property. Count, just like the length property, it returns the number of elements of the list. For example, our list has three elements, Peter, Sarah, and Adam. So let's check the output of the count property. We will call the count on the list, and the output should be 3. So let's run the program and check the output. And so you see the output in the cancel, right? So we have three components. So this count property can be used instead of the length property in the for loop. Now we are going to looping through the list using the for loop, and we'll simply use the count property, make the use of the count property, and we'll print out all the name in the cancel, right? Now our program will loop through the entire list and will print all the names in the console. Let's run the program and check the output. And so you see the output in the console, right? All the names are printed. We can also use the same way. We can also use the for each loop. For example, for each loop, the data type is a string, str, or we can change the name like n in name list. And then simply in our console WriteLine, we can print the variable n. So both the loops are doing the same thing, going through the name list and printing out the names. So let's run the program and check the output. And so you see the output of both the loops, right? The same output. This is the first loop, for loop, and this is the for each loop. The output from the for each loop. The another property, an important property, is the clear property. The clear property simply remove all the components and the list become empty. So now if we call the uh, clear property on the name list, so our, or it's not a property, it's a method. Our name list is now empty. We can confirm it just by calling the count property on it, right? The name list of count. Now the result should be 0. So let's run the program and check the output. And so you see the output in the console, right? Our list has no component, 0 in the console. So our list is now totally empty. Now let's say I want to insert the names in our name list and I don't know the number of names. We will decide it at runtime, right? So we can start with a string variable. Let's say the name of the variable is name and it has only a space from the beginning, right? And as we don't know the number of names we are going to insert, so the repetitions are unknown. And when the repetitions are unknown, we use the while loop, and we will say as long as the name is not equal to an empty string. When the name variable has the empty string, this condition will become false. So, and from the beginning, our name variable has only a single space. So this condition will become true because space is not equal to empty string. And here we are going to print a message to the user. Okay. We will say insert names and hit enter to terminate. Now we come inside the loop. And now in the name variable, we will simply read the name using the read line method. And once the name is saved in the name variable, we will assign it to our name list collection using the add method. And before inserting the name in the list, we can code a if statement here. We say if name is not equal to empty because we have an empty condition in order to terminate the loop. So if the name is not empty, that means there is something, so we can insert the name in our list. And what do we know from the readLine method? When we do not provide anything to the readline and hit enter, it returns an empty string. So as we hit enter without providing anything to the readline method, it will return an empty string which is saved in the name variable. And as the name variable has an empty string, this condition will become false and we will leave the loop. So we can now insert as many names we want under the execution time and our list will grow automatically. And now after the loop, we can simply copy this for each loop down there. So we can print out all the values. So let's run the program and check the output of this application. Right, so now we can provide the name. Let's say the first name is Salah, the second name is Oscar, then we want to provide Peter, Adam, Johan, and let's say Sila. And now, let's say now I will just hit the enter. You see, I hit the enter and the program is terminated, the loop is terminated, and this is the result of the for each loop. So all the names we provided become saved in the list, and here you see the output from the list. So my friends, now we have experienced the list collection, and the list collection is much better than the array. We work with the string type, but we can create a list of all the valid data types. For example, a list of string, a list of double, a list of any object or any class. We don't have any object or any class, right? So these were the basic concepts of the list, basic features of the list we covered in this lecture. In the next lecture, we will continue with the list collection, and we will cover some important predefined methods. So I will see you in the next lecture. Thanks for watching.
In the last lecture, we talked about list collection. List collection is generic and dynamic. It expands automatically. This lecture is a continuation of the previous lecture. Just like I told you at the end of the lecture that we would cover some important methods and properties which can be applied on the list collection. So here we are now. Let's continue with the list collection. In our code file, we have an empty list of type string, and the name of the list is namelist. And here are the topics we are going to cover: capacity, insert, add range, contains, and sort. These are the options we use quite often on the list collection. Let's start discussing these topics from top to bottom. The first topic here is capacity, which is very important to understand. According to the official documentation, the capacity is defined as the capacity of a list is the total number of elements the internal array can hold before it needs to be resized. Straightforward definition, but it needs to be understood properly. Whenever you create a list, the compiler creates an internal array and reserves some places for the incoming components. That's an important point. What did I say? Whenever you create a list, an internal array is created in the background, and that array reserves some spaces for the incoming components. As long as your list is empty, the internal array is also empty. And the size of that internal array is actually capacity, right? So capacity actually represents the internal reserve spaces by the compiler. And when there is no component in the list, the value of the capacity is also 0. Let's have some experiments. We are going to investigate the value of the capacity together with the count. In a console WriteLine, we are going to print the value of the count. Count represents the number of components, and the list is empty at this point. We can write here number of components, name list of count, like this. And now the capacity of the list, name list of capacity. Capacity is also property. The output of both the statements should be 0 as our list is empty, so the capacity is also 0. Let's run the program and check the output. And so you see the output in the console, right? Number of components 0, and there is no reservation in the memory. Capacity is also 0. Now we are going to insert a single component in our list. Let's do that. I'm going to put my name, Sala. As we have inserted a single component, the value of the count will definitely become 1 because count represents the number of components, and the value of the capacity will become 4. Our compiler will automatically create a dynamic array in the background and will reserve 4 spaces in advance for the incoming components. Let's confirm it in the console. Run the program. You will see 1 and 4 in the output. And so this is the output in the console, just like I told you. The component is 1 and the capacity of the list is 4. It means our list has reserved 4 spaces in the memory. Now what will happen when the number of components or the value of the count reaches capacity? In this case, our compiler will automatically create a larger array in the memory and will copy the components from the smaller array to the larger array. And usually the capacity of the larger array is a multiple of the previous capacity value.
That means the capacity of the new larger array should be 8. Let's have an experiment. I'm going to insert more name. Let's say Adam. And the last one is Trump. Now the value of the count simply exceeds the value of the capacity. That means our program will create a larger array in the background in order to accommodate these components, and will have some spaces reserved for the incoming components. Let's run the program and check the output. And here is the confirmation, right? The number of components are 5 and the capacity, the internal reservation, is 8. This concept and the creation of the internal array will continue in the same way. As we insert more components and the value of the count exceeds the value of the capacity, our program will simply create a larger array in order to accommodate all the components. This is how the concept of capacity works in dynamic collection. One thing that we can do more here is we can define or reserve the capacity value in the constructor. I can reserve 100 places in the memory by giving a value 100 to the constructor. Now the value of the capacity is 100. That simply means we have reserved an array of 100 places, although the components are only 5. It can be the waste of the memory, and that's why you should be very careful while issuing the value of the capacity. The thing which has more concern here is that when the value of the count exceeds this capacity value, our program will automatically create a larger array than this one, and the size of the array is a multiple of the previous one, so that can be 200 reserved places. Let's run the program and check the output. And so you see the output in the console, right? We have components 5 and the internal array size is 100. In a case where you know that you will only store 100 items in a list, you can have this capacity value. However, you will always check the value of the count before inserting the component, because value of the count shouldn't exceed the capacity value. Otherwise, a new and larger array will be created in the background. The list collection also has a very useful method which is called trim access. So in a case where you have a memory shortage, you can call the trim access method to release the unused allocated memory. Now, for example, here on our name list, we are going to call the trim access method like this. Now all the unused memory allocation will simply be released, and you will see a smaller value in the output. I think the value should be the same as the value of the count. Let's run the program and check the output. And so you see the output in the console, right? The unused allocation is now released. So that was all about the capacity. Let's move on. Now, the next one is a insert method. It's also a very useful method. Can take two arguments. The first one is the index value, and the second one is the element or the component you wanna insert. The add method that we discussed in the previous lecture simply adds a component to the end of the list. When using the insert, you can simply choose an index where you wanna insert the element, and all the other elements will simply shift themselves one position to the downward. Now, for example, Salar here is at index 0, and I want to put another name at this index. So on the name list, I will call insert method like this, and I want to insert at the index 0, and the name is Johanna. We can also print the value out in the console so that we get the confirmation. Let's create a for each loop. The collection name is name list. The type of the items in the string, let's call it simply a name. Now in the output, you will see Johanna is inserted at the first position or the 0 index, and all the other names will be shifted one position downward. Let's run the program and check the output. And so we see the output in the console, right? Johanna is at first position. I think there is another method I'm missing here, and we can cover it in connection with insert, and that method is remove at. Let's call it 1.1. Remove at is a very useful method. Definitely we need to remove some items from the list, and this method simply takes index value of the element we wanna remove. Now let's say from our list we wanna remove Adam. So the index value of the Adam is 2. because we are inserting Johanna before calling the remove at method. So Johanna will come first in the list with the index 0, Salar index 1, and Adam is at index 2. So let's call the remove at method and give it the index value of 2. Now you won't see Adam in the output. So let's run the program and check the output. And so you see the output in the cancel, right? Adam is totally removed. So that was the remove at method. Now, the another method, very important method here is add range method. Using this method, you can insert several items in a list. For example, we have an array and a string array of multiple names. We are working with the names and the data type is a string. So we need to create a string collection. Let's put some more name here. I need to think of some names. For example, Tony, Tom, and class. Add range method simply takes a collection as an parameter. For our name list, we are going to call the add range method like this, and to the method simply provides the name of the collection. Now these three names will be added to the end of the list in the same order: Tony, Tom, and Claus. So let's run the program and check the output. And so you see the output in the cancel, right? Our list is getting longer. Now, after the add range, we have contains. Contains is also a very useful method. When you want to find something in the list, you can call the contains method. This method will simply return true or false, and based on the true or false, you can process further in your program. Now, let's say I'm going to call the contains on the list, and I simply want to find out if the name Trump is in the list or not. And we have Trump in the list, so the output should be true. Let's run the program and check the output. And so you see the true value, right here. So our program can simply find the Trump in the list. Now the last method is the sort method. Sort is also useful. It can make your data more presentable. It will simply sort your data. No argument with the method is needed. Just simply call it on the list like this, and your list is now sorted. Let's run the program and check the output. I think the list should be in alphabetical order. And so you see the output in the cancel, right? In alphabetical order, C comes first, then J, Salar, Sara, and the other ones. So my friends, now we are done with the list collection. You must have realized this collection is very important and practical. Do some drills by your own and use this collection in your program instead of arrays. Now the last thing which is left to cover in the collection section is the dictionary collection. Dictionary collection is just another flavor. We will talk about it in the next lecture. I will see you there, and thanks for watching this one. As you guys know, we have been discussing and learning collections in C#. We talked about linear, two-dimensional, and checked array, and in the last lecture, we winded up list collection. Now, the last collection on our list is dictionary collection, which we are going to cover in this lecture. Dictionary is a different collection. In the dictionary, we do not work with index values. It actually holds data in key value pairs. Key value like data structure you will find in every programming language. For example, in JavaScript, objects are key value structure. In PHP, we have associative arrays which are based on keys and values. And the Python language also has dictionary data structure. So it's an important data structure to learn and understand. Let's move on and learn to create this interesting data structure. The first thing here is the declaration. How do we declare and create a dictionary variable? In the comments, I will simply show you the general syntax of the dictionary. Dictionary is also a generic and dynamic collection, just like the list collection. You only need to remember this thing. When we create a dictionary, we start with the dictionary keyword, and in the parentheses, we first mention the data type of the key. We can write here key type, and then we mention the data type of the value type, and then the process is the same. For example, my dictionary new, and now we will repeat the same data type and the
constructor, key, type, and value type. This is a general syntax for declaring or creating a dictionary. Now let's say I want to create a dictionary where the key is employee ID and the value is employee name. For both the types, I can choose the data type, string. String will work here. And now I will choose the name of the dictionary. For example, the name of the dictionary is employees, new dictionary. Here comes the suggestion, and that's it. So we have simply created a dictionary where the key is for ID and value is for employee name. In this declaration, I have chosen string for both the values, but you can have different types for the key and the value. For example, we are going to create another dictionary where the key is product name and the value is product price. The first value is for the key and key is product's name. So the best data type here is string, and for the price, we can choose decimal or we can choose double. And now once again, the name, product, and price, like this. So you see, we have two different dictionaries, employees and product and price. And in the second dictionary, the key is product name and the value is price. And we are using different data types for the key and for the value. That was the declaration and the creation of a dictionary. Let's move on. When the dictionary is created, you will definitely populate it with the data. And for that, we have add method. Let's say in the employees dictionary, we are going to call the add method like this. The first value here is the key value, which is ID in the string form, comma, and the second value is the employee name. Let's say the employee name is Bob. We can insert another employee using the add method. And now here, the key value or the ID is 002 and the employee is Sarah. Let's insert another employee. You can think of a dictionary just like a table, two columns table, where a single row represents an object, but the data is divided into two different columns, such as 001 represents the Bob, 002 represents Sarah, and 003 represents Tony. Now, the same way, using the add method, we can insert data in our second dictionary. So on the product and price, we will call the add method. Let's say the product name is RAM and the price is $500. Let's insert another product. And this time the product name is CPU and the price is $750. And another product is power supply and the price is $200. So we now have two different dictionaries and both of them have some data and the data is in key value pair. Let's now talk about the initialization. What did we do? We created or declared a dictionary and in the next step we added data using the add method. But you know, all the variables, arrays and objects can also be initialized at the time of their creation. The same rule applies here. We can initialize a dictionary at the time of its creation. So in order to initialize the dictionary, you will use this syntax. Just remove the parentheses. Now open the curly braces. And inside these two curly braces, every pair will also have their own curly braces. I mean key value pair. And inside these pairs, we will provide the data. We can copy and paste the same data. This is called initialization. We are doing the same thing as before, but this time we are inserting the data at the time of the creation. Now, in order to initialize a dictionary, we also have another syntax.
The syntax that you see here is a very common syntax. This syntax is readable, but there is another syntax you can use if you want. This another syntax is called initializer syntax. So let me show you the syntax. We use square brackets like this on both the sides of the key, and assignment is used to assign the value to the key. Here you have the initializer syntax. You can use any one syntax that you like. Things are the same, but the way we write them is different. Let's move on, as we now know how to declare and initialize a dictionary. Now, the next thing I'm going to tell you is an important one. The keys in the dictionary must always be unique. You are not allowed to duplicate or repeat any key. For example, in our employees dictionary, I am going to add another employee, and this time I am going to duplicate the key. For example, 001. As you can see, the 001 is already used with the employee Bob, and the employee name is Trump. Our compiler is not showing any error, and even the error list is empty. Now, let's run the program and see what happens. And here you see the exception within no time. Argument exception. An item with the same key has already been added as key. Right? So we are not allowed to duplicate the key values or simply the keys. So that was something you need to be very careful about while working with the dictionary. Let's move on. Once you have dictionary with data, you definitely need to read out the values. To read out the values, we use key values. There is no index concept. Like in the arrays or the list, we use index values to read out the components. But here, we will use the keys. Now, for example, in the console WriteLine, we will call our dictionary large brackets, and inside the large brackets, we will provide the key. Let's say the key is 002, and this line of code will simply return the value Sarah. Now, from the second dictionary, the name is product and price. We are going to read out, let's say, CPU, and here you will get the price 750. Let's run the program and check the output. And to see in the output, right? The employee Sarah and the price 750. So in a dictionary, keys are used to read out value. Now, what will happen if we provide a key that does not exist in the dictionary? For example, I provide a key 005 that does not exist. Our program will simply throw an exception. So let's run the program and see what happens. And so you see the exception, key not found exception. So if you provide a key that does not exist, our program simply crash. And that's why in order to save our program from crashing, we perform a simple check before reading out the value using the key. The contains key method is actually used to find out if a key is a part of the dictionary or not. Contains key method returns a boolean value. If the key is found, the value is true, otherwise false. Let's say the key we want to read, we have in a variable, and key is the same, 001. 001 is Bob. Before we use this key on the dictionary, we will simply call the contains key method, and we provide the key we want to read out. And if this method returns true, that means this key 001 is a part of the dictionary, and so we can simply read out the value. Let's provide the variable key here. We can also print a key here. For example, employee ID, employee name, like this. So this is a safer way to access the values of the dictionary. Let's now run the program and check the output. And so see the output in the cancel, right? Employee ID 001 and employee name is Bob. Now let's say if I try to provide an ID that does not exist, 009, we would never come inside this if statement because the contains key method gonna return a false value. Our program will not crash and we see nothing in the cancel, right? Now, in order to update and modify you to the same, you assign a new value to the key. And you always use contains key method to make sure if the key is a part of the dictionary or not. Now, let's say you want to update the name Tony and the key is 3. So let's change the key. Key contains will return the true value. And this time we will update the value first and then print the data. So employees, key, and let's update the data or the value, Tony Johansson. Now as we run the program, you will see the name is simply updated. So let's run the program and check the output. And so you see the output in the cancel, right? Employee name is simply updated, Tony Johansson. Another very common operation that we apply on the dictionary is the remove operation. And for that, we have a remove method. This method is very safe. If the key is found, the method will simply remove the pair, key value pair, and return the true value. On the other hand, when the key is not found, method simply returns the false value. Now, for example, from our second dictionary, product and price, I wanna, let's say, remove this pair, key value pair, RAM. So I will simply call the remove method and save the result in a boolean variable. Let's provide the key here, which is RAM. If this key is found, this line of code from the list will be deleted and a true value is returned. Now we can check a true value and inform the user. That's it. As you run the program, you will see item is removed in the console because the key RAM is a part of the product and price dictionary. So let's run the program and check the output. And so you see the output in the console, right? Item is removed. As you know, the method remove returns boolean values. We can also call this method directly inside the if statement, like if things will be the same. Now we know how to create a dictionary and how to add, remove, and update its values. The last thing that we need to know is looping through a dictionary. And this one is interesting. We can loop through a dictionary in 3 different ways. If you are interested in both keys and values, you can loop through both of them and print them out in the console. Or you can only loop through the keys or only the values, right? There are 3 different possibilities. Let's learn all of them one by one. Now this time we are going to loop keys and values. And the dictionary we are going to loop here is the employees. The for each loop is the ideal loop for this purpose. Our collection here is the dictionary and the name is employees. Let's say the variable here is emp, and here comes a special value which is called key value pair, and the data types of key is a string, and for the value we also have a string. So instead of the type dictionary, we use, for example, dictionary. In normal cases we use key value pair, and now using this value emp we can access the keys and the values. So for example, in console.WriteLine we can print the values. For example, emp dot keys space and emp dot values, and we are missing the loop parenthesis. So this is how you can simply loop through both the keys and the values. Let's run the program and you will see complete pairs in the output. And to see the output in the console, right? Here you have the keys and here you have the values. Now the second thing here is loop only the keys. Once again for each loop, and now the collection we need to filter out our collection, but this time we only want to loop through the keys. So we need to filter out the values and provide only the keys to the loop. And the data type of the keys is strings. We need to change the type here, and the loop variable is k. Now in the write line, we simply provide the value k. It will print all the keys in the cancel. Let's run the program and check the output. And so you see the output in the cancel, right? All the keys. Now the last one is the values. How do we loop through only the values? Let me just copy and paste. The code gonna be a bit similar. Now we are going to filter out the keys and we'll only select the values, and the data type of the values is also strings. We don't need to change the type here. Loop variable we can change. Let's say instead of k, we have variable v. This loop gonna loop through all the values of the implied dictionary, and you will see values in the output. Let's run the program and check the result, and so you see all the values in the console. So my dear listeners, that was a dictionary collection in C Sharp. Now we have covered this entire collection section. We now know linear array, two-dimension array, checked array, list, and dictionary. It's now time to move on and learn new and interesting concepts. In the next lecture, we will talk about string class. We have been working with the string data type throughout this course, but now we will look closer to the string construction and the string memory representation, etc. I will see you in the next lecture. Thanks for watching this one. So as you know, in the last lecture, we totally winded up the collections in C Sharp. We learned to code the one-dimensional array, two-dimensional array, checked array, list, and dictionary. So now we know how to code different types of collections in C Sharp and their properties. It's now time to go ahead. The next thing we usually learn right after the collection is string. We know what a string is, how to create a string variable, how to concatenate a string, and how to print string variables. So we are pretty much familiar with the string, but the string is not the same data type as other primitive data types. A string is basically implemented as a class in .NET, and it has many important characteristics we need to know and understand because a string is an important data type. A string represents the text, and text is everywhere. In addition, a string class offers a lot of predefined methods which we use to manipulate the string value. So like I said, a string is an important data type. Data is sent and received in form of strings, and we also save data as a string. The most important thing that we are going to discuss and try to understand is the string memory representation. Our string value or the string object converts into a character array when the value goes into the memory. So string value is actually a linear or one-dimensional array. It's a very important concept, and because of that, we can perform manipulative operations on the string. So in this lecture, we are going to focus on strings memory representation and its characteristics. I am going to create a string variable. The name of the variable is message, and it holds a string or the text. Let's say I am learning C sharp, right? So MSG is the name of the variable. I am learning C sharp is a string value, a text which is also called string object. A string object is composed of characters, not only the alphabets, right? A space is not alphabet, but a space is a character. This hash sign is not alphabet, but it is a character. All the characters defined in the Unicode table can be coded as a string. So that was an important point to remember. Another important point is every character in the string requires 2 bytes of memory. 2 bytes of memory. That means if we have 5 number of characters, they will in total reserve 10 bytes. And when we want to print out the value of the string, we do the same like we do with the other variables. We simply code the variable name. Now we will discuss the string memory representation, which is the core concept. I just told you a string object is actually a one-dimensional or linear array in the memory. So this string object I am learning C sharp actually converts into the character array, one-dimensional character array as we run this application. To get the better understanding of that, let's study the image on the screen. MSG is a reference variable which is pointing to the string object. And you can see the string object is actually saved as one-dimensional character array in the memory. Every character is assigned its own space and all the spaces are consecutive, exactly like an array. And then the compiler will assign the index values to all the components or all the characters. And the index value, as we know, it starts always from 0. So the first character is at index 0. The second character, which is a space character, is at index 1. And the index value get increased the same way up to the last character. So that was the memory representation of the string. And because of that conversion, the string object's conversion into the array, we have access to the individual character. Using the index values, we can access all the characters one by one, and we can apply loop to go through all the characters in a string object. So now we know the memory representation of the string. Let's do some experiments and learn more about it. The variable msg simply print the entire string. Now let's say in another console write line, I will simply want to print the first character. The first character has an index value of 0. So MSG of 0 will simply print the first character, which is an uppercase I. For example, I just choose another random value, index value 7. So index 7 is somewhat here 0, 1, 2, 3, 4, 5, 6, 7. I think this lowercase a has an index value of 7. So you can see we are not creating an array, but a string is an array in the background. So let's run the program and check the output. And so is output in the cancel, right? This is the first character and this is the character which is at index 7. So this is simply a proof that a string is actually an array in the memory because we have access to the individual components using index values. Now, one thing is confirmed, the string is an array in the memory. That means we can call the length property just like we do on the array. Our length property will simply return us number of components, or in other words, number of characters. Just by calling the length property, we can find out the number of components of the string. So let's run the program and check the output. And here you see the output 16. So our string object has 16 characters. We can also loop through the string character by character using the for each loop and for loop. Let's say I'm going to loop through the string using the for each loop. Now, the MSG is our string, our local variable is ch, and the data type should be char. Now we are looping through a string object, and a string is basically composed of characters. So the value which is returned from the string object is a single character, and we use data type char to represent the character value. So this for each loop will simply go through this entire string character by character. Now let's say we use console write instead of write line. Here we are printing the character, and we want to put, let's say, a comma in between. So a comma after every character. So let's run the program and check the output. And so you see the output, right? Here we are reading out the entire object and we are doing the same here, but this time we are going like character by character, right? You can see it's an example of simple manipulation. And instead of for each loop, we can simply apply a for loop. When we use for loop, then we have access to the index values. We can perform manipulative operations. So let's code a for loop like this. The use of the length property is the same as it was in the array. And now we can simply print out all the characters msg and loop variable. So we are going through all the characters one by one using the indexes. So let's run the program and check the output. And so you see the output, right? Here comes I am learning C sharp. So as we go through a string object character by character, so we can do some interesting things. For example, we can count the number of spaces. And for that, we can simply need a variable. Let's have an integer variable count, which is 0. And as we are going through all the characters one by one, in an if statement, we would code something like this. And once the loop terminates, you can simply print out the value of the count. right? So MSG of I, this simply represents a single character, right? Single character means char value. And this is the way we code a space using the char value, right? So let's run the program and check the output. And so you see the output in the console, right? Number of spaces are 3. Don't get yourself confused with string and char value. A string is actually composed of char values. Now, let's say if I code a space using the string value in the double quotes like this, our program will complain because we are trying to compare two different variables. This one represents the string value, and this statement represents a char value or character value. And you can also read the description here. The operation equals to cannot be applied to operands of type char and string. So we can do a type conversion here before the comparison. For example, as soon as we get a character here, we can call the toString method on that before the comparison. So we are fetching the characters one by one from the string object, and before the comparison, we are simply converting the characters to string. So character gets its string representation before the comparison because on the other side, we have a string value. So this can also be done. Now let's say instead of spaces, I want to find out a specific character, let's say the character A. I want to know how many times the character A appears in the string. So I can simply do it like that. Let's run the program and check the output. The output should be 2. And so you can see 2 is the output, right? So my friend, that was a deep dive into string data type, but we are not done with it. We just learned the basics and the memory representation of the string. The string class has a lot of useful methods and properties which we are going to learn in the next lecture. So I will see you there. Don't miss the next lecture. Thanks for watching and take care of you. As we know, in our last lecture, we learned something new about the string. String is not a primitive data type. String is actually implemented as a class in .NET. String has a different memory representation. A string object is saved as single dimensional array. And we have seen that and experiment with it in our previous lecture. So we learned all the basics in our previous lecture. For example, how to use the index value to access the individual character, how to apply the length property, and how to loop through a string character by character using the for each loop and the for loop. And we also know that a string represents the text and the data in text format is everywhere. And in most of the cases, we need to manipulate, change, and update text type data. So that's why the string class offers a great variety of methods and properties to manipulate string data. So in this lecture, we are going to go through frequently used methods and properties which we apply on the strings in order to manipulate it. So let's have a quick look on all the methods we have in a string class. Open a browser tab and search for string class C#. Now, here we have the first link from the Microsoft, the official link, string class, belongs to the system, namespace. Now, click on that. And if I scroll down, so here you see constructor, properties, and here comes the methods. Now, you see the list is very long, right? So these are the methods we can apply on the string. And from this list, we are going to learn some of them, the methods which are frequently used. And you can simply use this documentation as reference. You want to learn something more about the string, the documentation is here. Just come here and try out the new things by your own, right? Now, coming back to our code editor, let's clean our code file, even the string variable. Now, I'm going to create two string variables here. Message1 contains the string object uh, hello, and string message2 contains the same object hello. Now the first thing here is string comparison. How do we compare a string objects? In order to compare two string objects, we can simply use relational operator equals to, or we have another built-in method which is called uh, equals. I think equal or equals. Uh, yeah, it is called equals. Now, for example, if I want to compare message1 and message2, both the strings are equal, so I will simply apply the relational operator is, and the result of this statement should be True. We can also use the result in the if statement. For example, in an if statement, now I will call the equals. Equals is a method it applies on a string object and takes another string object as parameter. So let's see MSG1, we are going to call the equals on the first string object MSG1. Here comes the equals, and the second we're going to send as object like this. So using the method, we are going to compare if the first string object equals to the second string object. Now, the interesting thing here is that the equals method in the background calls the relational equals operator. So this operator is actually called in the background by the equals method. So there are two ways to compare the strings for equality, and this one is most popular. Now, in the if block, we gonna simply write a statement. This strings are equal. So let's run the program and check the output. And so you see the output in the cancel, right? True, coming from the first statement, and the strings are equals coming from the if statement. Strings are case sensitive. If I simply turn this uppercase letter H into the lowercase letter, then the result would be false. The uppercase is not equals to the lowercase because they have different character code in the Unicode table. So remember this point, strings are case sensitive. Okay, let's now move on. That was the first thing, how to compare strings, objects. Now we have case conversion. There are two very straightforward methods which we can use to change the lowercase to uppercase or uppercase to lowercase. We can simply call it case conversion. Now let's say in the WriteLine method, to the first string, which is MSG1, I will call to uppercase or to upper like this. This is going to convert the entire string object into the uppercase. It will become uppercase. And to the second string, MSG1, I will call to lowercase like this. Now the string is totally converted into the lowercase. So let's run the program and check the output. Now here you can see the string are converted. The first one is in the uppercase and the second one is in the lowercase. The advantage of two upper and two lower is they can also be called at the time of reading input. Now, for example, I want to read a name in the program using the read line like this. Now, on the read line, we can call to upper directly like this. So as I enter the name in the console, the name will be converted into the uppercase and then assigned to the name variable. Now we can print out simply the name variable in the console. So let's run the program and check the output. So let's now provide a name. I will use a mix of different characters. Let's say SALAR. You can see two uppercase characters and three lowercase characters, and they will be converted into the uppercase because we are calling to uppercase. So let's press enter. Now you can see all the characters are converted into the uppercase. So that was a case conversion, and here we have two very useful methods. So let's now move on. Another very useful method is index of. And using this method, we can find a part of the string in the whole string. This method is overloaded and has several different versions with different parameters. Just have a look at the documentation and you will see index of method here with different parameters, right? There are several different versions of index of method. I am going to show you the use of the simplest one, index of with one parameter, and that parameter is of type string, and it will simply find the first occurrence of the provided string and return the index value. So let's create a string variable with the name str, and it has a value like learning C# is an interesting thing, right? And now I will call the index of method like this, and the search string is C#. The C# appears only once in this text, and our program will return the index value of the C because here our search string starts, right? So we will get the index value of the C. And that value is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And before we run the program, just deactivate the read line so that we don't need to provide something in the console. Let's run the program now. And so you see the output in the console. The index value is 9, and this is the start of the search string. And once again, you will only get the first match, the first occurrence. If you have another C# string like this, you won't get the index of this one. If you want to find all the occurrences, then you need to program it manually, right? So that was the index of method. It has several versions. You can try out some more by your own. Move on. Our next method is for controlling the input. Let's have a look at the documentation again. And here we have two very useful methods, is null or empty and is null or void space. Both the methods are used to validate user input. They return a Boolean result based on the value we provide to them. For example, is null empty. It will check if the value provided to it is null or empty, right? And the second one is for null or void space. So let's see how do we use these methods to validate user input. We can call the method directly in the if statement if we want, because the return value is a Boolean value. Both the methods are called using the string keyword, string dot is null or empty, and we are going to pass our str variable as parameter to it. Now the method will check if this string is null or empty. In our case, the str variable is not null or empty. That means the method will return a false value, and we will automatically come inside the else statement like this. So we can write a console writer here, and we'll say input accepted, and here we can write some message like invalid data. As we run the program, this statement will be in the console. So let's run the program and check the output. And so you see the output in the console, right? Input accepted because our string is not null or empty. Now we can remove the text and make this string an empty string like this. This is the empty string. Instead of empty string, you can also assign it a null value, right? So in both the cases, the is null or empty method will return a true value, and we will come inside the if statement and print this message invalid data. Before we run this program, don't forget to deactivate the index of method because our string is now a null string, right? The index of will not work on the null string. So let's run the program and check the output. And so you see the output in the console, right? Invalid data. You can also try out the other one, is null or void space by your own. So that was is null or empty method, which is used to validate user input. Let's now move on. Another very useful method is substring method. Substring method is actually used to extract the part of a string. And the method can also take several parameters. So let's consult with the documentation to learn more about this method. Now scroll down, we will find substring. Uh, here we have substring method, right? It has two different versions with two different parameters. In the first version, we provide a single start index value, and the method will start extracting the string from that value and will continue to the end of the string. And in the second version, we provide the extraction length using the two index value, the start index value of the extraction and the end index value of the extraction. So let's try out both the methods one by one. Let's create another string variable. We don't have a valid string variable. The name of the variable is car, and I put something here. For example, I have Volvo V90, V90. And now we will call the substring method with one parameter. So on the car, we are going to call the substring method. Now the first or the start index, let's say, is 0, 1, 2, 3, 4, 5, 6, 7, right? So I will start extracting from the index 7. So I will provide 7. Now the extraction will start from here and will continue to the end of the string. So this portion will be extracted from the text. So let's run the program and check the output. And so you see the output in the console, right? Volvo V90. So that was a substring method with one parameter. We can also provide another parameter. Now, let's say we want to start the extraction from the index number 7. And then we want to extract 4 or 5 characters. 1, 2, 3, 4, 5. I want to extract the name Volvo. So I will provide the value 5 here. This is the length of the extraction. Now only the word Volvo is extracted. So let's run the program and check the output. And so you see the output in the console, right? The Volvo is isolated, extracted from the string. Let's now move on. Another very important method which we use quite often is the trim method. This method removes the unnecessary white spaces from the string, and we use it quite often on user input. Before we start processing the user input, we call the trim method on it in order to remove the extra unnecessary white spaces. Now, for example, in our car string, we don't have leading or trailing white spaces, but we can create some white spaces, for example, like this, some spaces here, and some spaces here. Now, before I call the trim method, I will simply print the length of the string car.length. It will simply print the number of characters, and wide spaces are also characters. And now in another write line, I will call the trim method. And after the trim method, I will simply call the length property on it, right? To calculate the length. I will see the different value in the console. Here we see a length with the white spaces, and here we see the length without white spaces. So white spaces are totally removed as we have called the trim method. So let's run the program and check the output. And so you see the output in the console, right? With white spaces, the length of the string is 21, and without white spaces, the length of the string is 16. So that is a proof that white spaces, the trailing and leading white spaces are removed by the trim method. So trim method is a useful method, and we use it to remove the white spaces, the leading or trailing white spaces from the user input. Now, the last method I'm going to show you here is the split method. And this method is also very useful, and we use it quite often. And one thing you need to remember while using the split method is the return value is a string array. The method splits the string and returns several different substrings, several different parts of the string. And that's why the return value is a string array. This method is also overloaded and has several different versions. Let's consult with the documentation first. So here in the documentation, you can see the split method. It has several different versions with different types of parameters. So let me show you some very common use of a split method. So when we use the split method, we decide a separator. For example, the separator in this string can be the white space because all the words in the string are separated by the white space. So let me just remove the trailing and leading white space first. Right, so now we can use the white spaces as separator. So we're going to call the split method now. The return value is a string array, so we're going to capture all the return value in the string array. The name of the array is string parse, like this. Now on the card string, we are going to call the split, and the split value is a white space, right? So it's a separator. Now our program will simply split this car variable into 4 different string values, right? I is a value, have is another value, Volvo, and V90. So 4 different values will be returned by the split method, which are then saved in this string array variable. So variable string parse is an array. We can confirm its length using the length property. Sorry, length property, and the result should be 4 because it has 4 components. We can print out a component, for example, string parse the component at index 2. So 0, 1, 2. At index 2, we will find Volvo. So let's run the program and check the output. And so you see the output, right? The size of the array is 4, and at index 2, we have Volvo. So our string is now totally divided into 4 different parts. So when we use the split method, we decide a separator. Sometimes we have different separators. For example, the space is a separator. Let's say now instead of space, I just put a semicolon, or sorry, a comma here, and here I put a semicolon, right? So it's a different kind of a string which have different values, right? Here we have a space, a semicolon, and a comma. So what can we do in this case? We can gather all the separators first in a character array. We can create a character array. The name of the character array is separators. On here, we can collect all the separators. For example, space and a comma and a semicolon. Yeah, they can be a full stop, etc. Right? So these are the lists of the separators. And now we can pass this separators list to the split method like this. Now, instead of the one separator, we are actually providing a list of the separators. The output would be the same in the console. We will get 4 different parts here. So let's run the program and check the output. You won't see any difference. And so you see the output in the console, right? So we have 4 strings in the string array, and here is the string which is at index number 2. So my friends, in this lecture, we learned the most frequently used string methods. All the methods which I showed you in this lecture are useful. Practice with them, use them in your program, and consult the documentation if you want to learn more about the other methods. So now we have covered the strings in C#. We know the string representation in the memory and some useful methods. In our next lecture, we will cover character class. Character class has some very useful methods can be used on the string to extract some extra information. So I will see you in the next lecture. Thanks for watching and take care of you.
The last couple of lectures were all about string class in C#. Those were the important lectures, I must say, because string and data type represents text, and text type data is actually everywhere. So it's important to know how to tackle string in programming. So do not forget to take string lectures. Now, in connection to the string, we are going to cover character struct in this lecture. Character struct actually represents characters in C# and it has some very useful methods which we can apply on characters as well as on strings. We will cover frequently used methods from this struct, but you can read more about it on the internet or in the official documentation. Open a browser window and simply search for character struct C#. And here you have the official documentation from Microsoft. Click on it. And here you have the official documentation. It has a lot of methods and properties. And here we have some examples. So I'm going to cover some of them in this lecture so that you know how to call the methods, pass the values, get the result, and process the result further in your program. Here you can also see some of the very useful methods. For example, is digit, letters, is lower, is number, punctuation, is white space, etc. Let's try to learn some of the useful methods from the character struct. Let's create a character type variable. We will start with the character type and then move on to the string type. And I'm going to assign it a single character, for example, A, and A is an alphabet. The first method we are going to learn here is letter. And in order to call all the character structs method, we will start always with the char keyword point. And now we will call the method is letter like this, and to the method we will pass our variable c. All the method simply returns true or false, and you can process these boolean values in a program using the if statements to let the program decide. We will have a complete example of password verification at the end of this lecture. As you see, variable c contains a letter, so the output from this method should be true. Let's run the program and check the output. And so you see the output in the console, right? Now, another useful method is digit. So instead of the letter, you can also check for if the character is digit or not. And now we know the character is not a digit, so the output should be false. Let's run the program, check the output, and so you see the second output is false. Now we have a combination of is letter and digit, and the name of the method is letter or digit. This method will simply check for the both. Let's send the value here and make it a digit, and the output should be true here because the character is digit, and it will also be true if we would have alphabet here or the letter here. So let's run the program and check the output. And so you see the output in the console, the third one, right? Is upper and is lower can also be useful. Is lower and upper, simply check the case of the letter. For example, is lower, and here we have is
upper, they simply work on the letter, so we need to change the value. Let's have uppercase letter A. Now this method will simply give us a true value because the character value is uppercase letter A, and here we will get the false value. Let's run the program and check the output. And so this is the output, right? This false is coming from here and the true is from here. Another useful method can be is punctuation. So let's call it. Here we have is punctuation and just pass the character value. Here we have an alphabet. Let's change it to some punctuation value like a colon. And now the output here should be true. Let's run the program and check the output. And so you see the last one, right? The value is true from the method. Here we have 6 useful methods from the character struct. You can definitely check and investigate more methods from the documentation. We are not going to investigate any other method. We will instead try to apply these methods on the string type. Using these methods on the string, we can simply build some interesting and practical applications. Now, for example, I have a string value, a text which is a combination of upper and lowercase letters, wide spaces, punctuations, etc. So let's have a text here like the struct class is amazing, like this. I like chapter 9, 10, and 11. So here we have a text which is simply a mixture of uppercase and lowercase letters, punctuations, and wide spaces. What we know from the previous lecture is that a string is actually saved as internal array in the memory, and we have access to each and every character using its index value. And when we read out a character, the character is returned as char. For example, if I wanna extract this first letter, it is at index 0. So I will write like this: letter text of index 0. From the string, a letter is extracted which is at index 0, and the return value is always char. We know that from the previous lectures, and because of the index values, we can loop through this entire text. Now we are going to loop through this text and will extract some interesting information using these methods. So let's create, we can use for each group here a single character from the text, and outside the loop I am just getting a variable that is called count, which is 0. Now let's say I want to find out the number of uppercase letters in the string. We're going to write is upper, and we'll insert the character like this. And if this character is uppercase, we will simply increase the value of our count variable. When the loop is completed, we will simply print the value of the count in the console. So here you see the first use of the method on the string. Let's run the program and check the value of the count. And so you see the output 6. That means we have 6 uppercase letters here. Let's count them: 1, 2, 3, 4, 5, and 6, right? You want to count the white space, you will simply change it to is white space like this. Now you will get the number of white spaces. Let's run the program, check the output, and here we have number of white spaces 8, right? Now you can apply all these methods on the string, or you can have your own string for the experiment purpose. Now using these methods, we are going to create a very practical password validation program. The name of the variable now is password, and it has a password, for example, secure123, and the requirement is the length of the password. Length should be greater than 8, has digits, and has letters. And when it comes to the letters, we would say both upper and lowercase. These are our password validation parameters. We don't need the count variable. Instead of the count, we need a boolean variable is valid password, which is false from the beginning. And now we are gonna simply loop through our password text, character by character like this. And inside the loop, the first thing before we check any other parameter, we will see the length of the password, right? That should be greater than 8. So if the password length, if the length is less than or equal to 8, we are not going to check the other parameters. Our password is invalid and we will simply break the loop. But in the other case, when the password length is more than 8 characters, we will check for these parameters. And here we have 3 parameter cases: has digit, has upper, and has lower. That means we need 3 control variable here. Bool has digit, which is false from the beginning. Bool has upper, which is also false, and bool has lower, which is also false, right? Now after that, we will simply pass the characters to the methods. If character dot is digit, ch, if we find a character that is a digit, we are gonna change this value to true, has digit true, and the same way we pass the character is upper like this, ch, we are going to has upper, let's turn it to true, and the third one here is character is lower, has the character becomes true, has lower becomes true. So this is our control. If we find at least one digit, we will turn the has digit control variable to true, and the same we do here. If only a single character we find which is in uppercase, this value is true, or in lowercase, this value is true. So it will check the complete mixture. After that, we will investigate these Boolean values in order to update this final value is valid. Now the problem here is we are not using methods. Methods we are going to cover later on in our course. So these variables we actually need outside of the for loop. Like here, we need all these control variables, unfortunately. So once the loop has gone this entire string, we must have some values in our control variables. And now outside of the loop, we will simply control these variables in an if statement like this: has digit and has upper and has lower. If the true, in all of them, we would turn the is valid password to true. And in the last step, we are going to investigate is valid password. We would say if is valid password, if it's true, we would simply print a value, message, password is accepted. Otherwise, wrong password. That's it. Our password here is gonna be accepted because it has digits, lowercase, and here we have a single uppercase. So let's run the program and check the output first before we change the password value to something else. And so you see the output in the console, right? The password is accepted. Now I'm going to change the password. Let's say there is no uppercase letter in the password, right? So this condition, this one would never get the true value, and here comes the false value. So we would never come inside this if statement and turn the value to true. Let's run the program and check the output. And so you see the output in the console, right? Wrong password. Now let's say we have upper and lower case. We have uppercase and we don't have, let's say, numbers or digits. So the password should be wrong. Let's run the program. Wrong password. I think we never went inside these if statements because the length of the password is less than 8. Let's put here something else. Let's say ABC, ABC, like this. Now we would go inside the if statement and our program will investigate all these statements and the answer would be the same. The password is wrong. And so see the output in the console, right? So my friends, that was a lecture on character struct. This struct simply represents a character and it has some very useful methods. We learned some of them and we created a very practical application, password validation. Now in the next lecture or the coming lecture, we are going to discuss Unicode character coding. It's a very important concept to learn as a programmer, like how characters are coded in the digital system. I will see you in the next lecture and thanks for watching this one. In the last couple of lectures, we have been talking about characters and strings. Strings are actually characters. They are the combination of characters. We know how to create a string and character variables, manipulate the characters. But what we don't know is the reality of these characters. The reality of these characters are very interesting, and as a programmer, you need to know that reality. If you are an end user using any application or app, then you do not need to consider this reality about the characters that you see on your screen on daily basis. But as a programmer, you must know the ins and outs of the characters and their realities because you code them. You must know what are they and how they are treated by the machines. So let's dive deep into it. I will show you several on-screen diagrams to make this concept easy to understand for you. This lecture is all about Unicode. I'm not sure if you have heard the term Unicode or the term ASCII. ASCII is the old version and obsolete. Unicode is the enhanced version of ASCII, which is standard today. We will come to the point where we discuss the term Unicode during our discussion. So here comes the scenario. What if I say every character that you see on your digital screen is just a symbol? Symbol means it's just a drawing. You are surprised, right? But that is true. Every character that you see on your digital screen is just a symbol. We know and recognize the shapes of the characters. That's why our machines have mechanism to draw them for us. But when the time comes for the processing, these characters are converted to their binary codes. Let's have a demonstration of this process, and in the middle of the demonstration, we will catch Unicode. Let's say in a program we have uppercase letter P that we wanna process in the computer memory. As we send the letter P to the computer for the process, it will be converted to its binary equivalent because computers can only process binaries. Now, after the processing, letter P is changed to letter Q, which is then sent back to the computer screen. Letter Q will also have its binary in the computer CPU, and when that binary is sent back to the screen, the letter Q symbol is drawn and you simply see the letter on the screen. This entire process can also be demonstrated using the code. Let me show you the process in the code and then we will come back to this discussion. In our code, I'm going to create a character variable which holds a letter P, and now I will change the letter P to letter Q. And bring the letter in the console. Let's run the program, and in the output you won't see letter P. What you see is letter Q. And so you see the output, right? What do you see? You see letter Q. So the letter P is changed during the processing. This line of code is actually doing the magic and we will discuss it later on. Let's first finish the discussion. Now, coming back to our discussion, where do we have the involvement of the Unicode in this entire process? If you don't get it, let me tell you. Ask yourself a question. How did our computers find out the binary code of the characters? For example, the binary of the letter P is 0101 and 4 zeros. The binary of the letter Q is 1010001. So how does our computers know the uppercase letter P is always converted in 01010000, and the binary 10100010 will always display uppercase letter Q? So how do our computers do all this conversion? They do that because of the Unicode table. In the Unicode table, we have all the characters and all the symbols documented. They have their octal values, decimal numbers, and code points. So in the background, our machines or computers use Unicode table to do the conversions back and forth. Here you see a much better diagram, a complete flow. When you wanna send the letter P to the computer for the processing, our computer will first contact with the Unicode table to get the code, the decimal code of that letter. And in our case, the letter is P. The decimal of the letter P is 80, and decimal number 80 can easily be converted to its binary equivalent 01010000. And after the processing, when the letter P is converted into the letter Q, our computer will convert that binary into decimal and then once again consult with the Unicode table to get the character that represents that decimal number. In our case, the decimal of the Q is 81, which is then converted into the symbol Q. The process of getting the bytes value or the binary value is actually called encoding, and the reverse process is called decoding, where we convert the bytes value or the binary values back to the symbols. So our digital machines continuously do encoding and decoding in the background without letting you know. Unicode is a standard that assigns a unique number to every character in almost every language in the world. In addition, emojis, technical signs, and even the ancient languages have their representation in the Unicode. The main purpose of the Unicode is to provide a consistent way to represent text across all platforms and languages. Today, all the digital machines use Unicode to represent text and characters. I think now we have enough background, and I hope you guys got my point from the discussion. Let's now have a look at the structure of the Unicode table, and then we will do some experiments in the code. Open a browser window and search for Unicode table. That's it. And here I'm going to select the Wikipedia page, the list of Unicode characters. On this page, you can read more about the Unicode. I am going to scroll down to show you the Unicode table structure. In the table structure, we have a character, octal and decimal numbers of the character, and the code point. Code point is the position of a character in the table. Now, if I scroll down, you will see the Latin. Here we have the basic Latin characters, and we recognize them, most of them. For example, the space character has decimal 32, dollar has decimal 36, percentage sign has 37, and here we have the numbers. And this is even more interesting. When we write numbers in our program, they are also symbols. For example, 0 has 48, which is the decimal value. That means when you have 0 in your program, in the background, this 48 is actually converted into the binary. When we further scroll down, here we have our alphabets, English alphabets, uppercase. Uppercase alphabets start from 65 to 90, and the lowercase starts from 97 to 110, I think so, 122. So the uppercase and the lowercase letters are not same in the digital system because they have their own codes. And that's why where we do not allow automatic case conversion from lower to upper and upper to lower, our text will always show case sensitive behavior. Such as the password text is always case sensitive because the case conversion is not allowed there. However, in the username, case conversion is allowed automatically. So if you provide your username in lowercase or uppercase, there won't be any problem. But you cannot do that with the password. Password is always case sensitive. In the example code which I showed you earlier, we had a letter P with the decimal code 80. So what did I actually do? I added 1 to the 80 to get the value 81, and then I converted 81 back to the character. So we actually work with the decimal codes. If we further scroll down, you will see signs such as here we have pound sign and here we have a copyright sign, which we usually don't have on our keyboards. But using these decimal codes or even these code points, we can display these signs in our program. Let me show you some examples how do we interact with this table before we wind up this lecture. In C#, every character is Unicode by default, so we do not need any extra setup. So what we are actually performing here,
we are trying to add 1 to the ch. Ch is a character type variable with a character p. As we are trying to perform addition on a character, our compiler knows that every character has its decimal code. So before the addition, compiler will automatically get the code of that character. And in our case, the character is p and the code of the p is 80. And then the 1 is added to the 80, which results in 81. And after that, we are trying to convert this 81 back into the character using this typecasting. And that's why we see Q in the output. Let me show you another example. The decimal codes of uppercase letters start from 65. The letter A, the uppercase A has the code 65, and the last letter C has the code 90. Now, using these codes, we can print all the alphabets using a for loop. We will start our for loop from the 65 and run the loop up to 90. So we are looping through alphabet decimal values, and in the console write, we will simply type convert all the codes like this, and now we put a comma in between the alphabets. In the first round, we will have 65, and this call will simply type convert the 65 into the character. So let's run the program, and you will see all the alphabets on the screen from A to Z. And so you see the output in the console, right? All the alphabets from A to Z. Let's have a couple of examples more. I don't have pound sign on my keyboard, but I can get the sign using code. And the code is 163. Let's run the program and check the output. And here you see the pound sign in the output, right? You can also do the reverse. If you have a character, you can simply get the code. Now, for example, I want to get the code of the add sign. So I will write something like this. I will see the code of the add sign. The code of the add sign is 64. Let's see what do we get in the console. And so you see the output, right? 64, which is the decimal code of the add sign. Now, all the characters which are listed in the Unicode table can be the part of the string, because a string is just a combination of characters and each character is Unicode in C#. Even the emojis can be the part of the string. For example, we have a string text, and now here I'm going to paste a string because I don't have characters on the keyboard. So I copied these characters from the Unicode. So here we have normal characters, Swedish characters, here we have Chinese characters, and here we have a single emoji. It's interesting, right? Now the last thing before we wind up this lecture is the use of the code points. You can also pick a character from the Unicode table and use it in your code using the code point. For example, this add sign has the code point U0040. So in our code, we will write like this. We will start with the backslash and then the entire code U0040. The backslash is important, is a part of the syntax, and right after that, you will write the entire code point. Now you will see the add sign in the output. Let's run the program and check the result. And here's the add point in the output, right? So my friends, that was a detailed lecture on Unicode, and now after taking this lecture, you must have realized that this is something important for you as a programmer. Now you have better idea how the characters are coded in the digital system. When you see a string like this, you can now automatically connect it to different concepts like the memory representation and the character coding. I will recommend do some research on the Unicode and some grease in the code. I will see you in the next lecture. Thanks for watching this one. So, my dear listeners, methods. It's now time for the methods. If I am not wrong, this is our lecture number 44, and we are starting out methods from this lecture. In order to cover methods in C# together with all the variations, we need at least 8 to 10 lectures. Methods in programming are everything. Every computer program has at least one or more methods.
They are extremely useful in programming, and once you have mastered writing methods, your next journey will become easy because methods and properties are used in object-oriented programming. So from this lecture, we will start learning methods and we continue talked about methods in coming 8 to 10 lectures. This lecture is the most important one because here you will learn why do we need methods, what are methods, syntax and definition of methods, and writing methods. If you do not understand any point in this lecture, I would recommend watch it again, do some research by your own to understand that point, because the coming lecture is just a continuation of the method. So everything we are going to discuss in this lecture, you must have good understanding. You must know them well, all the points we are going to discuss in this lecture. Let's move on, and now we will learn the definition of methods. Okay, so what is a method? A method just a piece of code, a separate piece of code in your code file that performs a task and can run itself again, and again. That is the simple definition. Method is just a piece of code, a separate piece of code in a program file that can run again and again. So the first advantage of having method is that you can avoid code repetition. You can simply repeat a task again and again on different places in your code without code duplication. Methods in programming turn the sequential code into modular. Up till now, we have been coding sequential, like statement after statement, and the program execution has also been sequential from top to bottom. Once we have methods in a program file, that means our code is modular. Every method is a single module and our program execution is no longer sequential. Our program will simply jump back and forth in order to execute all the statements. Because of the modular structure in a program file, we achieve higher maintainability. The dependency between different modules and statements decreases, and because of that, we can easily maintain, update, and change our code. And now the third and the final point, what is the method? Methods in programming can make the code more flexible for the logic. Your logic in methods is more flexible and even safer. For example, in a program, you have a method that controls the input data, another method that controls the main logic, and another method that controls the output data, or maybe another method that controls the underlying logic. Right? So you have your logic distributed among different methods. If you need to upgrade or change anything, you will only put focus on that part of the code. Now we have some idea what is a method. When we code, you will get better understanding. Let's move on. A method in programming, I'm not talking about only the C#, I mean programming, can behave in 3 different ways. So in all the programming languages, a method can behave in 3 different ways. And what are those? Let's have a look. Number 1, a method that does not return a value as well as takes parameter. It's a behavior. You can have or design a method in programming in your code that does not return a value and even take any parameter. In other words, we can say a method with no return value and no parameters. Parameter-less method. The second behavior is a method that returns a value but does not take parameters. That simply means the method is designed to return a value but not for parameters, taking parameters. And the third behavior is a method that returns a value as well as takes parameters. So these are the 3 main behaviors a method can behave, and what behavior we choose, it totally depends on the program flow, program logic. You as a programmer will decide to choose a behavior. Here comes the last slide before we start coding the method. Methods definition. Methods in programming. Once again, I'm not talking about C#. I mean in every programming language consists of at least 3 parts. Method's name is a middle part. Your method will always has a name. Before the method name, we will code return value data type. We know all the types like integer, string, char, double, array, etc. So the data type of the return value should be before the method name. And after the method's name, there must be 2 small parentheses. And inside these 2 small parentheses, method can receive parameters or not. And then every method has its body, which we mark using the curly braces. This is a minimal definition. You at least need these parts in the method definition, and using this definition, we can create all the behaviors. Behavior 1, 2, and 3. That was the introduction of the method. Let's now move on and get your hand dirty. Write some code. As you can see in the code file, I've already transferred some text from the slides. Here we have the syntax, the method's definition, method's name, return type, parameters or not. And here we have three behaviors. Using this definition syntax, we will code all the behavior number 1, 2, and 3 one by one. At the end of this lecture, we will try to put everything together and develop a simple application based on methods. Now, the first behavior, a method that does not return a value as well as take parameter. Such type of methods are mostly used to display information. For example, in a program, we need a method that displays the error message. So the method name, if we start from the method name is error message. Error message is the name of the method, and right after the name, we must code to its small parentheses, and don't forget to code the body of the method. Right? This is the body of the method. Like this. Now, our method is parameterless. There is no parameter, so we don't need to code anything inside the small parentheses. And our method is also return valueless. So here we need to code a data type according to the definition that represents no value. And that data type in programming is called void. This is your first meeting with the void type. What you know is int, and you know string, you know double, you know char, you know integer array, you also know list and dictionary. You know all these different types, but void is another type in programming, and that simply means nothing. When you code a method that does not return a value, the data type should be void. Void simply means empty. You cannot code a method without the return type. As you can see, our method is complaining. So there should be or must always be a return value data type. So by using this definition rule, we have created this first behavior, a method that does not return a value as well as take parameters. What we see here is called definition. We have defined a method. What does this method do? We will always code inside the method body. Now let's say this method is of printing a message. We have a method which is fully defined. Now, what will happen if I run this program? Do we see this output in the console? You have error in your program or not? Let's check it out. So, nothing in the output. Our output is empty. Is there any error in our code? I don't think so. And here comes the twist. The twist is that methods cannot execute them automatically. They need to be called. How do we call a method? In order to call a method, method's name is used. And the method name is error message. And right after the name, you must code the parentheses, the small parentheses like this. This statement is called call. We are now calling this method, and this time our program will execute this piece of code, and you will see you have error in your program in the output. Let's run the program and check the result. And so you see the output in the console, right? That simply means our method executed by the call. In the introduction, I told you using the method, we can avoid code repetition, and method can run again and again and again. That simply means this code can be used on several places in a program file. All you need to do is just call the method. Here is another call. That means method is executed one more time. And now we have 5 different calls. That means our program will run this piece of code 5 times, and you will see this output 5 times in the console. Let's run the program and check the output. And so you see the output in the console, right? It's amazing. Methods are amazing. So if you're trying to create a method with no return value and parameters, the definition will always look like this one. You will start with the void and then name of the method. Name of the method can be different. And right after the name, you will code two small parentheses, no parameters inside the parentheses. Let's code another method of type 1 behavior. And this time, our method's name is addition. Going to add two numbers. We will start with the void because method does not return value. The name of the method is addition, two small parentheses, and then the body of the method. This method will simply add two numbers. So we need two variables. Number 1, which has a value 10, and the number 2 with the value 20. And now we are going to print the result. We can print the result directly in the console, or we can save the result in the variable like this. Number 1 plus number 2. And now we can print the result in the console. Now, once again, nothing will happen if we run this code without calling the method. This is the definition. So we must call the method. You can call the method anywhere in this code file, right? You do not need to have the method above or below the call. You can put your method anywhere. Okay, so now we are going to call this method like this, addition, and simply the parenthesis. That's it. Now our program will execute this piece of code. Let's run the program and you will see the addition result in the console. And so see the output, right? So now we have a method, a dedicated method for the addition. We will write several different methods in this entire section in all the coming videos. And I can guarantee you, after taking all the lectures on method, you're gonna be the master. We have so many concepts related to the methods in C# and we will be covering all of them. Let's now move on. The behavior number 2, a method that returns a value but does not take parameters. No parameters simply means we will not have anything inside these two small parentheses, but this time the return value should be different as compared to the first one. Let's see the definition of this second behavior. Here we have the addition. Let's say we create another method and the name of the method is multiplication. Once again, two parentheses, there is no parameters, so you don't need to code anything inside the parentheses. And now the method's body. This time in this behavior, method gonna return a value. You as a programmer decide what type of value you want your method to return. If we try to sense the return, it's a multiplication, right? It's a calculation. So the best return type can be decimal or double, right? So this method gonna return a double type data. Now inside the method, once again, we have two variables. Let's say double number 1, which has a value of 10, and double number 2, which has a value of 20. And now we are going to calculate the result, which is the multiplication. And the last one, the last line here is the important one. We want to send back this result because the method is designed to return a value. And for that, we use a reserved word return. You cannot return a value from the method without using the return keyword. So this method simply returns a result of type double because the return type is double. You cannot return any other type. For example, if I have decimal a with the value 19 and I try to return the decimal, our program will simply complain. And what does it say? It says cannot implicitly convert type decimal to double. So you must match the return value with the return type you have in the definition. Another thing to notice here is once you start coding or defining a method with the return type, our program will continue to show the error message until you write or use the return keyword. This is just a reminder so that you do not forget the return keyword. Now in the error list, you can see not all code pass return a value. That means you are not using the return keyword, and as you use the return keyword, the error disappears. Now we have a fully defined method that multiplies two numbers and returns a value. And here comes the interesting thing. How do we call such method? This method called gonna return something. That means we cannot call this method just like the previous one, the addition.
Type of mistake, multiplication. This is a normal call like the previous one. But here we have a return value. Method gonna return something. And we need to take care of this return value. So this call is not enough when the value is returned. So what we usually do, we assign the return value to a variable like this. Here is a method call that simply means our program will jump to this method, execute this method, and when the program comes back to the call position after the execution of this method, it will have a return value, and that value need to be assigned or used somewhere. And that's why an assignment is necessary. Now we can use this variable in the console to show the result to the user, or we can further involve this value in our calculation. This is how we properly call a method that returns a value. Let's run the program. You will see 200 in the output, which is a multiplication of 10 and 20. And here you see 200 in the output. Methods with the return value can also be called directly in the WriteLine or in other calculations. For example, this method returns a multiplication of 10 and 20, and we want to further add 100 to the result. So here we are gonna add 100 like this. So we are actually not adding 100 to the method. We are adding 100 to the return value. Our program does not have the sequential flow here. You remember from the introduction, our program will find a call. Call simply means jump to the definition or from the definition. When the definition is completely executed from top to bottom, our program will come back to its calling position. This time our method has a return value which is further added to the 100, and now you will see 300 in the output. Let's run the program and check the output. And so you see 300 in the output. You can also call this entire line of code. If you do not need to save the result in the result variable, you can also call it directly in the WriteLine. WriteLine is going to wait for the call. The method is called, code is executed, a value is returned, which is then added to 100. And then the final result is published by this WriteLine method. So you can also do like this if you do not need to save the result in a variable or use the result further in your VM. So my dear listeners, that was the second behavior, a method that returns the value but does not take parameters. Now the third behavior. Here we have a method with full definition, a method that returns a value as well as take parameters, one parameter or multiple parameters. Parameters are the data that you pass to the method to work with. Let's create a method, and this time our method's name is subtraction. Right after the method name, we will create two parentheses and then the method body like this. And this time we will code parameters inside the small braces. As the name suggesting, this method gonna subtract two values. It will receive two values as parameters. So we are going to give our method two parameters, for example, double value 1 and double value 2. Parameters are normal variables. They can be arrays, they can be lists, etc. We will see all the variations in coming lectures. And the last thing which is missing is the return value, and the return value is also double. The method will simply subtract the variables and return the result back to the calling position. That's it. We are saving the subtractions result in a variable, and here we are returning the result. We can also do something like this. So this can also be done. Your code become more concise. Method receives parameters. Parameters are actually data, working on the data and returning the result. Now the calling of this method is also interesting. As we know, the method returns the data. That means we need to take care of the return value. So result, and now we are going to call the method subtraction. As you see, our program is complaining something is not good. So what does it say? open the error list, and it says parameters are required because the method definitions has double. Here we have double. That simply means in order to call this method, we must pass data to these variables, and there are two values. So we must pass values like 10, 20. As this method is called, these values are copied in the same order to these variables. That means the value 10 is copied in value 1 and 20 is copied in value 2. The order of these arguments is important here, so don't forget that. At the time of calling, value 1 has 10 and value 2 has 20. And then 10 minus 20, the result is minus 10, which is then sent back to the calling position and then assigned to the variable r. Now we can print the value of the r in the console. Let's run the program and you will see minus 10 in the output. And so you see minus 10 in the output, right? You can also call the method directly in the WriteLine if you do not save the result. For example, we can call this method directly in the WriteLine and the result will be published after the call. So my friends, that was a comprehensive lecture on methods writing in C#, but we are not done with this lecture, you know that. There are many things we need to learn related to the methods and we will continue with them in our coming lectures. Now we are going to put everything together and develop a simple calculator where the main operations are performed by the methods. We will code several methods and this program gonna be interesting. I am going to remove all the code. Let's start the development of the calculator. We want our program to do multiple calculations. So everything is inside this while loop. The first thing we are going to do in the while loop is a message to the user, simple calculator, and right after that we will show different options to choose such as addition, multiplication, subtraction, and division. So here we have 4 choices or 4 operations. This piece of code can we have in a method. It is just a display, so we can create the type 1 method, no return, no parameter. So for example, outside of the loop, here we have menu method, void show menu like this, and just take all these lines and put them in the method. Now we just need to call this method where we need to print the options. After the menu, we are gonna read the user value from the console. And this time we are gonna validate the data and keep the user inside the loop until the right options value is provided. In the while loop, the statement should be like so we are controlling 2 different things here. The first thing here is the value should be of type double. We are using the try-parse method, which is safe. And I think the type double doesn't fit here because it's the many option. So type integer is fine. So if you provide something else other than the integer, this statement will return false, and we are turning that false value to true using the logical not operator just to come inside the loop. Once a value is provided and that value is also integer, this try parse will return true, and true is then turned into the false. A false from this statement simply means the value is good and acceptable. And then we have another control to the right. And here we are controlling the interval. If the value is less than 1, which is useless, or greater than 4, which is also useless, then any one of them become true. And here we have logical OR between both the controls. One true with logical OR simply means the final result is also true. And we will come inside the while loop where we will publish a error message. And here in the loop, we would say choose a value between 1 to 4. And I think these values will not work properly. We can change them to our valid interval is 1 to 4. So if the option is less than n equals 0, and if the option value is greater than or equals 5, I think this will work. So in case of invalid input, we will simply display this result, and right after that, we will ask the user to enter the choice again. Let's now run the program and check the development. We will first provide invalid data to see if the user remains stuck in the loop or not. Here we have our menu, which is coming from the method your choice. Let's say I provide ABC. Now you can see we are inside the loop and we are stuck there. Let's now provide a value which is not acceptable. For example, 10. Now once again, you can see choose a value between 1 to 2. Now I will provide a valid value, for example, 4, and it worked. As you see, we don't see the error after providing the value 4. Our main while loop, this one is simply repeating it again, and that's why you see the menu again. So once the right option is provided, we will encourage the user to insert two numbers for the calculation. So right after the loop, inner while loop, we will display a message like insert two numbers for the calculation. Right, so user will insert two numbers for the calculation, number 1 and number 2. And once again, we are using try pass for the safer input. We don't want our program to crash. And you know all these things, try pass, read line, we have covered all these things earlier in our course. And now before performing operations on the numbers, number 1 and number 2, we will check the Boolean values returned by the try pass. If true, both the values are true. That means the number is provided perfectly. Inside this if statement, we are good to perform operations, addition, subtraction, multiplication, and division. We are going to open a switch statement like this, and to the switch, we are gonna provide the options variable. Options variable is not visible here. It has become the local variable. So we need to modify our code a bit, and we'll create the options variable outside of this loop here, or we can put the options variable outside of both the loops in the initial value of 0. Now we need to remove the int keyword. So you see the options variable is now visible to the switch statement. And here we need to code 4 cases, one case for each operation, right? Four cases, and each case is for one method. For example, the case number 1 is for addition, 2 is for subtraction, and then multiplication and division. We are going to create a single method that can perform all the operations based on the sign we pass to the method. So our method here is void. We don't want our method to return a result, and the name of the method is perform calculation. And this method will simply take 3 arguments. Number 1, number 2, and string sign. Here you see the variations in the parameter. Now, if the provided sign, for example, equals plus, we will simply add number 1 plus number 2. Else, if the provided sign is minus, we will simply perform the subtraction. Else, if provided sign is multiplication, number 1 multiplied by number 2, sign equals division, we will simply perform the division. We are not controlling
the zero division here. You can put another control, another if statement to check for the zero division. I'm not going to do it here. So number 1 divided by number 2. So here you see an amazing example of method, a single method performing several operations based on these parameters or the data. Now in our switch statement, we also need a case for terminating the program, the case 5. And when the case 5 is chosen, we are going to turn this variable to false. This is our main variable which keeps the program running all the time. So running is false and break as usual. And we are going to add another option here for the termination. That's 5. Terminate application. And now we just need to call this method accordingly. So in the first case, we are going to perform the addition, perform calculation. The first argument is the user input, number 1, number 2, and the sign we will pass plus. Let's copy this piece of code. The second operation here is subtraction, the sign is minus. For third one, multiplication. And for the fourth one, we have division. Here we have the call accordingly, right? Call. So when the case 1 is chosen, case 1 is for the addition. Addition sign is passed with the numbers. In the second case, which is for subtraction, the subtraction sign is passed, and so on. My friends, you see a program which is based on methods. Now you can see we have more flexibility in our application. Let's now run the program and check all the options. So here we go. Let's start with the addition. 1, enter number 1, for example, 10, 20, and here you see the result. Here comes the menu again. Now number 2, insert 2 numbers for the calculation. Let's say 20 and 5. Here you see the 15. Enter the choice once again. Now we are going to insert 3, multiplication, 10, 10, and here is the result 100. And now the fourth choice is division. Let's say 100 divided by 5, and here is the 20. And now we are going to terminate the application. 5, and option 5 is not working because we added this option later in our program. So all we need to do is just increase the range from 5 to 6. Now the option 5 will also work. So my friends, that was a detailed, comprehensive, and long lectures on methods in C#. I promise to you the coming lectures on the methods won't be so lengthy and overwhelming. That was an important one with the methods definition and behavior, and we coded a complete calculator application. It's now time to wind up this lecture. In the next lecture, you will learn the variables life cycle inside the methods. I will see you there. Thanks for watching.
So we are in the methods section of this course, and the last lecture was the very first lecture on methods. That lecture was very detailed and we learned to code methods in C#. Let's move on and talk more about methods. Like I told you in the previous lecture, we would need 8 to 10 lectures to cover methods in C#. In this lecture, we will try to understand variables scope in the method. So let's move on. Here we have a code we wrote in the previous lecture. Just remove the entire code. And in methods in C#, our topic is variables scope. Variables scope is a common and important term in programming. We discussed this term in relation to the methods and classes. So as we are learning methods, we need to cover and understand this term. Variable scope is all about 2 things. Number 1, availability, and number 2 is life cycle. That means when we talk about variable scope, we discuss its availability and the life cycle. We have a method that returns the length of the string. The name of the method is length of the text, and it will simply take a string variable s and return the s of length. That's it. Very simple method. You can use it to get the length of the string. Now, in order to use this method or call this method in our application, we are going to create a string variable text. Let's put some text here. Hello, we are learning methods in C#. Now we want to get the length of this string, and here we have a method for that. So in the WriteLine, we can call length of the text method and can pass our string object to the method. As we run the program, you will see the length of this string object, but we are not going to run this application now. Now, the fourth point, availability. Availability simply means if the variables of a method are available outside of the method or not. Variables of a method, that means the variables we create inside a method are not available outside of the method. All the variables which are created inside the method are always local. So availability for the variables of the method is always local. Now, for example, this parameter is a variable of this method, and this variable s is accessible inside the method but inaccessible outside of the method. Here, outside of the method, we cannot use the method s. As you can see, the variable is unknown outside of the method. In addition to the parameters, if we create, for example, some other variables in the method, let's say a variable that saves the length first and then use in the return statement. Now, this len, length variable, is also local because it is created inside the method and cannot be used outside. The variable is unknown outside of the method. As you can see, the error list, the name length does not exist in the current context. See, that was the first thing, availability. Now we know all the parameters and the variables created inside the method are local. The second point here is life cycle, and it's also important to understand. You know one thing from the previous lecture, and that thing is, in order to execute a method, we must call it. Without making a call to the method, this piece of code will never be executed. And once the method call is over, that means you call the method is executed, and the control goes back to the calling position. So once this entire cycle is over, this method is simply removed from the memory. And so does the variables. That simply means the variables, these local variables, are only created when the method is called. And when the method is fully executed and it's now time to return control back to the calling position, all these local variables are destroyed in the memory. The life cycle of all the variables inside the method is very short. They only live under the execution of the method. When the method is finished, all the local variables are destroyed. They are simply removed from the memory. So my friends, that was an important concept related to the methods. And now we know how to define the term scope, variables scope in programming. It's now time to wind up this lecture, and in the next lecture, we will look closer to the return keyword. Return keyword is a special keyword and you know what it does, but how to use it properly in a method we will discuss in the next lecture. I will see you there. Thanks for watching this one. We are learning methods in C#, and the last lecture was all about variables scope, and this lecture is about a return keyword. You know one role of the return keyword. Return simply returns a value from the method to the calling position. So the main role of the return keyword is it returns a value to the calling position, but it has another role or another functionality. And what is that functionality here? See, return terminates the execution of the method. As the return statement executes inside the method execution is totally terminated. And that simply means the control is returned back to the calling position. Let's say in a program, we have a method that finds out if the provided number is even or not. And the method returns a Boolean value. True means even and false mean odd. So here is the definition of the method. The return value is bool, and the name of the method is find
even number. It will simply take a number as parameter like this. Inside a method, we need a boolean variable to capture the result, which is false from the beginning. And if the number modulus 2 equals 0, that simply means the number is even, and we are going to assign the value true to the result variable. And finally, we are going to return the result using the return statement. Now we can call this method directly in the WriteLine because the method has a return value, find even number, and we are going to pass the number 10. Let's run the program and you will see true in the output. Hence we see true in the output, right? Because the number is even. Now we are going to provide odd number. Let's say number 5. In this case, this if statement won't become true and we will never come inside the if statement. So the value of the result will remain false. So let's run the program and check the output. And so say false in the console. So that was the first and the main use of the return keyword. It returns a value. Now return terminates the execution of the method. This feature of the return statement is very interesting, and by utilizing it properly, you can code even more sophisticated methods. For example, we can design and code methods with multiple return statements. Let me first show you the execution's termination. So after this return statement, I am going to add a WriteLine statement. And here we write, I did not run. As you can also notice, our IDE has lightened the color. It's a signal from the program that this line of code will never run because the method execution is terminated here. Right after the execution of the return statement, the control is sent back to the calling position. And if I, let's just suppose, call the return statement in the beginning of the method like this, now you see all the code after the return statement is just disabled. Our program will never come down and run these statements. So that was a simple demonstration of execution's termination. In the GUI programming, we sometimes use return statements only to stop the execution of the event method. So as you learn the advanced programming, you will see this usage. Now, using this behavior, we can code methods with multiple return statements. Such as in this method, we actually do not need this result variable. We can simply use multiple return statements. For example, let me just remove the variable, and when the number is even, we are simply gonna return the true value. Otherwise, we are gonna return the false. Here you see multiple return statements and only one will be executed at a time. When this one is executed, the method's execution is also terminated. And that simply means our program will never go down to the second return statement. And when the provided number is an odd number, we will never come inside this if block, and our program will simply run this last return statement. Let's have another example of multiple return statements. It's fine. We are going to code a method that returns a string value. The method name is compare string, and it simply takes two string parameters, string text1 and string text2. Like this. This method will simply compare both the string values and return the lengthy string. So our logic should be like if text1.length is greater than text2.length, that simply means text1 is lengthy or have more characters. So we are gonna return the text1. Else if text2 but length is greater than text1 of length, that means the second text is lengthy, we are going to return the second text. And there can be the case where both the texts are the same. So in this case, we are going to return length is equal. When we work with the multiple return statements, then one return statement should be outside of the parenthesis because the method cannot see if you are using the return statement or not. And in this case, our program will simply show a compile time error. For example, if I deactivate this return statement, which is outside of the if block, as you see, our program is complaining and the error says we are not returning a value. Right? So one return statement should be outside of the block. Here you also see I have this return statement outside of the if block. To check this method, we need two string variables. Let's create them. String str1 has a value hello and string str2 has a value hello and now we can call the method in WriteLine, complete string, and can send both the variables str1 and str2. str2 is longer than the str1, that means this statement will become true and the text number 2 is returned back to the calling position. Let's run the program and you will see the output in the console. And so it's the output, right? Hello. Now we will make first string longer than the second one. Now you will see this one in the output. Let's run the program and so receive the output in the console. And the last option here is if both the strings have the same length. And now you will see this in the output. Length is equal. Here I have type of message equal. And so you see the output, right? Length is equal. So my friends, that was a closer look on return statement, and now we know how to use it properly in the methods. In the next lecture, we will talk about methods calling methods, which is a very normal and common phenomenon. I will see you here. Thanks for watching this one. We are learning methods. The last lecture was all about return keyword. We looked closer to the keyword and we now know how to code methods with multiple return statements. And like I told you at the end of the previous lecture, we would talk about methods calling methods in this lecture. So let's move on. Here we have a code we wrote in the previous lecture. Let's just delete the code. Our topic is methods in C# and we are going to cover methods calling methods. Method calling methods is a very common way for breaking down complex logics into small, manageable, and reusable components. Let's learn how do we program like that. Let's suppose in a program we want to perform two operations, addition and subtraction. But there are two requirements. Number should be in a range from 1 to 200, and the second requirement is operations are only performed on the even numbers within that range. So this is our program scenario. We will first code this entire scenario without methods, and after that we will implement method calling methods approach. So in a program we have a number with a value 102 and we have operation sign in a variable. Let's just say the operation sign is addition. Before we perform addition or subtraction, we will check for the range. So number should be greater than or equals 1 and number must be less than and equals 200. So that was the first requirement, and if this requirement is fulfilled, we are going to check for the even number. So if the number is also even, we will check for the operation. If the operation sign equals plus, we are simply going to perform addition, and in the addition we will simply add m to the number. In the second case, let's say if the operation sign is subtraction, we will subtract 10 from the number. We coded this scenario without using the methods. Number is 102, it falls in the range, and it's also a even number. As the sign is plus, that means our program will perform addition operation. Well, let's run the program and you will see 122 in the output. And say the output, right? 112. As we change the sign from addition to subtraction, our program will do accordingly and perform the subtraction operation. Let's run the program and check the output, and so you see 92 in the output, right? If we provide any other number outside of the range, we will never come inside the first if statement. On the other hand, when the number is in the range, however, the type of the number is odd, we will never come inside this second if statement and no operation will be performed. Now we are going to transform this program, and this time methods will perform all the operations. As you can see, this logic has connections. When we write methods to do this thing, they will also have the same connection. Connection means methods calling methods. This simple program can be divided into three methods. A method that performs the calculation or the operation, a method for the even number check, and another method for the range check. Let's now see how do we code this same program based on the methods. Our first method is the main method that will perform operations like addition and subtraction. So we can call this method void perform operation. This method will take a number as a parameter in order to perform operation on it and the operation sign. Before we further program this method and apply operations on this number, we must check for the interval. And for that, we will write another method, and this time the method will return a Boolean value. The name of the method is check interval. It will take number as argument. It will return true if the number is greater than and equals 1, as well as numbers less than equals 200. Right? This is the logic. Now, in our main method perform operation, as we receive the number, we will pass the number to the check interval method to find out if the number is in the range or not. The method returns a Boolean value. That simply means we can call this method inside the if statement, and we are going to pass the number parameter. If the provided number is in range, that simply means a true is returned, and we will come inside this if statement. Here we will check the type of the number. Is the number is even and odd? And for that, we write another method. The definition of the method is same. It will return a Boolean value. Check for even. It also takes number as parameter and will return a true value if the number is even. Number modulus 2 equals 0. And once again, inside this if statement, we will send the number further to the method to check its type. If the true is returned, that simply means the number is even. And now it's time to perform operation. We can simply copy this code, paste it here like this, and our variable here is operation sign. Now you see an interesting methods-based solution. And what you also see here is methods are actually calling other methods. Let's now remove the first version of the program. And to check this entire program in the console, we just need to call this method perform operation. Let's call the method perform operation. To the method, we will pass the number variable and the operation sign. The execution of this program is very interesting. Our program will first jump from here to this definition, and inside this definition, our program will find another call check interval. Our program will jump from here to this method, execute this method. We come back to the calling position, we'll come inside, and here we have another call. That means another jump. Our program will jump from here to this method, execute this method, and we come back to the calling position. So let's now run the program and check the output. This time our number is even and it's also in the range, and the operation is subtraction. So you will see some output in the console. As you see the result, right? It's the right result, 92. Now we are going to change the sign to addition. Let's run the program, and I will see 112, and here you see 112 in the output. Let's now pass an odd number. For example, 103. Nothing will happen, no operation will be performed, because this method check for even will simply return a false value. Let's run the program.
and you won't see anything in the output. So you see nothing in the output, right? So my friends, that was a demonstration how do we program like where methods call other methods. When we code like this, we simply divide our complex logic into reusable and manageable code chunks. So that was all about methods calling methods. In the next lecture, we will discuss and try to learn something very important. The topic of the next lecture is value versus reference parameters. I will see you there. Thanks for watching this one. We are in the methods section of the course, and the last lecture was all about methods calling methods. We learned to write programs where a method can make call to other methods. Using this approach, we can divide a complex logic into different reusable blocks. Now, in this lecture, we are going to talk about value types versus reference types. This is a very important concept in programming. You must know the difference between value types and reference types. We will start this lecture by learning the difference between the value and the reference types, and then we will learn how these two types behave when they are used as parameters in the methods. Let's move on and try to learn the difference between the value and the reference types. We will take help from several on-screen images. So here comes the first image. Data types in programming are divided into two types. We call them value type and reference type. In the value type, we have types like integer, double, bool, date and time, and struct. You know most of them, right? Struct is not a part of this course, but struct is also a value type. The second category is reference type. In the reference type, we have different types like class, array, string, list, dictionary, etc. Except class, you know all of them. We have worked with array, string, list, dictionary, etc. Classes are used in object-oriented programming, and for that we have the second part of this course where we will learn to code object-oriented. So here we have two different types. Our types or data types are divided into two categories. Now the question is why value type is called value type and reference type is called reference type. Here comes the answer. Try to read and understand the text on which arrows are pointing on. Value types are called value types because they store data directly in variables. Right? So data is stored directly in the variables. There is no other memory reference. Whereas in the reference type, data is not stored directly in the variables. Data is stored or saved somewhere else, and the variable will only have the memory address of that location. This is the core difference between value types and reference types. It's all about how the data is being stored by the variables. I have further simplified this concept. Let's now study these two diagrams. Diagram to the left is for value type. In the diagram, you can see how an integer variable is saved in the memory. Data is saved together with the variable. For example, at memory location 0x200, we have our variable with data. The second diagram to the right shows the memory representation of reference type. We have an array with three components 1, 2, 3. These components are saved somewhere in the heap memory at location 0x100. Whereas the array variable number is not assigned those values directly in the memory. Array number variable is actually assigned the memory location of the data, which is 0x100. C#.NET system uses two different types of memories, stack and heap. Stack memory is used to store variables and value types data, whereas heap is only for reference types data. So if you have reference types in your program, the data will always be stored in the heap memory. I think you guys got my point. I have tried to simplify it as much I could. If you still didn't get it, I would suggest just Google it and read some more about it on the internet. Now we need to find the answer why value types and reference types are important when we are working with methods in C#. And here comes the answer. When a value type is passed to the method, a copy of the value is passed. A copy of the data is passed to the method or the function. Whereas when a reference type is passed to the method, a copy of reference memory address is passed to the method, not the data. This is an important distinction you need to know. When the value type is passed, a copy of the data is passed, and when the reference type is passed, a copy of the memory address is passed. If you are not aware of this behavior in programming, or especially when you're working with methods or classes, you can have some real issues, especially when data manipulation is required. Now you have enough background, and it's now time to experience everything practically. We will experiment with the both value types and reference types and try to pass them to the method. And after that, we will learn how to force a value type to behave like a reference type. This is the key point of this lecture, and this is what I want you to learn from this lecture. Send a value type as a reference type. Let's move on and jump into the code. Let's change the topic first. We are talking about value types versus reference types. We are going to start with the value type. In a program, we have three variables. Let's call them A, the value 10, B with the value 20, and C with the value 30. Integer falls in the value type category, we know that. Before we send these values to the method for the manipulation, let's first print them out in the console. Now we will write a method that simply adds 5 to the values, each of them. The method name here is change values. It will take 3 parameters of type integer. Let's call them int AA, int BB, and int CC. Now each value is get increased by 5. Now we will do an interesting thing. Here we are printing out our values, and right after that we will call the method change values like this, and to the method, okay, the method is misspelled CH, and to the method we are going to pass all the variables in the same sequence A, B, and C. And after the method call, the method is simply changing the values. We will try to print our values once again. We can also put a string here to make our output more interactive. For example, after change, and here we have before change. Before we run this program, let's just try to guess the output. This statement will simply print something like 10, 20, and 30. And then we have a method call, and this method is trying to add 5 to the values. After the method call, we are trying to print our values again. So what would be the values? If you guess the output, the right output, you got the point. So what would be the values? 10, 20, or 30, or 15, 25, or 35. So what is your guess? If your guess is 10, 20, 30, then you are right. But if you are guessing 15, 25, and 35, you are wrong. Let's first run the program and check the output. We need some confirmation. And here you see the output in the console before and after. You can see the values are not changed. They are still the same, even though we send them to the method for the increment. That is because of the value type. The parameter we are passing to the method is of type value. Let's now try to find the answer why this thing is happening. What did we said in our last slide? We said when a value type is passed to the method, then a copy of a value or the data is actually passed. Here you see an example that represents our program. In the diagram, you can see we have 3 variables which are saved somewhere in the stack memory. All the variables have their own location in the memory. For example, 0x100, 0x101, 0x102. But when the method is called, our program won't send the actual memory location of our variables. It will instead send a copy of the data to the method's variable AA, BB, and CC. Then our method made increment to the variables, and that increment won't affect our original variables or original values because there is no connection in between. The method is working on its own values or own local variables, and the variables have their own location in the memory. So that was a simple and clear demonstration of value type parameters. we can fix this issue. We can make the value types to behave like the reference type. And we will see that at the end of this lecture. Now we need to investigate the reference type. We will do the same, create a reference type, print its values, and then send the reference type to the method for the manipulation, and then print the values again. So array is a reference type. Create an array with just 3 values, 1, 2, and 3. Now we are gonna print the values. Now we are going to create a method that manipulates the values. Void change array values. It will receive an array x parameter like this. A for loop that simply loop through the array. Now we are going to update all the values by using the multiple of 10, number of I multiply by 10. So 1 become 10, 2 become 20, and 3 become 30. And now we will simply call this method. Like this, and send that array to the method. And after the call, we are going to print the values again. Here we have before call, and here we have values after call. We are doing exactly the same as we did here with the value type. Here you will see the difference. Before the call, you will see the values in the console 1, 2, 3, and after the call, you will see the values are actually updated. You will see 10, 20, and 30. Let's first run the program, get the confirmation, and then they will discuss more about it. And so see the output, right? Confirmation before the call 1, 2, 3, after call 10, 20, and 30. You might know the reason. What did we say in the last slide? We said when a reference type is passed to the method, a copy of the reference, a copy of the memory address of the data is passed. In the diagram, you can see when you're passing the number array to the method, the actual heap's memory location where the data is located is passed to the method. And that's why the values are changed, because the method is also working with the same memory location, the original one.
Now you have seen and experienced everything I told you in this lecture. Let's now come to the final point, which is the actual point I wanted to teach you in this lecture. But to cover that point, we needed some background. That's why we talked about value types and reference types. The point is, how can we make value types behave like reference types? That means instead of sending a copy of the data, we want to send the reference of the data or the location of the data in the memory, so that the changes made by the method affect the original variables. So what we actually do to achieve this goal? In C#, we have ref keyword. Ref means reference keyword, which we use in the definition of the method as well as at the calling position. Let's see how do we do that. Before the data type, we are going to add the keyword ref like this. Now we have modified the definition of the method. These variables, parameter variables, won't receive the data. They can now only receive the memory reference where the data is located. When we call the method, here is a calling. We will also put the reference keyword before the variables. That simply means do not send a copy of the data, send reference. Now our value type will behave just like the reference type, and this time you will see this output 15, 25, and 35. Let's run the program and check the result. And so this is the output in the console. Values in our original variables are now changed by the method. That was the point we wanted to cover in this lecture from the beginning, and now we have covered that point. We know now how to code a value type to behave like a reference type. Now here comes a question. Why do we do that? There should be a reason, right?
The answer here is that a method can change multiple values, however, can return only a single value. For example, if we only had a single value and we wanted a method to change that value, we could have figured out a method that would return an updated value. Let me show you the example and I want you to hang along. I know the lecture has become lengthy, but things we are talking about are important for you to know. So for example, we had only a single value like this. We simply have coded like that. Send the value to the method gonna update the value or modify the value and return the modified value back to the calling position where you need that value. But how can we use this method to modify and return multiple values? For example, value B and value A, and the method is also receiving value PB and value CC. So if we updated these values, let's say in the method like this, all the values are being updated in the method, but we can only return a single value. This is a problem that we can resolve using the reference. No return is required. You can code a reference method that simply works with the original data. So my friends, that was an interesting, lengthy as well as important lecture of this course. We covered important terms in this lecture, value type and reference type. And you must have realized one thing here is that methods in C# cannot be covered in a single lecture. It's actually a topic that involves many other things. I think this is our fourth lecture on methods and there are more lectures to come. We need to cover the out keyword, in keyword, params keyword, expression body methods, methods in top level and no top level program files, the use of static keyword and local methods. All you need to do is just fasten your seatbelt and hang with me. I will teach you everything about the methods. It's now time to wind up this lecture. In the next lecture, we will talk about the out keyword. Here, we talked about the ref keyword, reference keyword. In the next lecture, we will learn the out keyword. I will see you there. Thanks for watching. So we are in the methods section of the course. In the last lecture, we talked about value types and reference types. We wrote several examples and learned the use of the reference keyword. This is a code from the last lecture. Now we don't need it anymore. So I'm going to delete that code. And the topic we are going to cover in this lecture is out keyword. The out keyword is another useful keyword which can be used in the methods together with the parameters. You have already seen a usage of out keyword in the try-parse method, but this time you are going to learn another use of this keyword. The out and reference, both the keywords are almost the same. Not exactly same, almost the same. There is a slight difference which we are going to learn in this lecture. I am going to write an example where we have two numbers. Let's say number 10. Number 2 is number 20. Let's call it number 1. And two operation variables. Addition, which is 0, and subtraction, which is also 0. Now, using a method, I want to calculate the addition and subtraction of these two numbers. Our method is gonna initialize these two operation variables. And as you know from the previous lecture, double is a value type. So we must send the reference of addition and subtraction if we want the method to initialize our original variables. If we do not send the reference, the method will work on its own variables, local variables. So let's create a method and call it do operations ref. It will take 4 parameters, number 1, number 2, and reference double addition and reference double subtraction, right? So addition and subtraction are sent as reference. And now in the addition, we are going to add number 1 with number 2. And in the subtraction, we are going to subtract the values. And now we are going to call the method right here, do operations Z, and we'll pass the parameters. Number 1, number 2, ref, addition, ref, subtraction. Print addition and subtraction in the console to show the result. So our method is performing both the operation addition and subtraction. And I think here the variable name is subtract, only the sub. The parameters add and sub are passed as reference. That means they are pointing to the same memory location. So this method will simply initialize our original variables. Let's run the program and get the confirmation. So see the output, right? Nothing is strange in the output. Everything is as we expected. So that was just a repetition. We know this stuff from the previous lecture. Now the out keyword. The out keyword is almost same as the reference, but will guarantee the data return or the initialization of out parameters. Let me give you the example so that you got my point. We are going to write another method, and this time the name of the method is do operations out, like this. It will also have 4 parameters. Number 1, double, number 2. Now instead of ref, this time we are going to use out, double, add, and out, double, subtract. Now as you will notice that our program is complaining about something. Let's consult with the error list window. What does it say? It says add parameter must be initialized or assign a value before the method finishes. And the same is here. Subparameter must be assigned to before control leaves the method. This is a guarantee. We cannot leave this method without assigning a value to the add out parameter and sub out parameter. So that is the main difference between out and ref. Ref do not guarantee the return or the updation of the ref parameters, whereas out simply guarantee for that. So we must assign values to our out, add, and sub parameter like that. Now you can see the error is gone. Now we can call the method do operations out. We can utilize this code do operations out, and instead of ref, you're going to use the keyword out and out. You won't see any difference in the output, but this time the output is guaranteed. There must be something. Now in this case, let's say if I deactivate both the lines, we could still call the method do operations ref. Our program will work, but we won't get the expected values. So my friends, that was out keyword. Out and ref are almost the same, but if you want guarantee that the out parameters must initialize themselves inside the method, then you will go for the out keyword instead for the ref, right? So my friends, that was a lecture on out keyword, and we learned to use it properly. In the next lecture, we will study another keyword which is called in. I-N. I will see you there. Thanks for watching this one. In the last lecture, we learned the use of the out keyword. And in this lecture, just like I told you at the end of the last lecture, we would cover another keyword, very interesting keyword, which is called in. In keyword is all about read-only parameters. Sometimes we are more cautious about our data. We don't want our data to be modified or changed because of the nature. Data can be sensitive, for example, user ID and password, or simply the user input that we do not want to modify. So in this case, where we do not want our data to be modified by any module, we can use in keyword. Let's have an example on it. We will write a method which prints greeting message to the user. User provides first and last name, and method prints the greeting message to the user. In a program, we are going to need a variable fname, console.readLine, and another variable last name, console.readLine. Print a message to the user, console write first name, in the last name. Now we are going to pass both the names to the method, and method will return a greeting. String send greeting and string f name first name, string last name, like this. And using the return, our method will simply return a greeting. Very simple method that takes a name and returns a greeting. Now in this method, parameters are user input. So they must be read-only so that they can't be modified. Let's say in our method, we by mistake somehow reset our variables. Now the entire purpose of this method is destroyed. We will never get a proper greeting. Let's call this method here directly in the WriteLine method, because the return value is string, and send the parameter first name, last name. Let's now run the program and check the output. Here comes the cancel window, and I will provide my name. Let's say Salar Oscar. And here comes the greeting. Hello, nothing. You are welcome to the system. So to avoid this thing and save the data so that it can't be modified, we have in keyword which we can use in our parameter. Now here, before the data type, I will simply write the in and in. Now you see, as we turn our parameters to read only, the system is complaining. What does it say? You cannot assign to variable f because it is read only. And the same is with the other variable. Variable L cannot be assigned a new value because it is read only. Now we have no other option just to remove its assignment code. This is how we use the in keyword with methods parameters so that our data cannot be modified. Let's now run the program and check the output now. Let's provide the name, Sala Askar, and here see a proper greeting message. Hello, Sala Askar, you are welcome to the system. So we have many keywords which we can use with the methods. It's interesting. Now we only have one keyword left to cover, and that keyword is params. In the next lecture, we will learn to use that keyword. I will see you there. Thanks for watching this one. So my friends, we are in the methods section. We are trying to cover methods and the other important things related to the methods. In the last lecture, we talked about the use of the keyword in the methods parameter. And before that, we learned the use of the keyword ref and out. It's now time for the last and important keyword which can also be used with the parameters. And that keyword is params. So let's remove the code we wrote in the previous lecture. And now the topic is params keyword. Params simply means variable number of parameters. It's interesting. Using params, we can code methods which can receive variable numbers of parameters. In other words, methods do not have fixed parameters length. Let us see how do we code such method, and then we will talk more about it. We are going to write a method which can add numbers. How many numbers? We are not sure. Method is capable of adding different amount of numbers. Let's start with the void. The name of the method is add numbers, like this. And now the parameter, params integer numbers. Param is for variable numbers of parameters. We don't know the exact amount of the parameters, and that's why params automatically collect all the parameters in an array, and it sounds logical. Now we can figure out further this method. This method gonna generate the sum of all the numbers. So we have an variable to hold the sum. Let's now run the for each loop like this. And finally, we are going to publish the result. Sum. That's it. Now, this method, like I said, is capable of receiving variable number of arguments or the parameters. Calling to this method is interesting, and that will clear all the points. So we are going to call this method. In the first call, we do not send any parameter and the program won't complain. our program will simply set the length of the number variable to 0. Now, in the second call, we are going to pass only one parameter. In the third call, we are going to pass 2 parameters. In the fourth call, let's say 1, 2, 3, 4, 5. In another call, let's say with 10 parameters. Now you must have got the point when we say a variable number of parameters, and here you see the example. The number of parameters to the method are variable, and that's why method is collecting parameters in an array. All the calls are legitimate, and you will see some output or the right output in the console. So let's run the program and check the result. And this is the output, right? The sum of different calls. That was the params keyword. Let's now talk about some important things you need to be careful about while using params. The first thing here is when you combine params with other normal parameters, then the params parameter should always be at the end of the parameter list. What does it mean? Let me show you. Let's say we have a method log. It has a normal parameter info and a param parameter of type string message. This is what I mean. When you combine params with normal parameters, param should always be at the end of the parameter list. This is the parameter list and param is at the end of the list. You cannot put params before the normal parameter. There is a reason and we will look into that in a couple of seconds. So info is a normal variable, whereas message can have several components. So in our for loop, for each loop, our collection is message. We would say info plus space concatenation and msj. You must change the loop variable. And of course, the data type. Now, the calling of this method is very interesting. The first parameter should always be for the info, and the rest of the parameters are automatically collected by the params array. Now, here you see the calling. Let's say the first parameter is information. The second parameter is start. The third parameter is processing. The fourth parameter is end. And the fifth parameter is error. And the name of the method is misspelled. This is log. Now you can guess why params should be at the end of the parameter list. If we had params in the beginning, params will simply collect all of them in its array. And we don't want like that. This first parameter is for the info and these parameters are for the params. And I think if we have params before and the normal parameter after, our compiler complains about it. Let's say we put a normal parameter, string inf. You see our compiler is complaining. A normal parameter cannot be after the params. What does it say? Here you can see params parameter must be the last parameter in the parameter list. So this cannot be allowed. So that was the first thing you need to be careful about while working with the params. Another thing here is you cannot have more than one params in the parameter list. That means you cannot code another params parameter, right? Let's now run the program and check the output. And so you see a beautiful output. All the params parameters: start, processing, end, and error. Now, one last comment on the params parameter before we wind up this lecture. And that comment is you cannot use out and ref keyword on the params, right? This is simply not allowed. So my friends, that was the params parameter we covered in this lecture. Params give you the option of coding methods with variable number of parameters. It's now time to wind up this lecture, and in the next lecture, you will learn the use of the optional parameters. I will see you there. Thanks for watching this one. In the last lecture, we talked about params parameter, and in this lecture, you are gonna learn optional parameters in the methods definition. So let's change the topic of this lecture. We are going to talk about optional parameters, and optional literally means optionals. Optional is a free to use parameter. If you want to use it. Otherwise, it does not do any harm. Let's have a quick example of optional parameters. We are going to write a method.
The method's name is enter data log, like this. The first parameter is the message, and the second parameter is about the owner, like who is creating or logging the message. Inside the method, we are going to print both the variables or the parameters. There is nothing special with this method. It is just an ordinary method. To call this method, we just need to pass two parameters. Let's say the first parameter is I do not find the user data, and the second parameter administrator. And once again, nothing special with this method call. I do not find the user data becomes a message, and administrator is actually the owner. Now let's say we wanna make this owner part of this method optional. That simply means if someone wanna provide his name, can do that. Otherwise, leave the owner part, and the owner part will automatically utilize an optional value. And to do so, we assign an optional value to the parameter. Let's say the optional value is system user. Now you see an optional value is assigned to the parameter inside the method's definition. So whenever you leave the owner part in the method calling, this string will automatically be used. But when you explicitly provide owner name, your provided value will be used inside the method. So in this calling, administrator will be used in the output. Let's now have another call with only the message parameters. Enter the log, like this. I do not find the payroll data. Now you can see only the message parameter is passed, and for the owner, our method will automatically use this optional parameter. Let's now run the program and check the output. So you see in the output, right, the result of both the calls. In the first call, the owner is administrator as we provided this argument, whereas in the second call, the owner is system user, and system user is the optional parameter, right? So my friends, that was all about optional parameters. It can be handy and useful in some situations. Now, in the next lecture, we are going to discuss C Sharp's console application templates. C Sharp has two different console templates. The one is called top level statements template, which we have been using throughout this course. And the second one is the traditional C Sharp console template. The lecture is very important, and after that lecture, we will be using traditional C Sharp console template. The question is, why do we need to understand both the templates? The answer to that question is methods behave differently in both the templates. Do not skip the next lecture. I will see you there. Thanks for watching this one. Like I told you at the end of the previous lecture, we would talk about C Sharp's console templates in this lecture. Let's move on and learn another very important concept of the language C Sharp. Here is the code we wrote in the previous lecture. Remove the code and change the topic. The console application in C Sharp can be created using two different templates. The one is called top level statements, and the second one is classic console application template. So we can create a console application either with the top level statements or classic console application. Both the templates are for console application, but there are some important differences between them which we need to understand. And like I told you in the last lecture, after this lecture, we would be using classic console application template. Before we start discussing the differences between both the templates, we need to open this classic console application project. The same create new project wizard is used to create any of these projects. You might have not noticed when we create console application, there comes a checkbox asking about do not use top level statements. If you check that checkbox, you will automatically get classic console application. Let's now add another project, classic console application project. In our solution, we are going to right click. Now click add and new project. We will select the console application, click next, the name of the project, let's say classic app, Now, next, and here comes the option. Do not use top level statements. Top level statements is a template. It's the name of the template which we have been using throughout this course. So when you want to create the classic console application, you will check this checkbox. I don't want to use top level statements. Let's create the application, and I will see the classic traditional C# console application template. Here comes a beautiful template with some mandatory line of codes. These line of codes are absolute necessary in order to make this template work. Whereas in the top level statements, as you can see, it's just an empty file, just like a JavaScript file, the Python file. You do not have mandatory code like we have in the traditional console application. The interesting thing is there is something hidden in the top level statements template behind the scene which we cannot see directly. In top level statements template, we start writing the code without considering these lines, these important lines. But what happens behind the scene? For example, we write a WriteLine method with the text hello. As we run this program is converted into another structure behind the scene. And that structure is almost the same as you see here in this classic console application. The program class is automatically generated by the compiler and the main method is placed inside the program class. So this is what happens as we run this top level statements template. This WriteLine will automatically be placed inside the main method and main method belongs to the program class. So conceptually this file as we run would look like as you see on your screen right now. A program class, static main method, and inside the method you have your code. So program class and the main method, both of them are absolute necessary for a program to work. The main method is a very important method. It is also called entry point of the application. That means our operating system like Windows start communicating with our code through this method. Using the Visual Studio Developer tool and the IL Dissembler, you can even study the assembly code of your top level statements. Without going into the details, how do we use disassembler, I am going to show you the assembly data of this file where you can easily find out the program class and the main method. Now you see the assembly of our program file. You can easily spot program. This is our program.cs class, and inside the class you see the main method. Let me just double click on the main method. Now in the main method we only have a hello word string text and the system.console WriteLine method. Now we get the confirmation. Program will automatically create a program class and the main method inside the program class. Our code is gathered inside the main method, right? So that was just for the confirmation. Let's now close the developer tool. So this template, top level statements, is actually the same, almost the same as this classic console app behind the scene. Top level statements template is actually designed for the simplicity and was introduced with C#9. Template is actually for beginners so that you do not need to worry about these line of codes at the initial stage. You are now far away from the initial stage, so this is a perfect time for you to start using this classical template. Classical template is also good for the larger applications and object-oriented applications. However, there is another reason, and because of that reason we are discussing both the templates in the method section. As you know, we are in the method section of the course, and that reason is methods behave differently in both the templates, and this is what we are going to learn now, how the methods behave differently in both the templates. Methods in the top level statements are actually called local functions. In the official documentation, the term local function is used for the top level statements, and this is because of behind the scene scenario. All the methods which we write inside the top level statements template are automatically placed inside the main method. Main is also a method. That means after a compilation, we have methods inside the main methods. And that's why the methods in the top level statements are called local functions. Let's now create a method which simply adds two numbers, double number 1 and double number 2, like this. Console, WriteLine, and let's print directly the sum of both the numbers. Now as we run this program, this addition method is automatically placed inside the main method. Now the same method, let me just copy the method. Here in the classical template, the methods are placed outside of the main methods, inside of the program class. So here we have the class block. So we can place our method here, or we can place our method somewhere here. This addition method does not belong to the main method. It actually belongs to the program class, whereas in the top level statements, this addition method will automatically be placed inside the main method, or you can say this addition method belongs to the main method. It is something very important to understand the difference between local functions and the methods. Methods in the top level statements are actually called local functions, and now we know the reasons. And the methods in the classical console application are just methods, and they belong to the program class. Now because of this belonging to the program class or the main method, there are some important features which add and subtract to the methods, such as in the classical app we can overload our method. Overload means you can have another method with the same name but different number of parameters. For example, this method is going to add two numbers. We can overload this method with another parameter, double number 3. Now we can call both the methods in the main program like this. The first method with 2 arguments, and the second method is 3 arguments. Another thing that we need to add in the definition of our methods is the access modifier. Access modifier like static, private, public, etc. They actually controls the accessibility of methods or properties in the program file or in the same assembly or in the different assemblies. So according to the programming's rule, a static method cannot access non-static components. So we need to add the static keyword before the definition like this. So here you see in the classical template, we can overload our methods. Methods overloading is an important term, and you will learn more about it in the object-oriented programming. You will see the proper use of methods overloading and constructor overloading in the object-oriented programming. Now, this overloading is actually possible because our method belongs to the class. We cannot overload our method here in the top level statements. Let's now put another parameter. You see here, as we try to overload our methods, our program complains, and what does it say? It says a local variable or a function name addition is already defined in this scope. So methods overloading is something which is not possible if you are using top level statements. Let's remove this overloaded method. However, in the top level statements, we can do another interesting thing just because of the culture. In this template, we have methods inside method culture. So we can nest or hide methods inside the methods in order to introduce some encapsulation or hiding. Let me give you an example for more understanding. This is our addition method. It takes 2 parameters and performs the addition operation. The method performs the main operation, and as well as it is exposed to the user. So what we can do instead, we can call another method that performs the addition, and that method is inside the addition method. So our addition method has now another name. Let's say wrapper addition, and inside that method we are going to code another method which actually gonna perform the sum. This sum method is now totally hidden from the outside.
All we need to do is just call the wrapper addition method, and this method will further call the sum method in order to get the sum. So here in the WriteLine, we simply call the sum method like this, and to pass the parameters, we need to call the addition method. Let's pass the parameters 10 and 20. Let's run the program and check the output. And so you see the result in the console, right? Now, one last thing, the final thing before we wind up this lecture. The sum method is a child method. We can call it a child method, whereas wrapper addition is the parent method. The child method has access to the parent data, variables, and parameters. Now, for example, if the parent has a variable like this, name max, you can access this variable inside the child method. Now, because of this access to the parent data, child can even modify the values. For example, we can assign a different value to the first variable and another value to the second variable. This thing gonna produce the wrong result. We know that, and this shouldn't be allowed, but we cannot do anything to fix it. If we turn the child method as static, then the method will be logged, totally logged. Static methods cannot access non-static data or variables. If we, let's say, turn even the parent method static, things will be the same. So we have to give child method access so that it can work on the parameters or the parent's variable. Adding static to the main method's definition is a good idea. Using static in the method's definition, you can stop this method to access and modify data which is outside of the method. This is the best practice to always have static in the method's definition. If we have any variable outside of the method, let's say string username Peter, this variable is not available inside the method. Let's say if the method try to access the variable, you'd see the error here. And what does it say? It says a static local function cannot contain a reference to the username. That simply means you cannot access the non-static data or the variables inside the static method without having a reference. So using the static keyword in the method definition, we can stop the method to directly access the data from the main application or the main program. Data can be passed to the methods as parameters, but the methods have no direct access to the data. So my friends, that was a comprehensive lecture on top level statements versus classic console app. Now we know the differences between both the applications and the behavior of the methods. It's now time to wind up this lecture. The next lecture is the last lecture on methods section, and we will talk about generic methods. I will see you there. Thanks for watching this one. The last lecture was all about learning differences between the top level statement template and the classic console template. We learned the differences between the templates and methods behavior in the templates. Like I told you in the previous lecture, this would be the last lecture on the method. When we started learning methods, I told you we would need approximately 10 lectures to cover all the concepts. So this is our lecture number 11 on methods. We did 10 or 11 lectures only to cover methods in C#. One last thing that we need to cover or understand is the use of the generic methods. It's a very important concept and will help you to understand generic classes when you start learning object-oriented programming. Generic methods are very interesting, and by using them, you can better utilize and reuse your code. Let's learn how do we code such methods and the use of the generic methods. We start with a normal method that simply prints a value. Method takes a parameter. Very simple method, and the job is only print the parameter value in the console. Now we can call this method in our main program. Send a value like this.
In the output, you will simply see the hello string. Now, this print method is only capable of receiving a string value. Now, let's say I also want to print an integer number, so I cannot use this method. I need to write another method like this. Now I'm going to change the type. Here you also see the concept of methods overloading, which we discussed in the last lecture. Both the methods have the same name but different parameters. However, the operation is the same. Now we can call the second print method like this and can pass an integer value, let's say 45. After that, we have another requirement and we also need to print character value. So we are forced to create another method for that can take character as parameter, and now we can call this method as usual and can pass a character to the method. So we have three methods, overloaded methods, and all of them doing exactly the same thing. The only difference here is they are working with different types. Is there any way to improve this code so that a single method become capable of receiving different types? The answer is yes. We have generic methods which can work with different types. So a generic method is simply a method that can work with different types using type parameters. Instead of having multiple methods for string, integer, and character, we can write a single method that works for all the types. And that method is generic. Let's see how do we code such method. I'm going to remove last two methods. Instead of this static and constant data type, I'm going to change it with a type parameter t. At the same time, right after the name of the method, I will open and close angle brackets and will provide the same type parameter inside the brackets. Now you will notice we have no error in our program and all the calls with different types are simply accepted. Let's first run the program, check the output in the console so that we know method is capable of receiving different types. And so you see the output, right? All the parameters are received by the methods. Now, what does it mean? Character t in the basis and t instead of the data type. This character t is actually unknown data type and it will automatically be changed by the compiler at runtime based on the type of the parameter. In the first call, the parameter is a string, so our compiler is actually calling this method like this. In the second call, the parameter is integer. Our compiler is calling this method like this. And in the third call, compiler will call the method like this. In the first method call, this character t is replaced by the string, and so this one. In the second call, character t is replaced by integer, and in the third call, character t is replaced by character. This is what happens in the background and everything is decided at runtime. You do not need to mention the data type here with the calling as long as you are working with a single parameter. Right? So we can simply remove the types. So this is a basic structure of generic method. Let's move on. Now we have multiple parameters. We have value 1 and value 2. And in the WriteLine, we need to update our variables. Now this method can receive two parameters, but the type must be the same. That means we can send another parameter of the same type like this. And in the background, the calling should be like a string. So this t is replaced by the string and they will get the same type. The second call will also do the same. We just need to put another parameter, let's say 60, and the same is here with the third call. So that was an example of multiple parameters of the same type. Now the question is, how do we do when the parameters have different types? For that, procedure is the same. We will choose another type parameter character. Instead of t, we can use such as character u and then the name of the variable, for example, number. And finally, we will add the type character to the definition. Now we can give type parameter u a different type. So in our call here, the second parameter is integer, and we can now pass an integer value. Let's say 45. A string is for type parameter t, that means these two variables are strings, and the integer is for type parameter u, that means this number variable is now an integer variable because of this call. As you know, the types parameter are initialized at the time of calling, that means there is no predefined type order. Now let's say if I put another integer number here, no error in the program, and this time our calling looks like int. So both the type parameters are initialized with integer. In the third call, let's say I also want to send a string as the last parameter. So I can simply put a string value here like this. This will be fine. And in the background, it will look like this. This is how we can code parameters of different types. But remember one thing, types are decided at runtime. Therefore, there is no predefined types order. Let's move on. Another thing that we need to understand is applying operations on the type parameters. Applying type-specific operations are simply not allowed on the type parameters. The reason is quite obvious. The compiler doesn't know the type of these type parameters until the program is running. For example, these two types are string because of this call, this first call. String literal has the length property, which is type specific. We can apply length property on string type, but not on the number type because property is type specific. Let's see what will happen if I try to apply length property on the string type. Our program shows an error. As you can see here, the error list says the type parameter t does not contain a definition for the length property. That simply means compiler doesn't know the type of this variable until the program is running. That's why we cannot apply type-specific operations on the type parameters. The same is true with the number type. Now, for example, the plus operation is a type-specific, and if I try to add number with the number, our program will simply complain. So this is something you cannot do with the type parameters. You cannot apply type-specific operations. What is the solution now? The solution is find another way to do that. Overload the methods. If you want to apply type-specific operations, you can simply overload your methods just like we had before. Now, the last thing here before we wind up is the return value. The generic method can also return a value, and in that case, we need to specify the type parameter in the return part of the method's definition. For example, I wanna t as a return value. Now I can get type t value as return from this method. For example, return value 1 like this. And when we are calling, we need to assign the value to the same type of variable, a string result like this. And now we can print out the value in the console. On the other hand, if I want to get the number back from the method, I will change the type value from the return section of the method's definition, u, like this, and the variable name is number. I need to update the data type where I will be receiving the result, and that should be integer. No error in the program. As we run this application, you will see 45 in the console. Let's run the program and check the output. And so you're seeing the output 45 in the console. So my friends, that was generic methods in C#, and you will get more understanding of generic methods when you start learning object-oriented programming. You will learn to code generic classes containing generic methods and the use of generic classes. This is now end of the methods section. We have learned each and everything related to the methods in C#. It's now time to move on with the course and cover some other important concepts. In the next lecture, we will discuss another concept which is called tuple. I will see you there. Thanks for watching this one. In our last lecture, we learned to code generic methods, and that was the last lecture on methods in C#. As we have now very good understanding of methods in C#, it's time to move on. The programming tool we are going to cover in this lecture is called tuple.
So let's see what tuples is and how we can utilize it in our code. So our topic in the lecture is tuples. Here we have the code from the previous lecture. Let's remove the code, clean the code file, and now tuple is a special programming tool, and I think most of the languages have tuple. I never used tuple in JavaScript, so I'm not sure if JavaScript has tuple or not. But C Sharp, Java, and I think Python, all of them have tuples. Using tuple, you can create a group of multiple values, either of same data type or different data types. You can then assign that group of values to a single variable. Let's first learn the syntax of the tuple. How do we create tuple in programming or especially in C Sharp? And then we will code some practical examples. In order to group tuple values, we always use a small parenthesis, and inside the parenthesis, we put several values. Values are separated by a single comma. For example, the first value is a string value, my name, and the second value is also a string value, my second name, and the third value is an integer value, let's say number 90. This is called tuple literal, which groups the values. Now this literal need to be assigned to a variable. Let's say our variable name is values. Values is the name of the tuple variable, and these are the components. Now the question is, how do we tell the compiler this values variable is of tuple type? If we had a normal primitive variable like a string, so we would have written like this, string in the beginning or integer like this. But here, the case is different. A single variable has three values and they can have different types. So to tell the compiler about the values, we create a group of data types and put them in the same order as we have on our values. For example, string, and integer. So here we are going to create a group of data types, string, and integer. This is how tuple is created in programming, more specifically in C Sharp. If I put another value here, let's say I put a boolean value, true, and a character value, C, I must update the data type list to the left in the same order. A single value containing 5 values of 4 different data types. This tuple is now ready and it can be used. However, this syntax of creating tuple can be further simplified. Instead of having a list of all the data types in the same order, we can use the keyword var. Keyword var is a special keyword in C# which is used to initialize a variable based on the assignment. For example, if I have a variable like this, using the integer keyword, I am telling the compiler in advance the type of the number variable is integer. But if I change the int and put var instead, now the data type is decided based on the assignment value. Value is integer, so the type would be the integer. If I assign, for example, string, the type of this variable would be the string. So we can get the advantage of the var keyword in this case. So we can also write var. Both the lines are actually doing the same thing. This is explicit. We are doing this, and here we are letting the compiler do the same thing. That was all about how to create tuples. The next thing here is how do we read out the values? The compiler automatically assigns item x type index to each value. Here x, it starts with the 1. For example, the first value here is Salar is item 1. The second value is item 2, and so on. And I think the item is with a uppercase letter I. Now, for example, if I want to read out the first value, I will call my tuples values item, and here comes all the valid values I can use. 1, 2, 3, 4, and 5. I have 5 components. So item 1 is the address of the first value. We try another value, values of items 5. Let's run the program and check the output. You will see Salar and C
in the console.
And here you see the output, right? Sala and C.
And when the item index is invalid, you will get a compile time error. You won't be able to compile your program properly. For example, item index 6 is an invalid syntax. You can see the error indication and it's a compile time error. It simply says the tuple does not contain a definition of item 6, right? Now, if you do not want to use this default naming like item 1, 2, 3, you can name your values in the tuple as you like. For example, first name, and here we will put a collar. So value Salar has now identifier first name, and we can even access this component or the value using this name. Now, for example, instead of item 1, I can write first name, and you will see the same result in the output. The same way you can assign a name to all the components. That was all about the creation of the tuple and accessing the values. Now we will talk a little bit about the usage. The most common use of the tuple is to get multiple values returned by the method. You know, a method can only return a single value. In order to get multiple values changed or updated by the method, we use reference or out parameter. We do not get any return when we use reference or out parameters. We only get our values updated. But with tuples, we can have a method that can return multiple values. Let's have an example of that in comparison with the out parameters. In a program, we have three variables: integer a with the default 0, string b with the default empty string, and bool c with the default false. Now we write a method which will initialize these variables using the out parameters. So the method's definition would be look like static void fill these values out integer a, out string b, and out bool c. And now we can initialize our value. Let's say the integer value is 100, the string value is hello, and the boolean value is show. We can now call the methods here after the variables, fill these values, and can pass all the values out A, out B, and out C. Now after this calling, our variables will definitely be initialized and will get these values. So we simply got our values updated, but there is no return. The tuple can make the difference, and we can have a return of 3 values. So a method with tuple return gonna look like here you see a method with tuple return. Method's name is return 3 values. It takes 3 parameters, initializes all the parameters, and then returns the tuple or all the values. Calling to this method is also very straightforward. We are gonna receive a tuple. Now let's say we do not know the structure of the tuple we are going to receive. So the best option here is use the var keyword. So I'm going to use the var keyword, var tuple values, and now I will call the method and pass out values A, B, and C. And now in the console we can print out all the values, tuple values, item 1, item 2, and item 3. Let's now run the program, and you will see the values are initialized by the tuple method. In the output, you will see 100, hello, and true. And so you see the output, right? 100, hello, and true. So this is a very common use of tuple in programming to get multiple values as return value. Now we know what tuple is and where to use it in the code file. It's now time to wind up this lecture, and in the next lecture, we will study nullable types, another very important concept to learn and understand. I will see you there. Thanks for watching this one. In the last lecture, we talked about tuples, very interesting tool in programming, and now we know how to use it and code it. In this lecture, we are going to discuss nullable types. It's also an important concept to understand, but the concept is very straightforward. We already have background knowledge to understand nullable types in C#. Let's have some knowledge and discussion about nullable types. First, we need to clean our code file. So here's a code we wrote in the previous lecture. So let's remove all the methods and clean the main method. Like I said, we already have background knowledge to understand nullable types. In the method section, we talked about value types and reference types. You remember this slide, right? It's a slide from the previous lecture, and when we discussed that slide, we said data types are divided into two broad categories. The one is value types and the other is reference types. In the value type section, we have data types like integer, double, boolean, date and time, and struct. Whereas in the reference category, we have classes, array, string, list, dictionary, object, etc. We also know the reason why the types are divided into two categories. I am not going into the detail. We have already discussed that previously. Having that background in mind, we can grasp nullable types easily. We have a very special value in programming which is called null. As you can see, the color of the null is blue, and all the reserved keywords in C# are usually displayed in a same color. So in this IDE, all the reserved color are blue. As you can see here, blue, 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 and blue. So null is a reserved keyword and it's a value, right? So null is a value. The question is, what does this value represent? Null actually represents nothing. Null means no memory reference. It's very important to understand the meaning of a null. Null simply means nothing, no memory reference. We cannot compare null with empty. Empty means something is there which is empty. For example, a glass which is empty, but glass exists. When we apply the null concept, that simply means there is no glass. Empty or non-empty is not a discussion in case of null. Null simply means nothing. Now, this null value can be assigned to some types and cannot be assigned to other types. For example, if I have a string variable, let's call it name, this variable can be assigned null value. However, if I have an integer value, let's call it number, I cannot assign a null value to a number type or the integer type variable or the data type. Our program has error, and what does it say? It says cannot convert null to integer because it is a non-nullable value type. That simply means integer is not nullable, whereas string is nullable. So nullable is simply a type that can be assigned a null value. And all the reference value types in C# are actually nullable. That simply means you can assign a null value to a class object variable, a string type, array type, etc. On the other hand, value types are not nullable. You cannot assign a null value to integer, double, a structure, a date and time, etc. Let's have more examples. Array is also a reference type. That means we can assign null to that type. You see, null is acceptable. Boolean. Boolean is value type. Here we have a Boolean variable, and we cannot assign a null value to that type. So we now know where to assign null value. In C#, we have a mechanism to change a non-nullable type into nullable types. And for this conversion, all we need to do is just put a question mark right after the data type name. For example, integer question mark
bool, question mark. Now you see the null is simply accepted and there is no error in our program. It's interesting, right? A boolean type and a number type can also assign null value. This question mark that you see here is actually a shorthand of applying nullable to the non-nullable. It is a more common syntax to apply nullable, but in reality, we are actually calling system nullable in the background, or the program is calling or applying system nullable. Just for the reference, I can show you how to apply system nullable. And here is an example. Let's say our variable name is another number. This syntax can also be used instead of this question mark. Question mark is just a shorthand of this syntax. Now the question is why we need that. Why do we need to convert non-nullable types into nullable types? The answer is to control dynamic values as a result of dynamic call. For example, we make a call to the database to get a numeric value, or we make a call to an API to get some response. In such cases, most of the time our program is running, and at runtime, when a null value is returned for the number type or the integer type variable, then these variables won't be able to handle that value. It's a very serious bug and our program eventually can crash. So we can activate the nullable behavior on the non-nullable types in order to get the null value in certain cases. However, the null value cannot be processed. So in a program where you have a risk of getting null value, you will always check your variable for the null or for the real value before you start using it. In order to check the null value, C# provides has value property. Let me give you a proper example of receiving a null value by a call. We will simply call a method that returns a null value, and then we will use the has value property in order to further investigate our variable. Let's say we have a method and the name of the method is database numeric value. Inside the method, we have a variable numeric value, and this variable can be null. So we are activating the nullable behavior on the variable, and now we will simply return that variable to the calling position. As this variable can also hold the null value, we need to activate the nullable behavior on the return section of the method declaration. Now in our program, as we call the method database numeric value, and we know that in most of the cases value is number, but it can be a null value. So in order to receive that value, we also need to activate the nullable behavior on the variable. Now, before using this result variable, it's very important we investigate it because it can have null value. At this point, the return value is a numeric 10, but it can be null. It's a database call and we exactly don't know. So in an if statement, we will call the has value property on the result. I guess the has value property returns a true if the value is something else other than the null. And if the value is null, we will simply get a false and come inside the else statement. And here we can publish a message. The value is null. And if there is some value, we can simply use this result variable. Let's say we simply wanna multiply the result with result. Let's now run the program and check the output. As we know, the return value is null, so we would see this in the console. The value is null, and so this is output, right? The value is null. When the value is not null, value is numeric. Let's say 10. 10 is a value other than the null value, so has value is gonna return a true, and so we can process our variable. Let's run the program, and now you will see 100 in the console. And here is output, right? 100. Now, one last thing before we wind up this lecture. Instead of has value property, we can also use the normal not equals operator and compare it with the null, right? So this can also be done. This is actually the most common way to check for the null value.
So my friends, it's now time to wrap up this lecture. In this lecture, we learned nullable types and how to convert non-nullable types into nullable types. The next lecture is actually the continuation of nullable types, and we will talk about some important operations which we can perform. I will see you there. Thanks for watching this one.
The last lecture was all about non-nullable and nullable types. We learned the differences and also looked at converting the non-nullable types into the nullable types. This lecture is a continuation of the previous lecture, and here we are going to learn some operations which we can perform on nullable types or the null value. In C#, there are some operators which we can use to check for the null value and then can decide whether to apply default value or not. There are three operators, they have different names. We are going to explore them and learn them one by one. Here is the code we wrote in the last lecture. We have a method database numeric value which can return a numeric value, integer value, and can also return a null value. We are going to update this method to make it work for the string instead for the integer. It will make more sense. And of course, the name of the variable. From the main method, I'm going to remove all the code. Let's now learn the use of the first operator. First operator is actually called null collecting operator. It is coded with two consecutive question marks. When you see two consecutive question marks in any C# code, that simply means null collecting operator is used. This operator is for assigning or providing a default value when something is null. When the value is null, you can use this operator to provide a default value to your variable. Our method is set to return a null value. We are going to call this method like this, database numeric value. And right after that, in a WriteLine, we are going to print the value in the console. We know that this method gonna definitely return a null value. However, in real cases, we have no idea either the value is null or valid. In such cases where the null value can be received, we can control it using this null collecting operator. If the value returned by this method gonna return a value. We know that if the value is null, we can apply a default value. Default value because null is received. As we run this program, you will simply see this output default value because null is received. Let's run the program and check the result in the console. And so you see the output in the console, right? Now, instead of assigning a value, you can also do something different here. You can, for example, throw an exception to inform the user. For example, throw new null reference exception, name of, and here comes the variable name. Let's run the program, and now you will simply see an exception is thrown with this name. You can have more description about the exception if you want. So you see exception is thrown, the exception name is null reference exception, and this variable is the reason for this exception, right? Let's now reverse the changes, and we are going to have our string back. So that was the null collecting operator. The next operator that we have on our list is actually called null collecting assignment operator. Null collecting assignment operator is almost the same as null collecting operator. It actually uses an assignment sign to provide a valid value to the variable. In programming, we code this operator like this, two consecutive question marks and then an assignment operator. Let's have an example. We have a string user name with the value null. So when the value is null, we can assign a default value. Let's say guest. This is how we can use null collecting assignment operator. If the value of the variable is null, this default value is assigned. Once a valid value is assigned, a value other than the null value then the use of this operator won't make any difference. Now, for example, at this line, username will initialize with this default guest string. Now, I am going to once again call the assignment operator with a value admin. The second assignment won't work because username already has a value other than the null value. We can check it out in the console. Let's find out the value of the username. And so you see the output, right? The value is guessed, not the admin. That was the null collecting assignment operator, which is used to assign a default value only once, which is the main difference between collecting assignment operator and collecting operator. Let's move on. Another interesting operator that we have is called null conditional operators, which is called using a question mark and a full stop sign or the period sign. This operator is also very useful and save you from some trouble. Using this operator, you can safely access properties and methods of an object which can be null or might be null. For example, we have a string variable message. It has a message hello like this, and now we are going to access the length of the message. Now, length is actually the property which we can call on the string. We can also call any method, for example, queue method like this. There's no issue in our program as long as we have a value that can be processed. When we run this program, you will simply see this message is returned in uppercase. Now, let's suppose instead of this valid message, we have got a null value. Now things won't be the same. As we run the program, our program will simply catch the exception because we are trying to call a method on the null value. And interesting thing here is that no error in the program in advance. The error is runtime error and you will only experience it when the program is running. So let's run the program and see what happens. And so you see in the background, we have an exception. Exception is null reference exception, and here you can see message was null. So to avoid this exception where the value can be null and you need to call any property or method, you will go for null conditional operator. And here we are going to put the question mark. Now our code is much better. No null reference exception is thrown. Let's run the program and check the output. And so you see, no exception is thrown. Our program is working perfectly fine. However, this is not the proper or practical use of null conditional operator. When the value is not null, there won't be any problem. But when the value is null, we need to take some action. And for that, we can combine null conditional operator with a null collecting operator. We can further extend this expression like this. And here we can write default value. This is the most practical way of using null conditional operator by combining it with a null collecting operator. Now you will see this value in the console. Let's run the program, check the output, and here you see the output, right? Default value. In the second case, when there is a valid value like hello, this value can easily be processed here, and the true upper is called on the value. So my friends, that was a detailed lecture on null operations. We have 3 operators we can apply to handle the null value: null collecting assignment, and null conditional. It's now time to wind up this lecture, and in the next lecture, we will work with the structures. Structures are advanced and you will learn to write more sophisticated and flexible applications. After structures, we will have a lecture on debugging, and after that, we will have a last lecture of the course where I will give you a guideline to take your programming skills to the next level. I will see you in the next lecture. Thanks for watching this one. This programming journey has been wonderful, I must say. I enjoyed creating content and teaching you guys how to code with C#. We have almost reached to the end of this course. We only have one programming tool left to cover, and that tool is called structure. After structure, you are completely ready to next step. And next step should always be object-oriented programming after the basic programming. We have covered all the basics one should know to start with the next level. Structure is actually the last topic we cover in basic programming before starting the classes or the working with the classes. Classes means object-oriented programming. Why do we do that? Because structures are lightweight class type. Structures work like classes in several different ways. One thing that we cannot do with the structures is family relation. There is no inheritance concept, and inheritance is the core concept of object-oriented programming. Inheritance, encapsulation, polymorphism, and abstraction. These four terms are the core concept of object-oriented programming. I have already told you in the introduction of this course, we will do part 2 of this course where we will study object-oriented programming and all the concepts. Just stay tuned, have a click on the channel. I will definitely publish my course there very soon. Let's move on and try to understand the structure in programming. Understanding structure and the use of the structure will help you a lot when you start learning classes, because the syntax of creating a structure and a class is almost the same. Both of them have properties, constructor, methods, and the objects are also created the same way. This lecture is gonna lay a foundation to that next level. First, in this lecture, we will learn to create a structure, and then we will create a complete parking house program using our structure. This lecture is gonna be lengthy, but you can take a pause whenever you feel yourself overwhelming or tired. Now, let's move on. This is our code from the previous lecture when we talked about nullable types. Let's remove the code and clean the code file. Our topic here is structure, so let's change the topic first. Before we start creating a structure, let's have a closer look on the namespace. Namespaces in C# are actually logical containers to group its structures and classes. Here you see we have a namespace. The name of the namespace is the same as the name of the project. It is a default namespace. This namespace has its own block, and inside that block we have our program class. The program class is actually inside this logical container. We will not dive deep into the namespaces, like how do we manage namespaces and the name conflicts. But fortunately, I already have a dedicated lecture about namespaces in C# where we discuss default and custom namespaces as well as avoiding name conflicts. So do check that lecture if you want to learn more about the namespaces in C#. So namespace is just a logical container that can have one or more classes or structures. Having this background of namespace, we can create a structure inside the namespace and outside of the namespace. When we create a structure or a class inside the namespace, they will belong to that namespace. And to use them somewhere else, we need to provide the namespace reference. On the other hand, if we create a structure outside of any namespace, it will automatically be owned by the global namespace. And that structure can be used anywhere in the application. I am going to create the structure outside of the namespace first. Later on, we will see how to place the structure inside of the project's namespace, but in a different file. That's going to be very interesting, and you might have feelings like we are doing something advanced, right? To create a structure, we have a struct keyword. We start with the struct like this, and right after that, we choose a name for the structure. Let's say our structure name is calculator, and then the structure block using the curly parentheses. As the name suggests, this structure gonna perform the calculator's operation. Now, a structure, just like a class, consists of two main things: variables and methods. Variables and methods together defines an object. An object in programming is something that has some properties and behaviors. For example, a car object. A car object has some properties as well as behaviors. Properties can be like the type of the car, like model, color, manufacturing year, etc. Behavior of the car can be like move forward, backward, turn left, turn right, switch on, switch off, etc. So in programming, for defining the properties for an object, we use variables, and for behaviors, we use methods. So that was a brief introduction of object, and I hope you got my point. Now coming back to the structure.
a structure or a class. Both of them are actually used to define an object. For example, this calculator structure will only define the object with the properties and the behaviors. Its structure will only work like a template, and multiple copies of the objects will be created here inside the main application. This is how the concept of a structure and classes looks like. They are just a template which document an object by defining its properties and behaviors. Now, this calculator object has two properties, or in other words, two variables. Properties are defined using the variables. We can write here properties. The first property here is number 1, and the second property is number 2. If we had a car object instead of the calculator object, then we would have put properties like private string color, private string number of doors, private string length, private string height, etc. These are the properties of the car. But for the calculator, number 1 and number 2 are the properties. Its structures can also implement encapsulation. That means you can hide your data outside of the structure using the private keyword. This number 1 and number 2 cannot be accessed inside the main application. With the public access modifier, you will be able to access number 1 and number 2 directly in your main application. Let me change it from private to public. Later on, we will change them back from public to private because it is not a good practice. We don't want our data to be exposed outside and to give the direct access to the sensitive variable. So now we have two properties in our calculator structure, number 1 and number 2, and both the properties are public as for now. Now, after the properties, we need behaviors. As we are coding a calculator application, so one behavior can be like addition. Calculators can add addition like this, and this method will simply return the addition number 1 plus number 2. Another behavior here can be like subtraction, which gonna return the subtraction of both the numbers. I am not going to add more behaviors like multiplication and division. We are good with these two behaviors. Our structure is almost ready to use in the main application. It has properties and behaviors. Now you will see interesting thing in the main application. In order to use this structure, we need to create objects. This structure is actually defining an object, not creating it. We will create the objects and utilize this entire template. In our main application, we are going to create a calculator object. The name of the object is calc1. This is a syntax of creating an object of type structure or type class. The name of the object is calc1. Its type is calculator. New means reserve the memory. And here we are calling a method which is called constructor method. We will come to that in a couple of minutes. Now, this variable is actually called an object, and it is automatically assigned a whole template copy of calculator. That means this cal1 variable has own copy of number 1, number 2, and can call the addition and subtraction method by its own. Now, using the object variable, we will initialize number 1 and number 2 variables. Calc1 dot operator is used to access a member of the class or the structure. Here, seeing the number 1 is shown here. Choose the number 1 and assign a value. Let's say 10. Calc number 2 value 20. After this initialization, using the same variable, we can call the addition method like this, and this method we are calling only for this object, this method, and it will return the sum of both the numbers, which is in our case 10 and 20. Let's run the program and you will see 30 in the console, and say 30 in the console. Okay, now we are going to create another object like this. The name of the object is calc2. Let's update the name like this. Two different objects of the same template or the same structure. Both objects will receive their own copy of this
template. This is interesting. They are using the same variables and calling that same methods, but they are working on their own copies. Let's now call subtraction method instead of the addition. Subtraction like this. Let's now run the program. You will see the output, some output in the console. And so you see the addition and the subtraction. The same way you can create many such objects and each object will receive its own copy of this template. It's a very important concept to keep in mind always while working with the structures of the classes. Structures and classes are just templates and they are used to define an object. They are used to document an object. Let's move on. Now we will make this structure more advanced and practical. Our variables are public and that's why we are able to access them directly in the main method. However, in real scenarios, we do not expose our data members or the variable. And for that, we enforce or implement the encapsulation using the private keyword. As we turn these variables to private, we lost the connection or the access. As you can see, our program has no access to the data members or the variables because of the protection level. All the variables are simply inaccessible. What do we do now in this case? How do we initialize our data members? The most common way to initialize private data member is make use of the constructor. Constructor is a special method. As you can see that it's a method. How do we know something is a method? You know the answer, right? A method must has a name and right after the name, parenthesis, small parenthesis. Whenever you see such thing in programming, that means you are dealing with the method. But this method is a special method which is called constructor or default constructor. A constructor method is always called at the time of the object's creation. We cannot create an object without calling the constructor method. It's a part of the syntax. And the method can be the default constructor or the custom constructor. Now the question here is we are calling this constructor method on two different places, but where is the definition of this method? We don't see that method in the calculator structure. For example, if I right click on the method and then choose go to definition, I will be diverted to the calculator structure. That means methods definition, constructor methods definition is somewhere inside this block. We do not see that. This thing is 100% true. We have the definition of default constructor inside this structure. The same concept is applied on the classes. Every class we create has a default constructor. But that constructor is always hidden until unless we do not need it. So a default constructor is there and that's why we are able to call it. The constructor method is not the same as the normal method. For example, this is a normal method. Subtraction is also a normal method. Constructor methods have a couple of special properties. The first property here is that the name of the constructor method must always be exactly the same as the name of the structure or the class. That was the first property. The second property is constructor never returns a value. That means we are not allowed to put any data type in the definition part. Now we need that constructor. That's why we are going to program it or bring it in our code. And the constructor is default constructor. This is how the default constructor looks like. Public calculator. That's it. What you see here is a default constructor. It doesn't do anything, but it is required in order to create object variables. When we have coded the default constructor or brought it back in our code, so we can only use it to initialize our variables with some default values. Now, for example, we can initialize our variables with some default values. Number 1 with 0 and number 2 with 0. Now, at the time of the object's creation, both the variables will be initialized with 0. Let's make things a bit more interesting. Instead of 0, we are initializing it with -1, right? We need to remove this code here. It won't work. And this one, it won't work. So what we're doing, we are creating two object variables and calling the methods. As this line of code is executed, this constructor method is called and variables are initialized with the -1 value. There is some value in the variables. As we run the program, you will see some output. Addition of -1 is -2 and subtraction would be 0. Let's run the program and check the output. And so you see the output in the console, right? Addition result and subtraction result. That was simply a proof that our variables got initialized by the default constructor. Now, the default constructor is not so helpful. It can only be used to initialize our variables with some default values. The real use of the constructor is actually with the overloading concept. You remember that concept? We can overload the constructor and can then use our custom constructor at the time of object creation. Overloading of constructor brings more flexibility. As we have two numbers and we want to initialize them with the real values at the time of the object creation, so we can overload our constructor calculator with the two values, double number 1 and double number 2. And now we can use these parameters values in order to initialize our real variables, number 1 and number 2, like this. Now we can call our custom constructor instead of the default constructor at the time when we create object variables. So at the time of the creation, we are going to pass the values, for example, 10 and 20. And here we are going to pass the values, let's say 20 and 89. Now our program will automatically call a constructor that can receive two parameters. And here we have that constructor. And the values are further assigned to our data variables. As we run the program, you will see the proper output 10 plus 10 and 20 minus 89. Let's run the program and check the result. And so you see the output in the console, right? 30 and minus 69. So my friends, that was all about the structures. Now we know how to document an object using this tool. Now we are going to develop a demo project using a structure, just like I told you in the beginning of this lecture. Using the structure, we will document a vehicle object. Vehicle object will have two properties, type and registration number. Then we will have some behaviors in the structure. Behaviors are actually the methods, such as get information, get only the registration number, get only the type, etc. And we also need overloaded constructors so that we could create an object of vehicle type in our main program. In this demo project, we will take our programming to the next level. We will create the structure in a separate file, which is more practical. Here, you see this calculator structure directly inside the program.cs file. We can also have a structure in a dedicated file. And this structure is actually outside of any namespace. Now we will code a structure which shares the same namespace. Classic app. Let's start with the preparation. We will prepare our project. Right click on the project name and select add. And in this small window, you can choose new item and then a class file. And here we have a shortcut. You can also choose class file directly. Let me choose the first item, new item. It will open a window with some extension templates. And here we are going to choose our class file. We can name our class file as vehicle structure, like this. Now add the file. You will see the file is added in our project in a couple of seconds, and here you see the file. It's a class file, and our program will automatically create a class inside it, which is the same as the name of the file. We do not need a class. We are going to code our own structure. So remove the class here and remove all the using statements. Now you see we have a namespace classic app, and inside that namespace we are going to create our structure. The name of the structure is vehicle, like this. We do not need to include this file, vehicle structure file, into our program.cs file. Both the files, program.cs and vehicle structure.cs, are the part of the same project, and they are using the same namespace. So that means they can communicate and find each other. Now, for example, in our program.cs class, we will start first with some cleaning work. Let's clean everything like this.
Let's try to create an object of the vehicle. Here you see our program is suggesting vehicle, which is a part of the classic app namespace. As you can see, the structure has a reference classic app. So our structure is vehicle. Let's say the vehicle is VH and new vehicle. No complaint, no error. So we can have our structure in a separate class and can use it in our main application. Now let's start with the structure. We will have two properties. The first is string type and the second is string registration number. Now you see I did not mention the private keyword like this. When we do not mention the private keyword, our program will automatically apply the private access modifier to our variables. Private is the default access modifier, but for the purpose of having good readability, we are going to write private here. Now we are going to create a constructor, default constructor, public vehicle. This is our default constructor. We are not going to use it. We will use our own custom constructor, public vehicle, string type, and string reg number. Like this, it's gonna initialize our variables. So we have this constructor which we are going to use in order to create several objects. Now we are going to code some behaviors, and behaviors are actually the method. The first method or the behavior is return only the type. We can call this method get type like this, and this method will only return the type. Another behavior get registration number like this, and it will simply return the registration number. Another method, very useful method that we need here is, missing a parenthesis, return the complete information. We can call this method string get vehicle information like this. So these are the three methods we're going to need in this structure. Get vehicle information going to return the complete information of a vehicle, and when we are only interested of get type, we will call this method, and for the registration, only the registration, we will call this method. Let's say you are going to implement a search operation in your program, so you will definitely loop through all the registration numbers. Types can be the same. Several vehicles can have the same type. For example, several cars or several motorcycles, etc. So now our structure is completely ready. We can use it in our main application. So in our main program, we are actually going to save multiple vehicles. That means we need a data structure. Now the question is, what type of data structure we need here? Do we need a string data structure or a string array, integer array, or the object array? The answer is we need a data structure or an array or a list that can work with the objects. So a data structure that can work with the objects we need. Another question is what type of objects we are gonna save in the data structure. So the answer is here, we are going to save vehicle type objects. So vehicle is actually the data type for the data structure. So in our main program, we will start with the list. I'm going to choose a list. List is flexible. And now the data type here is vehicle. The name of the data structure is parking house and new list vehicle. So this parking house list can simply save the objects of type vehicle. For example, we are going to create a vehicle V1, new vehicle, and the type is car. The registration number is ABC123. Let's now create another vehicle, vehicle number 2. The car type is motorcycle, and the registration number is ABC111. So here we have two objects for two different vehicles. Now we can use this parking house list in order to save these objects. So on the parking house, add, you know how to work with the list, V1, and parking house add V2. So we are creating vehicles and saving those vehicles in a data structure so that we can
work with the data programmatically. Once we have data in a list or an array, we can apply loops, we can do search operations, etc. This is the main concept behind the application. We need a data structure to save the objects. Here we are creating the objects and here we are saving the objects so that we could apply more operations. We will have a menu in our program like park vehicle, drive off vehicle, show all the vehicles, etc. And we also have a program that runs all the time continuously. So we start with a Boolean variable. Let's call it running and the value is true. And right after that, we will code a while loop, and to the loop, we will assign running. This is our application loop. Inside the loop, we are going to create a menu. Running value is true. That means we will definitely come inside the loop as the program runs. And here we will show a menu. After this menu, the user will provide an option. So let's code the option console write, enter option like this. The input source is console.readLine, and the output source is a variable option. And at the same time, we will validate the option. Option variable should have or must have a value greater than or equals 1, and option should be less than or equals 4. And we are going to save the result in a Boolean variable. Let's call it OK. So we have two different controls here. The type of the value should be integer, and here is the range, right? We have already covered such things in our previous lecture, so this shouldn't be a surprise for you guys, right? Now, this variable is important. If we have a true value here, that means we are gonna program further our application. I guess as we are inside of a statement, we are gonna open a switch statement like this, and we'll pass the option value to the switch statement. And now we are going to program some cases here. Case 1, break like this. There are 4 cases. We don't need the default case here. Remove that. Case 1, case 2, case 3, and case 4. These cases are corresponding to the menu options. The case 1 is for park vehicle, the case 2 is for drive off vehicle, etc. This part of the code should be very simple. We do not program logic inside the case statement. We will keep it simple, and from here we will call only a method. Let's say park vehicle. We are calling the method without the definition. We will use this light bulb option in order to generate the method. So here is the first method, park vehicle. It is gonna park a vehicle. The second option or the second method is drive off vehicle. Now we only need to program these 3 methods one by one. Let's generate the definitions of these methods. Click on the method's name. You will see somewhere a light bulb. Click on the light bulb, and here is the option generate method park vehicle, and here you see the method's definition. Remove the exception part here. Now click on the drive off vehicle, light bulb, generate method, and here is the drive off method. And the last one is show all vehicle. Once again, light bulb and generate method. Now we have all the 3 methods in our application. Let's start with the park vehicle method. In this method, we need some user input, vehicle type, and the registration number. String type, console read line, and string rig number, console read line. A message to the user, console write, and type like this. Once again, console write, enter registration.
As the user provide vehicles type and the registration, we will simply control the data or the input. If the data is not null or empty, the first one here is type and is not null empty registration. As you have data in both the variables, we will simply create an object of vehicle type and then add that object to our parking house list. Parking house is not accessible here, and we know the reason. We are working with the classic app, and parking house is declared inside the main method, and the methods, as you know, belong to the program class. So the ideal place for the parking house list is program class. And another modification we need to do here is method is static. Static methods cannot access non-static data members. So we are going to make our list also static. We know all these stuff, right? Now you see parking house is accessible here. Call the add method, and here we are going to simply create a vehicle object. Calling that constructor, we don't need to create a separate variable and then insert that variable to the add method. We can directly call the constructor using the new keyword. The first parameter here is type, and the second parameter here is registration number. That's it. So whenever we call this method, a new vehicle is inserted in our system. Before we call this method, let's code also show vehicles method so that we get some confirmation in the console. Show all vehicles method gonna simply loop through the list. Each component in this list is an object of vehicle type, and we have a method here called get vehicle information. So we are going to call this method on each object as we loop through this list. However, before we loop through the list, we are going to check the count property. That should be greater than 0. So that means we have at least one vehicle parked in the system. And now the for each loop gonna simply help us and print the result on each vehicle object. We are going to call get information method like that. Now both the methods are fully programmed. We can run our application and check the response in the console. Here we have the menu. The first option is park vehicle. We are going to select this option. Enter type, let's say car. Registration number is ABC111. Let's park another vehicle. First option, type is car. Registration number is ABC222. Select option again, and this time I'm going to park a motorcycle, and the registration number is ABC333. Right, so we have 3 vehicles parked in our system, and now I'm going to select the option number 3. And here you see the output, right? We have 2 cars, car 1, car 2, and we have 1 motorcycle parked in the system. And here we have the registration plates. It's great. The third down application option is also program. Let's press the 4, and here you see application is terminated. Now we have only one method left to program, which is drive off method. Let's code it. To drive off a vehicle or to remove vehicle from the system, we need registration number. So let's start with the message. Enter registration number to drive off the vehicle. Now save and read the registration number from the console like this. The next step is found a match. Do we have a vehicle parked in our parking system or not? The option that we have here is once again loop through the entire list, objects list, and then call the get registration number method on each object and compare that number with the user entry. If the match is found, that means vehicle is parked in our system, and then we can remove the vehicle from the system. We are going to start with the variable which is going to save the vehicle index. Let's call it index. And the initial value or the default value is -1. And now we are going to loop through the entire list. And this time I will use for loop
because we need the index value. So on the parking house dot count, this loop is going to iterate over all the objects. Now inside the if statement, we would write something like if the index of I dot get registration number equals registration number, that simply means we have found a match. And in that case, we are gonna update our index variable. We are going to just save the index of that vehicle which is matched and then break the loop. We do not need to further scan our entire list. Once we are done with the loop, so outside of the loop, we can investigate our index variable, and we would say if index is not equals -1, that means there is something valid index or the index of the object we want to remove. So using this index, we are going to call the remove at method. Into the method, we will simply provide the index we want to remove. That's it. Our drive of vehicle method is also programmed. We can also inform the user in case the registration number is not found. So to the if statement, we can simply connect the else statement. And here we can provide some message to the user like registration number is not found. Now we can run our program and check all the menu options one by one. Let's run it. Here comes the menu. Let's get on. We are going to park a vehicle. Car registration number is ABC123. Park another vehicle, and this time motorcycle. Motorcycle is not a vehicle. Let's just call it a vehicle. And the registration number is ABC111. Now we will see all the vehicles in the system, and the option we have is number 3. And here you see both the vehicles parked in our system. And it's now time to drive off car. So I will select the option 2, and I need to provide the car registration number. Let's say ABC123, and the car is removed from the system. Let's try to print all the vehicles again, option 3, and you can see we only have motorcycle in our system. In the last we have shut down application, we have already tested this option. It will work. You can see our application is simply terminated, or this while loop is actually terminated in the background. In fact, improvements can definitely be done in this program. For example, registration number should always be unique. We are not checking for that. Right now, our system can register more than one vehicle with the same registration number. So it's a kind of bug and it can be fixed. Another improvement is the type and the registration number format restriction. Our system can accept all the vehicles type, for example, cars, motorcycles, trucks, buses, etc. The problem here with the big vehicles is they can reserve or take more than one parking places. It's also a bug in the system which can be fixed. We can restrict our vehicle to some types like car and motorcycles. Registration number format can also be controlled. Registration numbers have different formats. You can write a method with the logic to control the format of the registration numbers you wanna allow in your system. You can also use regular expressions in your logic. They will further simplify the pattern matching work. Another very interesting bug here is shifting of vehicles in case when we drive off a vehicle. You know we are using the list, and list is a dynamic data structure. It adjusts the size when the component is added or removed. In our program, as we remove the first vehicle or the vehicle which is parked at the first location, all the other vehicles will automatically be shifted to one place upward. That means the vehicle which was parked on the second parking spot will be shifted from the second spot to the first spot as we remove the first parked vehicle. In reality, the system doesn't work like that. This can also be solved with some logic. For example, before using this list, we can initialize it with some string like empty. We can also restrict the parking places in the parking house with some constant value. For example, the available spaces in the parking house is 10, 20, 100, etc. And when the time comes for adding a vehicle to the list, we need to find the empty string. Empty string simply represents an empty parking spot. So do some experiments with this code. Take these improvements as a challenge or as an assignment.
So that was all about the use of the structure in C Sharp. You must have realized now that you can build a better application with this tool. It's now time to wind up this lecture. I will see you in the next lecture. In the next lecture, we will talk about breakpoints and debugging an application. I will see you there. Thanks for watching this one.
This is the last lecture of the course, last but not least. Before we start the topic, I must say it has been a wonderful experience to have you guys on board and teach you guys coding basics. Like I told you in the previous lecture, this journey has been wonderful and I enjoyed creating content for you. Thanks for the appreciation, liking the videos and following all the lectures. Now this last lecture is all about how to utilize the debugging tool and work with the breakpoints. Debugging with breakpoints is a wonderful tool in order to find errors and bugs in a program. What we actually do is we put breakpoints in our program and take the executions control in our hand. That means we can pause the execution at some point and then we can execute the application step by step and study all the changes taking place in the application. So let's see how do we work with this interesting tool. Here is the code from the previous lecture. We wrote a parking house program. So we need to clean our code file before we start with the breakpoints. Let's just start with a very simple program statement. In a program, we have a variable which is number initialized with 0. On the second line, we are going to increase our variable with 1. On the third line, I'm going to create another variable. Let's call it number 1. And to that variable, I will assign the value of the first variable or the number variable. And now we create a sum variable where we put the sum of number and number 1. Now, as we run this program, our variable will be initialized with the values and data in the variables will be changed from top to bottom. And somewhere we are feeling that the things are not right, we are not getting the right result, and we want to study step by step what is actually happening between these lines, how the data is being changed or modified. So what we actually do, we put a breakpoint. Breakpoint is simply a pause to the application. To put a breakpoint, we actually move to this gray area you see in Visual Studio. See this gray area, and as the mouse pointer inserts the gray area, you can see the black circle. This small black circle simply follows the pointer as you see here. This circle is actually the breakpoint circle. To put a breakpoint, all we need to do is just make a click here. As you make a click, the circle turns its color and become red. Now, as we run this program will be paused at this line of code. Now, the question is what will happen when the program pauses at this line of code? As the program pauses at the breakpoint, you will see two important additions in your IDE. One at the top, here you will see some arrows in order to execute your program step by step. And down there, you will see a local window where you can study all the changes and the modifications in your variables. So let's run the program and see what happens. And so you see, we are now inside the debugging mode. Our program simply pauses itself. And just like I told you, here you see the debugging control. In order to execute the statements one by one, this one step downward, step upward, and skip the statement. And this is where our program is stopped at this moment. And here is the locals window. In the locals window, we can see at this point the values in the variables. The number variable has 0, number 1, 0, and the sum is also 0. The type of the variables integer, integer, and integer. Now we are going to press the move down button, and I can see our program has successfully executed the first statement, and after the first statement, number is still 0. And here is the control. Our program stands right here now. I'm going to press the down arrow again, and now you can see after the execution of this statement, the value of the number variable is 1. Let's now execute the program one step further. Now you can see after the execution of this statement, number 1 has also become 1. Now we are on the last statement. Let's run the last statement. And here you see the sum is now initialized with the value of 2. So you see the interesting tool, right? You have more control on the execution of your application. You can step by step study the modification and all the changes in your program. Let's stop the debugging process. You can also put multiple breaking points. We're not going to put them. Now, in order to remove this breaking point, all you need to do is just right click, and here you have delete breaking point. You also have an option of disable breaking point. If I select the disable, you will see a hollow red circle, right? We're going to remove this breaking point. Most of the time, you will use the breaking points to find the bugs in your code, especially when the bug or the error is logical. Let's have another example, and this time we will code program with a simple bug. So in a program, we have an array named prices, and in the array, we have some values 100, 200, and 300. Now we want to write a method that calculates the sum of all the prices and returns that sum back to the main method. Here we are calling a method and passing our array as parameter. Now we will use the bulb icon in order to generate the method's definition. And here we have the method's definition. To set the sum of all the variables, we need a variable. Let's call it sum. And now we are going to add on all the values using the for loop. And once all the values are added up, we are going to simply return the sum to the calling position. I think we need to initialize the sum variable with 0. Now, in this piece of code, we have a simple bug, and that bug is actually this line. Here we have a bug. Right now, our code is very simple, our logic is very simple, and we are creating a bug deliberately. However, in real situations where we have complex logic, these kind of bugs are very difficult to find. As we run this program, our method won't return the sum of all the values. It will only return the last value. Because we are assigning 0 to our sum value on each round, so the previous value will simply be erased. Let's now print the value of the sum in the console. And we also need to change the name of the variable because the sum is already declared. Put the value in the WriteLine method. Let's run the program and check the output. You will see last value in the console. And so you see only the last value in the console, not the sum of all the values. We know that this is a method which is gonna calculate the value. Now the value is wrong, that means something is wrong with this method. So what we are going to do, we will simply put a breakpoint at the beginning of the method. This is the first line of code. And now we will run our code and study all the changes step by step using the debug tool. So here we have our debug tool. We are now debugging our application. At this point, we have an array, as you can see in the locals window, 3 positions in the array, and the data type is integer. The sum variable is also initialized with 0. Now send the program downward. We are now pointing to the for loop. Variable I is initialized with 0. And once again, down. And here we have a sum initialized with 0 once again. And now we will calculate. And here you see the value of the sum now has become 100. In the second round, our program should add this value 100 with the second value 200, but it won't happen because of this variable. So let's start the second for loop round. And here you see the sum has now become 0 because of this line of code. So instead of 300, we are gonna get 200, only the second value. Now we know this line of code is problematic. Here we have the bug, and all we need to do is just remove this line of code like this. So my friends, that was a lecture, important lecture on debugging code and the use of the breakpoints in the application. Now we know how to apply simple debug technique on the code. I will see you in the next lecture. We won't be learning any new programming concepts in the next lecture. We would rather be discussing way forward. I will give you the guideline and the topics you need to cover after this course in order to master C#. So I will see you there in the next lecture. Thanks for watching this one. It's now time to wind up this course. Finally, we are going to wind up this course. In this short lecture, I'm going to give you the guideline and the topics you need to cover in order to master C#. Let's move on. C# and the .NET, they are two different things. C# is a language, whereas .NET is a framework. Most of the time when we talk about, we usually use the term C#, .NET, C#, .NET. So why do we always combine C# and .NET when we talk about this technology? Although they are two different things. The thing is that they are made for each other. The only language for the .NET is C#, no F#, no Visual Basic, only the C#. So if you want to become a .NET developer, you want to work with the framework, then there is no other option than the C#. C# is the only language. In this course, we actually learned all the basics of the C# up to the structures. Basics of a language are foundation, and after that you can move on. You can learn more concepts and advanced concepts. Let's now talk about the C# mastery path and all the topics you need to cover after the fundamentals. The biggest next step after the C# basics is object-oriented programming. This option is actually non-negotiable. Object-oriented programming is the real development paradigm. Without deeply understanding this concept, there is no C# mastery. You should know this concept working with classes, encapsulation, constructor, inheritance, polymorphism, interfaces, abstract classes, etc. So this should be the first step after the basics. After the object-oriented programming, you will learn more about the collections and the use of generic. Other collections like stack, queues, etc. and the use of generic in object-oriented programming. Generics are used everywhere in real projects and provide type safety. The third topic here is file handling and serialization. It involves reading, writing text file, working with JSON, saving and loading objects, or in other words, you simply connect your programs to real data. Link is a very powerful tool and you have some basic idea about it, like how to use it with APIs, databases, and other business logics. On number 5, we have error handling. It involves how to work with exceptions or to create custom exceptions, work with the custom class, debugging, etc. And then we have asynchronous programming, the most important thing today, because every program today is using some kind of network calling. Every program which is using web APIs or working with file input IO or have user interface must have some asynchronous logic in the background. Without asynchronous tools like async, await, and tasks, we cannot program applications where the tasks can be delayed. For example, a call to the web API and the server is not responding. So in this case, the task can be delayed. And when the task is delayed or the response is delayed from the server, we need to find a way so that our application or the main application behaves in the same way as before, and the delayed task is simply put in the background. Using asynchronous, we simply tell our application when the task is delayed, move on, and when the task is completed, we will come back. That's it. On the 7th place, we have data access and databases. This is also something very important you need to know. Real applications work with the databases, and here you need to learn some basics about the SQL, structured query language, entity framework core, learn to perform CRUD operation, create, read, update, and delete. It's called CRUD operations. And you also need to have some idea about migrations, database migrations. So these are the 7 concepts you need to learn after the basics, but you will always start with the object-oriented programming. There are some other concepts or the bonus concepts like solid principles, unit testing, refactoring, etc. Once you have done with all these topics, you will simply choose a direction. You can stay with the desktop and web.NET development, and here you need to cover the tools like Windows Presentation Foundation and ASP. Or you can start learning game development using Unity. So my friends, that was all about C Sharp Mastery Path. Don't wait for long and start learning the object-oriented programming. I am creating a course on that and will publish that course very soon on the channel. So keep watching and thanks a lot once again for all the appreciations. I will see you somewhere in some other course. Thanks for watching or taking this course.